Fantastic. So, yep, hello and welcome to this is Intermediate R. Hopefully that's not a surprise to anyone, and that is kind of what they're expecting. So basically, either building on the introduction to R course that I ran a couple of weeks ago, or you've done previously, or people who have been using R for a while and just want some sort of tips and tricks. I don't know what tips and tricks in order to do some further stuff. And yeah, we're going to go all over the place today and tomorrow. It's going to be quite a packed course, much higher pace than the introduction. But yeah, we will try to be as gentle as possible. So, introductions. My name is Simon Wellesley-Miller. I'm a senior analytical manager in the Southwest Intelligence and Insights team for NHS England. Also a fellow of the R community. And as I said, my background, I think I've been using R, let me see, must be about 7 years now. Very much coming from sort of a very sort of non-codey place originally. But yeah, here we are now, so I'm not going to dwell on me. So we are all going to be using the cloud again, just so that we're not going to have any issues with sort of local setups and bits and pieces like that. So I can't remember how many of these people, how many of you have done the intro course where we did this a couple of weeks ago, and I think some of you might be sort of new to this as well. So first thing you want to do is use your browser to navigate to posit.cloud. Will take you to let me see, yeah, if you go to posit.cloud, it will take you to this screen. If you've already are a user, then you can click on yep, already a user. If you're not, you can click on the get started. Get started comes with lots of different versions. We want to use the lovely free version because we're cheapskates, so let's click on the free one, and then you can click on sign up. And that will give you the option to either put in email and details, or you can sign up with your Google account if you have a Google account. And I just find that the simplest. Obviously, if you already have an account, you can just click on your. I mean, I do it with my Google account, and that should get me into my workspace. As ever, please shout at any point if I am going too fast or you're getting stuck or you just didn't catch any of those bits and pieces. Obviously, if you get stuck at this stage, we're not going to get very far. So obviously, I've got a whole load of junk in my workspace already. If you've already used R Studio, you might have some bits and pieces in there, or you might just have a blank screen. That's entirely possible. And what we want to do is click on new project, and there'll be an option at the bottom there where it says new project from Git repository. So that's the one we want to do. And oh no, wrong one. Where is that? Have I just closed it? I have just closed it. So we want to do that. And what we want to do, I'll pop it in the chat, is type in this lovely URL. That goes into the URL of your Git repository. Goes in there, and then OK. And that will do some bits and bobs, and I'll deploy our project. Please stick your hand up if you're stuck or not got there. Hopefully that's relatively straightforward, and we will be deploying.
Can I ask one quick question?
You may.
Sorry. Just trying to get this option on RStudio desktop version. Will we be getting that as well? I tried looking for it, but I was unsuccessful. I mean,
it works in a slightly different way if you want to open. So if you were on the desktop, which here's one I prepared earlier, you could do, where are we? no, that's not the desktop. That's the desktop over here. Sorry, I just get confused there. We could do a new project here. Let's save that. And then there is an option to new project from you have to do lots of extra setup. I want to do a new project, directory name, intermediate, and then oh no, where is it to set up from a Git? Sorry.
If you go back a step, Simon, if you start making a new project from version control.
Version control, that's the one.
And then
Yeah. Sorry.
That you can put in, when you click Git, then you can put the URL in next.
Yeah, but I would thoroughly recommend using the cloud one, just so we're all in the same space, because it just makes things a lot simpler. Let's just move that one out of the way. So that's my backup one. So yeah, your cloud then should come up with something like this, which hopefully you are sort of aware of. And there's a couple of files in here, one called intertrain student version and one called intertrain. You want to pick the student version because you're a student. So Alberto.
Yeah, sorry, my laptop is super slow, so I get behind a little bit. So I click the new project, but it doesn't give me the option to basically insert the GitHub link. So I'm a little.
Are you on the cloud?
Yes, I'm on Posit Cloud.
Oh.
And
it should just have new project and then new project from Kira.
Oh, that's the mistake.
Got it there?
No, I click newer project. So
no problem. Yeah. So
thank you.
No problem. Where are we? Oh, this is really and we were on that one. So I need to give them dates or something. That would make much more sense, wouldn't it? Right, I'll go back to mine. So there are a couple of files in there. There is one called intertrain student version and there's one called intertrain. We want to use the one called intertrain student version. If we click on that, it will bring up some code for us. So let me just go back to where are we? The slides. This is really annoying. The to go between the tabs is, there we go. Right, so hope we got that up and running now. So just gonna run through very quickly what we're going to go through in the course. So we're going to run through some base R concepts as well, mainly because you might see them out in the wild. Obviously, generally we do teach the tidyverse because it's really nice and tidy. But actually, base R does have some really nice little bits and features in there, so it's worth knowing, and it's also just worth recognizing some of the base R stuff if you do that. We're going to do lots and lots of data wrangling on NHS type issues and bits and pieces. We're going to have a quick play with some SPC plots, and work out how we can pull in a library to do those. By the end of tomorrow, we're going to get a very basic understanding of functional programming, which is where you can design stuff where you can write your own functions to do stuff, which sounds really scary. And we're also going to get a very basic understanding of programming loops, which is where you want to iterate over sort of the same thing but with a different variable each time. So which is a very powerful sort of programming concept. So we're going to do that. Course rules. One is obviously we absolutely learn from making mistakes. So every time you make a mistake, that's a learning opportunity for the class. Let's share those mistakes and make as many mistakes as possible. I'm not sure where we are around screen sharing. I think it gets a little bit complicated about setting things up. But generally, if you can pop, if you've got a piece of code that doesn't work, pop it in the chat. I can run it up on screen and then we can all discuss and hopefully sort of bug fix it across us all. And like I say, make a mistake because that means that we can share that with everybody, and that's a really good way of learning. So more mistakes you make, more learning you do. So I'm not sure where we can share screens, but yeah, do pop them in the chat. And this course very much builds on, we'll do a section and then we'll do something else and then we'll do something else. And then sneakily I'll refer it, the answer will refer back to something we did like, you know, a couple of things ago. So if you get stuck, please shout, because it will mean that you'll find some of the bits later on trickier. So, you know, don't think, oh, I'll just skip this bit and I'll come back to it. Yeah, please don't do that, because you will get stuck on sort of the further bits. As ever, feel free to chip in, shout, cry, ask questions, tell me to shut up if I'm talking too much over a bit where I'm asking you to do some stuff, or whatever. You absolutely, you know, feel free to tell me to shut up, but it's totally fine. And we will record the session, as you know, and we'll make that available, as are all the course materials, etc. So yeah, I'm not going to bother with sort of icebreakers or whatever today. I think we did the old Pokemon last time. Possibly tomorrow we may, depending on where we are and see how far we get through tomorrow, maybe tomorrow I'll take some requests, or maybe at the end of the day, if there's still something you're going, oh, that's really good, Simon, I really want to know how to do X, pop that in the chat and we can either pick up and try to add a little module into that sort of the tail end of the course tomorrow, or give you some sort of resource of how to get there as we go. So without further ado, let's go. So this is the student version. There is an intertrain version here, which does have some answers to the question. So what we're very much going to be doing today is running some code. Let me just make my code a little bit bigger, which I can just do with Shift+, can't I? Yes, there we go. Make my screen a little bit bigger. What we'll very much be doing is running some code, seeing the outputs of it, understanding how that function works, and then there'll be an example for you to sort of have a go at doing it. There is a version of intertrain, which is the non-student version, which does have example answers. As with anything, there are many different ways to answer the question, and you know, no single way is correct. I'm constantly surprised when people do share some of the answers and they say they've done it in a different way, and you go, oh, I didn't even know you could do it that way. And you know, that's you know, it's not wrong. As long as we get the right answer, how you achieve that is not a thing. So big shout out to the help function, really powerful, and it's going to be really useful for you today. And a lot of this is trying to understand how that help function works. So a really nice thing that you can do is just click on a function and press F1, and that will bring up the help screen for that function. Very much recommend using it and reading it, and we will be sort of looking at how those help functions work, because they are really helpful. You can also press, you can also type in the console a question mark and the name of the function, and that would also bring up the help for that. Or you can search for it within the help tab here, or there's obviously Google as well, which is obviously really useful, or whatever. So anyway, so as you can see, we're going to be using various libraries. Yeah, Claire.
Sorry to butt in, Simon. Philip, who's joined us a little bit late, is struggling to keep up. So what I'll do is I'll take him out and I'll set him up and then bring him back in, if that's all right.
Yeah, no problem. So first bit of code we're going to do is, so if you remember previously, we wrote some code, and if we're calling in the tidyverse, we just called in the tidyverse, and as we introduced new libraries, we just added them to the top of our script. So what we've got here is a little bit of a funkier script, and we will definitely come back to this to explain how it all works. But basically, we're going to create a my packages, which is just going to be a list of the packages which we're going to use today. It's then going to compare those packages and check whether they've been installed or not. If they haven't been installed, it's going to install them, and then it's going to call all those packages. So instead of you know, for instance, this has obviously told us that we've got some packages. We can click on the don't show again for now. But if we run this script, what it will do is check if those libraries are installed, for those that aren't, it's then going to install them and then it's going to call them. And it's a really nice way of just having all your packages. And if I was handing this over to somebody else to run, it's very, very clear that these are the packages that you need. And this is how they will work. And yeah, it will run free. So obviously this is the first time I've run this within this project. So those packages were not installed for me. So this first time run is going to install all of those packages for me and then call them. Once this is done, if I run that same script again, they will now be installed. So all it's going to do is call the packages. So it will not reinstall them. Marco, is that just a legacy hand, or are you trying to?
Oh, that was my legacy hand, yeah.
All right, no worries. So yes, so yeah, if you run that little bit of script, we should then have a list of saying. So when I've got my packages, you can see it made a little vector of the packages that I wanted to create, and then it checked whether these packages were installed or not, and if they weren't installed, it added them to this not installed list. So now if I rerun this script, we can see it's flicked through really, really quickly because it's not having to reinstall them this time. But when it does its checked, my vector now is empty. So I haven't actually got anything there because my packages are all installed. So that's called the tidyverse, the NHS-R datasets, and Pac-Man. Pac-Man is not as exciting as the old 1980s arcade game. It's short for package manager. So yeah, sorry about that. So what we're going to do is, first off, is create some data. So the NHS-R datasets has just got some NHS data built into it. Where are we? Oh, Claire's waiting in the lobby again. Sorry. Yeah, so the NHS-R datasets has got some basic data in there. So if we have a look at our data, this is hopefully something, well, you're going to get very used to because we're going to be using it for the next 2 days, which is our data set. So we can see that it is a time series. So we've got a period, and obviously working on time series data is something that we use a heck of a lot. We've got an organization code, which is the provider code. We've got a type, and that's either type 1 attendances, type 2, type 1, 2, or other attendances, and it's numbers of breaches, attendances, and admissions over time. So a very, very basic data set, I guess, and obviously it's just looking at AE attendances over time. But we're going to be doing so much with this data set. It is phenomenal. So hopefully you have got a data set up there. So let's just use some very, very simple base R commands. So col names, really, really useful. So if we run col names, brings up the column names of our data set, which I find really, really useful now because I can just double click on them and copy them if I need to and paste them into bits of code. Because sometimes you get these really, really complicated column names, and yeah, it doesn't always pick them up. So column names is a really, really good way of just having a look at the column names of your data set. I think we covered it before, but if you do the data and then the $ and pick a column, it will bring through that column as a vector. So this will basically be bringing through this column as a vector by using this $. And again, if you do data $ and pick, I don't know, admissions, again, that will bring through that admissions as a data set. So that's really useful. What we can also do is get a list of the unique items in a variable. So there's a nice unique function. So if we run that, it will give us all the details of all the unique values within there. So again, if we look at unique, I can't spell, unique data $type, it will tell us all the different types that we have got within our data set. So literally we've got 1, 2 and other, so it will just give us is that what we expect? Are we expecting to see anything else? So that's really useful. So like I say, that $ is really useful to call a column as a data as a vector. What we can also do is slice our vector in order to get certain bits out of our vector. Again, this is all horrible base R stuff, and if you've used Python, you'll see it's different. So if I do data $type and then square brackets and a 4, it will bring back the number 1. So if we go back to our data, we can go 1, 2, 3, 4. We can see indeed our 4th entry within that vector is a 4. Sorry, is a 1. Likewise, we can also bring back sections of the thing. So we can do data $type 4 to 10. And if we run that through, we get 1, 2, other, blah, 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 blah. So 1, 2, other. And if we can see this, we can see we've got 1, 2, other. So if we want to pick out an individual cell or a sort of a range of cells within a column, we can use this square brackets. Not going to go massively into it now, but you can also, I think there's a tutorial, and I'll make sure I cover it in the resources, where you can, if you wanted to know, for instance, from your data set, which organization code has the highest number of attendances, you could use sort of slicing here to sort of bring that through. And again, that's if you're trying to do things like automated commentary and things like that, being able to just pick out sort of things based on other conditionals is really useful. And I will link where I just do a whole sort of hour discussion around that at another date. For Python users, this is quite alien. Python starts its counting at 0, and R counts at 1. So R does human readable, Python uses 0, and if you're flipping between the two, it does get very confusing. So Python counts the first thing as position 0, R counts it as 1. R also includes the 10th entry, whereas Python would not. It would stop beforehand. And so yeah, the differences between R and Python indexing is very frustrating. Not frustrating, different. So yeah, but obviously if you don't use Python, that's not really a problem. I think we did some things like ndistinct before. So if you just want to check that, I don't know, you're expecting a certain amount of organizations to be submitting the data, you can use like an ndistinct, and that will just tell us the number of distinct entries. So we know here we've got 274 different organizations are submitting to this data set. I think we've used things like mean and medians before, but we've also got functions like range, where we can look at the range of the data for our period, so we can just double check what time period this data set covers. So we can see that it covers from the April 2016 through to March 2019, which is really quite nice. Just be able to do that really simply. We can also use str to see the structure of our data. So very much when people have done the introduction course, we did, so we imported some data, and we had to make sure that one of the things was that, date was in a date format, and that our numbers were in a number format, and our characters were in a character format, etc. And if we use the str function, it allows us to see the various data types within our data set. So we can see that, yep, for sure, our period is coming through as a date. So that's really good. We have got some interesting things here where we've got a factor data type, and we will we will do some factors probably later, either probably one of the last things today or possibly tomorrow. So a factor is a really cool data type where you can assign hierarchies to non-numeric things. So for instance, if you literally had the words low, middle and high, and you ordered them using any sort of a range or whatever, R traditionally would obviously just put them in alphabetical order. So you would get high, medium, low. No, yeah, high, low, medium. I'm trying to do my alphabet there. What a factor would allow you to do, I know, thank you. I can't do letters. So what factors will allow you to do is assign a hierarchy to a sort of text in order to make sort of that ordinal data, which is really, really cool. So we will be doing some of that later. We've also can just double check that our attendances have come through as numerics, as have our attendances and breaches, which is good to know that they haven't come through as a character by mistake or whatever. We can also do things like head data, which just gives us the sort of the first 5 rows, or sorry, first 6 rows of our data set. And just has, it says 5, that's very wrong, isn't it? Let's change that to 6 and remember to change that to later. So if we just want a little snippet of our data just to sort of eyeball, really, really useful when you're looking at sort of big data sets. And likewise, you can do tail, which will bring back the sort of last bits of the data set. We can also give head an additional number in our data set. So if we actually want to see the top 15, that would be a way of doing it, and that's a sort of base R function. There is a dplyr function which allows us to do much more. So to start with, we can do our slice head data n equals 15, which will do exactly the same. However, we can also do things like, instead of just saying we want to bring back the first 15 characters, we can say we want to bring back the first 15% of the data. So we can do a slice head based on the proportional size of the data. So if we run that one through, that would bring us back 1,904 observations in our data set. And if we assign that to a variable, we would be able to see that that was our top 15. So we can just test that, because 12765 is the total number of observations divided by 100. Let's put some brackets in because that's always best. And if we times that by 15, that should give us more or less the 19. So it would be those 1,904 rows plus the 10 it's seen would give us, we can see that it's given us the top 15% of our data set. What we can also do is we can do a slice max, which is quite nice. So we want to see the first 15% of our data, but this time order it by our attendances. So we can use the slice max function. So we're going to bring in our data. We're going to do that proportion equals 0.15. So we're going to get our top 15%. However, rather than just taking the slice out of the top, we're going to base it by our attendances. So if we did that, we can see that, this has put this in sort of attendance order and has now given us our top 15% of our attendances. So here we go. First, over to you, which is quite scary. So see if you can find the lowest number of attendances for each organization code. And bonus points if you can find the lowest number of attendances for each organization code by each attendance type. So over to you, and stick your hand up when you've got an answer. I mean, clues, I guess, as well. So if slice max does the highest, how would we get the lowest? Oh, I've got a hand up already. Fantastic.
Oh,
And
well,
if you Sorry, was that another question or I finished?
Oh, yeah. Well, it was a question. It was just a case of, would we kind of be doing what we did before, but instead of doing a proportion, we'd do an n equals because it wants us a 5.
Yep.
And then we just set the attendances to order it by attendances, but go the other way. Does it work?
That is a way of doing it. Yeah, I guess. So yeah, you could do order by minus attendances. I think there's a simpler solution. But yeah. Anybody else found a?
I think I have something for with the bonus points, I suppose.
And the bonus points. Okay, what have you got?
That's it. So data pipe group by the org code and the type, pipe it to slice min attendances n equals 5, and ungroup, of course.
Okay, I like that. So let's have, because I can't be bothered. So if people still having a go, I'll give it another minute. Yeah, if you want to pop your solutions in the chat as well, and then I can also pop them up on screen, because I appreciate for the recording nobody's going to be able to see that. So yeah, if you could pop your solutions in there. Okay, you're doing it that way. Nice, thank you. So let's just double check whether it works, which it does indeed. Dan's done that. Fantastic. Did anybody get the bonus point? So order by attendances. Yep. Data group by org type, slice min. Yeah. Same as. So okay. So let me show my solution. And I say, if your solution works, it's not wrong. So this one definitely works. This is probably my preferred solution. But if I was going to do it by org code and type, we can pop that into a vector, and then we can run it by both. So we can do slice min data. Why is it giving me an unmatched bracket? There's no unmatched bracket there. Yeah, why is that doing there? That's weird. Is there an unmatched bracket here? No, it's just been weird. Right. So let me pop that in the chat if you want that version. So I definitely like the thinking of the slice max, and then yeah, order by minus attendances would kind of work. I think potentially that might be a little bit confusing to read, so I would definitely stick with that minus, but good to know that you can do that. But adding that by within the slice function, I think makes it a lot simpler, and then we don't have to worry about adding in additional bits and pieces. I see some people have put it in pipes, so let me just show you the pipe version. And yeah, that is probably, we could do, where are we? We could do blah, 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 blah. Data, then slice min, and to do all that, and then make it all pretty. So yeah, that would work as well. Everybody okay with that? And yeah, that one would work as well. Any questions on that one before we move on? Okay, so some other really nice functions. So summary is a fantastic function, and again, it's one of those absolutely go-to functions when you first get your data set up together. So if you do summary data, it will just basically give you a summary of your data. So give you the sort of the min, the max, quartiles, the tell you a count for sort of categorical data, and also if you've got any NAs or missing data, it would also tell you the numbers of missing and nulls or NAs you've got in your data set. We don't have any in this, so we're not going to be dealing with those massively today. But yeah, really nice, quick and dirty function just to say, does my data cover the period that I'm expecting it to? Am I seeing the right number of attendances or whatever? We can see that we've got, obviously, it doesn't go through all of our different organizations, but we can see that we've got bits and pieces there. So yeah, summaries are a really nice data table. What's also really good is the table function. So table, and again, lovely little base R function. And if you just want a really quick count by a column, you can do table, data, and then the $sign and the type of and the column that you want to do a count of. So if we run that one, we can see very much it's just done this same copy as this. We've got 4,900 type 1s, 1,000 odd type 2s, and 6,500 others. You can also put in 2 columns. So if I wanted to get a very quick count of by organization code and by type, you can also run that through. And now I can see across my data set how many of my organizations have submitted across the piece, and how many of them have got type 1 and type 2. So yeah, we can see there are some that have got sort of type 1s here. We've got a couple that have got type 1s and 2s, etc. So if you just want that really quick and dirty just count of something, really useful. So if I just wanted a quick count of my organizations and how many times they have submitted, I could do a table org code, and I could run that, and I can just see very quickly a count of all the organization codes and see who's done sort of 36, which is obviously one submission for every data point, and then also those that have only got sort of sporadic data sets. So really nice. Where have I gone? I seem to have jumped down slightly. Okay, so table function, really nice for those like quick and dirty when you're just working on the data set. It's not going to be part of your analysis as such, but just when you want to sort of double check, have I done the right thing, or has my bit of code done the right, has it come out with the right answer, or have I dropped anything, or stuff like that. You can put 3 or even more columns into a table function, but it does get very odd very quick. There's no way I could work out to that size. Okay. Oh, sorry. Okay, well, I will slow down a bit, and okay, I will see if we can cover things a little bit slower. No problem. How to do that access? Okay, well, let's have a look. So yeah, I'll see. So we'll go back to some more nicer tidyverse stuff now, and just to say how we can do stuff. So we're going to take our data and we are going to rename a column. So classical thing is, especially if you're importing data from Excel or some other places, sometimes what you will have is a space in your column name. And Excel is absolutely classic for putting spaces within column names. So very difficult to deal with within R. So if we have got a space within our column name, what we need to do is put it in backticks. A backtick is the little tick next to your 1 on the top left hand side of your English keyboard. If you don't have an English keyboard, then I've got no idea where it is. But backtick is something where a bit like where we use speech marks or single quotations within our data set. So again, probably go off on a little bit of a preamble here. Quite often, especially when I have done our courses before, people go, well, when do you use like quotation marks and when do you use sort of single quotations? And, you know, I look at one bit of code and you've used one, and I've looked at another bit of code and used another. What's the rule? And the rule is there is no rule. As long as you are consistent within your thing. So if I do print hello, that will work. If I do print hello, that will also work. But if I do print hello and make them inconsistent, it won't work. It will crash. Will not crash, it will leave me hanging because it's waiting for an end. So this does allow you to do some interesting things. So if I had my speech marks within my single quotes, when I come to print it, it will now print with the, well, it does something a little bit odd here, but it will print that through. Or if I did my single quotes within my double quotes, that will print those. And if for some bizarre reason I wanted to do something, print all of those, I could put that within backticks, I think. Oh no, that does not going to work because that was going to ask for an object. Yeah, there is another way. I'd have to get into sort of weird HTML stuff if I want to print those. But yeah, so that is the difference between single quotes and double quotes. Essentially, there isn't those. So yes, when you're running code, what are you pressing? Yeah, I press Control and Enter at the end of my code in order to run it, and that will just run that line. Or old school would be click that and do it. I will probably I will revert back to doing that because then it makes it very clear which bits of code I am running. So thanks for picking that, Catherine. But yeah, Control and Enter will do it. So anyway, what I've done now is renamed my org code into organization code. So again, if we look at our col names data, we can see now that the org code now has got a space in there and it is now called organization name. We're also now going to rename all our stuff some other weird things, and even going to add in a leading space into my column name for type, which is just awful. So if I do col names data, now you can see I've got a shouty, I've got a space, I've got a leading space, I've got attendances, which I haven't touched, I've got capitals, and I've got admissions. Yeah. So yeah, I talk about, sorry, somebody's asking about the pipe function. So yeah, that's just a modern pipe function. So sorry, just pop it on the screen. That's the old school pipe function, and that's the new school pipe function. This old school pipe function was part of tidyverse, specifically the migritar package, and you would have to load either the migritar package or tidyverse in order to use that pipe function. This is the new pipe function, which also works within dplyr, but it's now part of base R, so that you don't have to use tidyverse in order to use that. They do work more or less the same in 99.9% of cases. However, there are some very odd edge cases where they are slightly different, but for all intents and purposes, they are the same. So yeah, so that's very, very common that we've got these horrible column names with lots of things. So we have a lovely library, which is definitely one of my favorites, called Janitor, which we haven't installed yet. So let's install that. We could, if we wanted to be nice and clean, we could add it into our list up here. And there we go. And we could run our little script here again. And it will check. This time it will see that Janitor wasn't installed, and now it's loaded it in. So we could do that, or you could do it manually by doing tools and install packages. but probably nice to add it into that so it's all in one place. And as you see, it will check. And just to confirm, I've installed it now. So this was saying as not installed. If I run this again, that should come through as blank again. So we just add that into there. If that's not a thing, you could also just do the install packages and install it there if you wished. So where was we? So Janitor's a lovely package, and I guess along with Tidyverse, it's probably the second package I usually run at all times. And what my favorite function is the clean names function. So I'm going to get my data and I'm going to run clean names on it. And if I run that, doesn't look like it's done anything particularly exciting. But now if I look at my call names data, it has put them all into snake case, all in lowercase, and where we had these spaces, it's now put an underscore, and where I had things like leading spaces, it's removed that. So it just puts all your data, all your column names into a single format, and it does make your code much nicer and much easier to use. So let's have a quick try over to you. So yes, see if you can rename breaches to number of breaches, and just see if you can mess it up and remember how to add spaces into your column name, and then chuck it back again. So mini hints, just be aware of what order your rename goes in, because I always get it wrong. No worries. Thanks, Claire. So hopefully everybody managed to just rename stuff. Obviously, really useful thing to be able to do is renaming your columns. Everybody happy with that? Do shout if not. Yep, we're all good. Okay, fantastic. As ever, please shout if not. So Janitor does have some other great functions. It's got a lovely function. You know, Excel does that weird date thing sometimes where it comes through as a numeric. It's very good at then converting that into a date. It does things where if you just want to check a data set and say, have I got any duplicate rows? It will do that. It's got some nice things where it adds quick totals to stuff and subtotals by groups. But yeah, just finding sort of duplicate rows on your data set, or if you want to find duplicates within a column or things like that, it's really nice little package which does lots of that tidy work. However, without a doubt, its shining function is the clean names function, which is definitely the go-to, and I would thoroughly recommend. I think we touched on naming conventions in the introduction, of course, is, you know, make sure all your variables are in a similar sort of format, in that they are, you know, I recommend using snake case, obviously make them descriptive of what they are, and that makes it really nice. Obviously, when you come to plot your chart or put your data set into a table or whatever, at that's the point where you kind of convert it and put spaces in there and make it human readable and all of that stuff. So let's just rerun our data equals A attendances just to make sure that everything is back to its sort of defaults, and we haven't got anything in a weird format. So everybody okay with rename? Again, really useful, be able to do stuff. Sorry, Olu, I can't pronounce your name, so but to shout. I've got a hand up. Now you're getting this error. What are you getting?
Yes, I'm getting an error that says that column name number of breaches does not exist.
Okay. So if you do cool, where are we? So if you do your col names, what col names have you got? Have you got number of breaches as a column name?
Yes, please.
You have. Could you pop your code in the chat? Let's just find it again.
Yeah, I can just copy that and send.
Excellent. Yeah, back to front rename. That's what I do all the time. So let's just get this right around. So you did it that way. And you had, so if you've got it that way, yeah, I always get it wrong. Absolutely, every time. So you've got number of breaches there.
Yeah.
And that's definitely, that's what you've got coming up there. Yeah.
Yes.
And then when you run that one.
Okay, no, mine is not coming out the way it's appearing on yours. I'm still getting the error. Number of breaches doesn't exist. Now that I've run it again.
So if you run col names data, what does that show?
So for that, I can get the period, attendance, organization name, all of those.
But it doesn't say number of breaches.
No,
no.
Says,
so it looks like you haven't changed it to number of breaches yet. So you probably need to, right, let me get this right. So you need to do that way round. I know, yeah, so it's doing that essentially. So you need to do that way round first. I'll pop it in the chat. So if you did that first, it will change it to number of breaches, and then if you run that second bit of code, that then should work. It is backwards. It kind of makes sense logically in that it works in that tidy way. If you think about how you would write a mutate statement, you would say mutate and you'd give it your new column name, and you would then say what your new column name is. So it does work exactly the same as that. And that's the way I try to remember how to do it. So if you think about a mutate or a summarize where you create a new column name, that's what we are doing.
Yeah, that makes sense.
That's essentially what this rename is doing. It's kind of creating this new column name, and it is now going to be called this. However, in my head, I always picture it the other way around, and I'm glad it's not just me. Anyway, let's reload our data to AE attendances so it's all clear again and we're all good. An earlier iteration of this course didn't do that, and everybody had like 500 different versions of stuff. So anyway, we are going to go back to our lovely select statement, which I think we sort of covered, and just show you some other really nice things that we can do with it. So it's really simple stuff. And if we do our data and we select our period and our org code and we run that, we now have a new data frame. And if we click on that, we can see it's just a data frame now with our period and org code, which is great. Or if we did data select org code period, it will now put the org code first and then the period. So I think we've done a little bit of that kind of stuff before. So just to be aware, obviously data select orders the data in the order that you have stuff in your select statement, very much like SQL, very similar. So Just to say there, and I think we've sort of possibly covered this a couple of times. So obviously you can, if you want to see that data, you can click up here in the data select. You can run the view command, or what you can also just run command, it's just the object itself, and it will display sort of ahead of it within the console. Or my absolute favorite is that you can click on control and click on an object, and that will also bring up the select. So let me just so if you've got an object, if you press control and then click on it, it will bring it up. For some reason our cloud seems to put it in another tab but doesn't ping to that tab, but if you're using it on the desktop, it will bring that up. So really nice way of seeing what an object is. So yeah, control on that. What's also nice, a bit like in SQL, we can add an alias or rename. We can rename a column name at that select period. So where we had and it uses that same syntax. So if you try to think about it, where we're saying our new object, our new thing is going to be this old one. So we can say data select, and then we can say date period will be period, organization will be org code. And if we run that through and we have a look now at our data select, we can see we've now got date period and organization instead of org code. As I think we possibly covered before, you can use a exclamation mark, which in our terms is called a bang. I usually call it an exclamation mark. Calling it a bang is strange, but that is the official term. So we can do a bang on this. And if we run that, we will select everything apart from organization code and period. But note, we need to put that into a vector in order to make that work. So if we look at our data select, now it should have all the information apart from, it will not have period code and it will not have period. If we do not put it into a if we do not put it into a vector and we run that, it has run, the code hasn't errored, but if we actually look at our select data, it hasn't worked. So it doesn't work in that way, which is a bit of an odd one. So just something to be massively aware of if you are trying to remove variables that way. The better way of doing it is using the minus, and this way does work if you're trying to pick sort of individual things. And we do our data select there, and we can see that does work, and you don't have to put those in a vector. Not sure quite what the quirk of that is. It's just one of those things, but yeah, just kind of be aware of. I think again we sort of covered bits and pieces of this in our previous training. There are sort of verbs, there are sort of tidy select verbs that you can add within a select statement. So we can say tidy select and select any columns that contain ES. So if we look at our col names, data, ES would be our tendencies and breaches, or it should be, as far as I can see. If we run that one and have a look at it, yes, indeed, we've just got our attendances and breaches. We can also put bang in front of our contains, and we can say, I want all the columns that don't contain ES. So if we run that one and we have a look at our data, we can see that we've got everything apart from those. We can also give it sort of conditionals. So we can select any of our columns and we can add a where statement, and our where statement will say, I want to select any columns where the data is numeric. So if we just have a quick look at our data, we can see that our data, and move that one down, we can see that our attendances, breaches and our admissions are numeric. Our organization code isn't, it's a factor, and our type also is a factor. It does contain the numbers 1 and 2, but it also has other in there, so it's not a numeric column. And if we run that one through, again, we have a look at our data, we can see that, yep, that's just pulled through our numeric. And again, we can use things like, we can mix those up, so we can select our admissions, our breaches, and then everything else in the order that it's currently in. And the really nice thing about everything is it will understand what's already you've pulled through in your select statement and then pick everything else. So it doesn't then duplicate up. So we won't have a data set that will have all the other bits in there twice. So we look at our data set. We've done admissions, breaches, and then everything else has come through in order. So we've got an over to you. So select the data so that it's in the order of admissions first, and then any other column that is a factor, and then everything else is as it is. So just have a mix up with all the bits and pieces above. So we'll want admissions first, any column that's a factor, and then all the other columns after that. And stick your hand up when you are done. And is there a, no, it's not, or I don't know. And I don't know, you can do a shocked face react or something if you are not done and got a problem. Do you find you always renaming, reordering columns as you do different things in your data frames, especially when using doing visuals? Yes and no. I find that it's easier to rename stuff when you do get to that point, so don't do it as you go along. And generally, I would rename them within the visual and not the data set. Very rarely would I hard code or put in, you know, my human readable spaces and everything within the actual data set. I would always keep the data set as a data set because you never know when you're going to be doing something else. So yeah, I'd always rename it either within my ggplot, or if I was doing GT tables, which quick plug, GT tables workshop coming up in about a month's time, I would rename my columns at that point. So yeah, I would try to keep the data as pure as possible. Any hands up? We got that? Fantastic. Yeah. Any more? Or hands up if anybody's stuck and it's all going wrong. So can't say, so I'll just run through it. So I'm going to start with my admissions. That's the straightforward one. We can copy, we want where it's a factor, so we can basically change that to where it's factor. And then we want oops, not an M, we want a comma, and then we want everything else after that. And then if we look at our data, got our admissions, our all code and type are both our factors, and then it's pulled through everything else. Hopefully everybody's got that. Okay, so just say there are lots of other nice tidy select verbs that you can use, things like starts with, ends with, to look at your column names. And also that where function, you can also do some really, really clever things with to try to identify certain columns as well. So you can do things like where is date and things like that. So there's you know lots. So you know, you can search by the data type, you can search by the data name, you can search by, you can select by, just trying to think, what else would you want to select by? Yeah, anyway, I'm trying to think of it. What else would you do? Okay, where are we at? We are at alternative joins. Okay, let's crack on to this section, which will probably be about 10-20 minutes, and then we'll take a quick break. So let's do some alternative joins. So very much in our previous learning, we've done sort of left joins was our main one. And again, if you're sort of a SQL person, left join is probably your go-to, or if you're an Excel person, then your VLOOKUP is probably your go-to type of joins. But there are different ways that you can also join two data sets together. So we're looking at row and column concatenation, which sounds far more complex than it is. But basically, it's like, how do I plug two data sets together without necessarily joining them on without a key? So this isn't like a VLOOKUP or whatever. This is literally pasting some data at the bottom of some other data, or pasting it onto the side of some other data. So definitely not trying to do sort of relational joins. It's just pure shoving data together. So let's just pull some data together. So we're going to have df1 and df2. So our df1 is just going to be our period, our organization code, our type and attendances. And then our df2 is just going to be everything that is numeric. So let's just have a quick look at those. So now I've got a mini data frame, which is just this. And I've got df2, which is just this. And what I want to do is paste df2 onto the side of df1. So I'm not pasting it underneath, I'm pasting it to the side and creating some new columns with df2. And so this is called a column bind. So I can do df new, which is I'm going to create a new a column, and I'm going to bind columns of df1 and df2 together. So what I would expect to see is still to see 6 observations, but instead of and I would then also expect to see 7 variables, because I expect to see 7 columns within my data set, which is indeed what I get. Phew. And let's have a look at our new data set. So it's pulled this through. Have noticed, however, that we do have a duplicate. So R will not allow us to have 2 columns that are the same. It just will not allow. It will not like that. So you can never have 2 columns with the same ID. So R has automatically done this weird, little weird bit of naming convention, and has said this is attendances and given it a 4 for its, because it's the 4th column, and this one's attendances 5 because it's the 5th column. So yeah, so always got to be mindful that your data sort of lines up if you're doing that. So we've literally just popped one onto the side of the other. So let's we can also bind data frames on the bottom, which is probably more likely that you're going to do. So you've got a new data set and you want to add it to your old data set. So you want to add your new data to your old data. So let's just create very, very simple data frame 1 and 2. So data frame 1 is just going to be the head data like this, and data frame 2 is going to be very, very similar, all with the same column names, and we're just going to chuck one on the bottom of the other in order to create a new data frame. And if we run that one through, so adding those together, we would now expect to see 6 observations of 6 columns or 6 variables. And if we look at this, that's indeed what we've got. So we've literally pasted one on the bottom of the other. So that's relatively straightforward. However, sometimes we might be pasting some data onto the bottom of the data set, which doesn't have the same column names. So what happens there? So let's create 2 slightly different data frames. So df1 is not going to include breaches and admissions, and df2 does have breaches and admissions, and we want to paste that one onto the bottom of the other one. So if we run that one through, let's have a look at what it looks like. So it's created, so where it's matched, it's added those in and it's matched those, and that's all good. However, where there's not a match, it's created those new columns. Obviously, this is still our legacy DF1 is this set of data here. And obviously we didn't have any observations for breaches and emissions. So obviously ours just filled those in with NAs because there's nothing to pop in there. So hopefully that makes sense. I've just been using bind roads here. However, we could also put that into a pipe if we wanted to, and we could run that one through, and that would also do exactly the same. So hopefully that makes sense. And so yeah, over to you. Can you create a data frame of the top 5 admissions only and the bottom 5 attendances only, and then join the 2 columns together? So this might be going back to some of the stuff we did earlier, just so you know. Apparently it's called reinforcement learning. Is that a done or is that a question, Mike? Sorry, I didn't.
It's a question. Sorry. So I tried what might be just a stupid thing, but just taking the head 5 for the first data thing.
Yep.
But I'll have a look. Actually, more what I'm doing before I embarrass myself more. I think I've got an idea.
Okay. So yeah, this is very much using a couple of things that we've been going over to kind of build them up together. So, and we will be doing that as we further go through. So you might get to a point and say, Sam, you haven't just covered that. Where's that? Kind of, and go, yeah, we covered that earlier. So this might be pulling a couple of things that we've done in other places together. Is there a fundamental difference between arrange and order by? No. I mean, order by is generally you would do that within a command, which does make things a little bit easier and all in one place, but you could do an arrange outside of that. So no, it's just potentially just adding another step to stuff, and want to keep it as simple as possible. But yeah, you could do an arrange, that would work. I guess the nice thing to do as well is, if we are using slicing functions from earlier, that it does all of that in one go. So let me put DF1 up, and if that makes people go so I want to select admissions because I just want admissions and that's all I want, and slice my max n equals 5 because I just want the top 5, and order by admissions. Right, so yeah, order by outside of the slice function. Is that, just try and remember, order. So order by is definitely yep, so that's a dplyr. There is an order, which is also base R, which does something sort of similar. Yeah. So what is the difference between arrange? So arrange is its own, I guess arrange is its own function in of itself, whereas order by generally sits within other functions. It's probably the thing. So yeah, arrange you can obviously arrange on anything. Order by sits within other functions in order to do that. So I don't think you could do arrange wouldn't sit within that slice max. But I'm just trying to think. I'm not sure if you can. Yeah. Whereas order by is usually a sort of sub function within another function, if that makes sense. Oh, have we got people? What's going on here? Well, Claire's back. Sorry, Claire, didn't realise you were sat outside. So that makes sense for data frame 1. And then data frame 2 was attendances. Attendances there, and we want to do slice min. And then literally that again, don't we? Oh no, by cols, not rows. That should then give us, oh, there's what, who, what, a? Yes, new, why is that? Oh, that needs to be df1. Right, so I'm using it. So now should have a little data frame of attendances and admissions. Mike.
Hi, sorry, when I try that, the df2 works, but for the df1, I get error in df1. The pipe operator requires a function call as RHS.
Okay, Joe, pop. I know, where are we? What have we done then? Is that your code? So that's the code you just popped in the chat. All right.
Oh no, sorry, that was
I was just seeing that you've just popped your new one in there. So let's just see what that's doing then. So that one works, yeah. And that one.
No, the top one doesn't work, but the second one does work.
And rows, bind cols, not bind rows.
Ah, righty-ho.
Yeah, it's that. Is where, yeah. Because you want them side by side, so I'm binding the columns together, not the rows. Which, I mean, yeah, generally binding columns together is quite rare, and it's quite horrible. And again, you've got to make sure that whatever data set you are working on, it absolutely lines up perfectly, because obviously if you've got one missing value, it's going to just shift everything horribly. So generally it isn't done. It's probably more an example type thing. What is more common is that sort of binding the data on top of each other, and you know, very, very common to have data that comes in and then a new data set which you're appending onto the bottom. Okay, everybody there and happy with that? Let me just get rid of that one. Everybody happy there? Yeah. If you're not happy, please shout. Okay, so just going to run. Oh, where are we? Yeah, so let me just have a look. So we're just going to, like say, if you are joining stuff together, definitely join is, you know, using your traditional joins family of stuff is going to be much better. Just going to rename breaches to admission in order to create some duplicates. Okay, so if we just have a look at that. So we're just going to get our org code and we're going to select our admission breaches, but we're going to call them admissions. And then we're going to create a df2, which will also have admissions in it. So we've got df1, which has got admissions, and then we've got df2, which also has admissions. And as we can see, we've got duplicates now because we've got RF code, and it's going to have lots of different, lots of the same things over time. So what we can do is a union all, and if we do df union, that will join them all together into one. But what's really quite interesting now, because obviously we've got columns which are the same. So if we want to find out where have we got these duplicates, we can write an use of the intersect function. And if we look at intersect, we can now see these ones appear in both just trying to think. Sorry, I'm just going back to earliest code. Yes, I would worry about using sort of the base R within the dplyr. I mean, it definitely works, but it does get a bit messy if we start putting $signs into the code. I mean, yeah, that does work. And like I said, when you put that $sign into your data set, let me just pop that into the code, into the screen for me, just so we've got it in the video, because the chat doesn't show up. So yeah, this is a potential alternative way of doing it. It does work, I'm guessing. However, it does use a bit of base R in these $signs. So when you do that, it's basically you're feeding a vector into that slice max function, what is working. But I think I don't know, it's a bit like crossing the streams. Either try to use tidyverse where you can, and avoid using stuff where we do. But do seem to have a bracket missing as well. There we go. So that should work. No, it doesn't like it. The applicable. No. Did you get it to work? Just trying to think. Sorry, I'll come back to that. We'll have a break in a minute. I'll have a look at that one. So the intersect will tell us where we've got the same identical columns on both tables. So where we've got identical values across both tables. So which is really, really useful. So if you want to see what's in this table, but it's also in this table, have we got duplicates? And if we have got duplicates, just bring me back the duplicates, which is really, really nice. And we can also then do the inverse of that and say, well, actually, I've got some data in table A and it's not in table B. Where have we got sort of non-duplicate data? So where have we not got matches where we are expecting matches? So we can do this set diff, and the difference then will tell us where have we got sort of data that should perhaps match across tables, but it doesn't. So we can use this set diff to show us where we've got individual bits of data that don't exist in the other one. And you can do that across the entire rows, or you can look at sort of specific areas and bits and pieces. And again, that's just using a bit of base R. I would shout out again to the janitor package, which has got a lovely lot of functions that do that, but a much more complicated way. So yeah, order of arguments does matter a lot with set diff, because it does get a thing. But I've got an error viewing it. Just stick to set math. Okay, that's fine. Okay, we are at 10:30. Let's take a quick sort of 7-minute break till 10:40, if that's all right. And then we'll get back to stuff. If anybody's got any questions or queries, do chuck them in the chat now, and I'll just see if we can pick them up before we crack on with the next bit. And do shout if I am going too fast. Yeah, do let me know. Otherwise, I'll see you at 10:40. Right, hopefully everybody's back in the room.
Hello, sir. All right?
Not too bad. All right, we ready to go?
Yes, ready to go. Yeah, I'm enjoying it already, which is good.
We shall do some more. No worries. Okay, so just gonna quickly run through group by within mutate and summarize. So depending on where you learn R, this may or may not be new to you. Obviously, if you've learned R relatively recently, this is all old new old hat, but if you are coming to this course and you've not done any R training for a while, this might be new to you. So old school way of grouping data would be taking your data, doing a group by, and then you do summarize, and then you would, traditionally you would do your count that way, and you'd have group by and ungroup outside of your or a wrapper around the thing that you wish to group. So if we look at our data old, this would then do a nice little count of our type 1s, 2s, and others. New school way of doing it would be using the .by command, and then we can add that in within our actual sort of summarize there. And if we have a look at that, that also comes up with exactly the same answer, which is great. We can also do groupings within mutate statements, which is also really nice. So if we wanted to group it by our type and create a variable which will be double of our emissions. So if we do a data old and we run that now, we now have got where have we got? We've got a new variable here, which is grouped by the type of the admissions. So that's sort of doubled that across the way. And again, if we were doing that new school way, we would do that, and that would work that way. So that would work again exactly the same. What's nice about the new method is that you do not have to worry about the ungroup. It's a much sort of safer method to do that. And yeah, it's a much nicer way to do it. Generally, I will use the new method, but yeah, it's worth doing that. Is group doing anything in the double admissions? I don't think it is actually, is it? No, don't think it is. So if I did group by org code, yeah, I think you're right. I think it is data old. Is that doing anything? No, that's still because I'd have to do a sum of admissions times 2. Oh no, if I did that, well picked up, whoever that was. Dan, thank you, Dan. So if I did that, now it's grouping it. So now it's grouping it by the sum of all the type 1s and then doing it. So yeah, so it was technically doing something, it just wasn't. So hopefully, so Dan put in the chat, is group doing anything with double emissions? In that instance it wasn't, mainly because I was just still taking the admissions and timesing it by 2. However, if I take the sum of the emissions, it's now, when it does that sum, it's doing it by the group, and I would have to do the same on this one. So when I add that additional function in there, it will now be doing it by the sum of the group. Thank you very much, Dan. I will adjust my next version of this accordingly. So yeah, now that will do me a total by the group. And because I've totaled it by the group, each time we've got a 1 now, it is going to give us the same number across each of the ones. Well spotted. So we can also do a count function, which is really nice. And this is basically a bit like where we did the table function earlier. It's kind of the tidy version of that. So where we did our data up here, we can use a count function, which is nice. And if we did have a look at our data count, again, it should give us our very, very recognizable little table of stuff, which would be the same as doing this to say data count, summarize, blah, 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 blah. So we can change all of that into a count function, which is really, really nice. And we can also do things, there's various different types of counts that we can do. So we can do summarize count, which is this one, or we can do an add count, which is basically doing a mutating count. So summarize, obviously, when we look at that one and we look at our data count, it's just giving us that summary. If we do a mutate count, it will add a new column for our total. So if we look at our data now, we've now got a new column, which is telling us our totals across and what we've done at a total by the organization codes. So that would be the same as adding in a mutate, where we're adding in a total numbers for that. What have we done? Total number of bits by the organization. So hopefully that makes sense. But yeah, the add count and count really nice little mini bits of dplyr to save you doing sort of big summarisy stuff. Fancy filtering. Sounds cool, doesn't it? So we can also do things like filtering. So we've done some sort of select verbs previously where we've done like starts with and things like that. We can also do things like do a string detect, which is a bit like using a contains, but slightly different, and it does allow us to do more. If you ever get into regex, allows you to do really quite complicated examples of, if you want to say, if you had a list of codes, for instance, and you wanted everything that had an R, and then a couple of wildcards, and then a 4, and then a couple of wildcards, or something like that, you can then add in this sort of string detect, which will allow you to do really quite complex sort of filtering and identification of your data set. Or yeah, and you can sort of give it a real, say, you know, the first thing must be an R, anything after that is a wildcard, the third thing must be a P, and then it must have 5 characters after that, and it has to match that exact format in order to be filtered. So string detect allows you to do much more complicated things. Here we're just going to do a really simple one where we're just going to do string detect, our organization code contains an R, and if we look at that in our data filter, we can see now that all our organization codes contain an R, and that can be at any point within there and just contain a single R. We can also add in some functions into our data set, and this is one of my favorite little ones, which blew my mind when I did it. So we could do a data filter, and we want to do a data filter where the period is the maximum period, but we also want to group that by the organization code. So essentially, this will give us the latest data point for each organization, which again, when you've got those, you know, sort of sitrep type things, or you want to know, you know, what's the latest data for each of the teams or whatever, that's what this will do. So we will look through here, and then we can see one row for each organization, and it will give us their latest data for that information. Catherine.
I've just done that, and I've still got duplicate organization codes on there. Is it not supposed to pull up just one per organization code?
In this one?
In the data filter max period.
Yeah. By organization code.
Yeah, so on row 41 and 42, I've got R1H 3 times.
Because it will be their latest one for,
yeah, so there you've
1,
got
2 and other.
Oh, okay, so it's, yeah, okay.
Yeah, so if we wanted it, I guess what we could do is filter it down to, you know, we could then add in a different one for yeah, because they've submitted 1, 2 and other, that's why it's come through with 3. So yeah, if we wanted to look at specifically the latest by, I mean, I guess we could also do by organization code and type, and that would give us their latest submission by each of the organization code, but also their latest submission by each of their types that they've submitted. So if we have a look at that, potentially we could have the same organization code, but would have different dates depending on whether it's a 1, 2 or other. Obviously, I don't know if I've got an example here or not. No.
Is it because it's sort of the first of the month that it's not, they've got the same date and that's why it's pulling?
Yeah. So all it is filtering out is on the max date. So if the max date is the same, it will filter through everything that has got that max date. Is there a difference in type? I'm just trying to work out. So if we had somebody on this last version that I did, if we had somebody who had submitted 1st of April for type 1 and 2 and 1st of May for type other, it would pick out those first, it would pick out all of those. If we didn't include the type, it would only pick out that 1st of May one because that was their latest overall submission. Okay. Does that make sense? Does that answer your question, Mike, as well? So Mike's asked, is there a difference in type?
Oh, no, sorry. I just put that up as a suggestion to when she was finding the duplicates.
Right, yeah. No, that's fine. I'm just getting back to it. So yeah, just trying to juggle 50 screens. Okay, cool. What we can also do is, we can add sort of multiple conditions into our filter, so we can get our data, filter it to our type 1s, and also filter it to only those that have got attendances of over 10,000. So if we do that and we look at our data filter, we can see that, we've got over 10,000 and we've only got the type 1s, which is, so you can add multiple things into your filter. What we can also do is add an OR statement into our filter. So I want to filter my data into type is 1 or attendances are over 10,000. So if we look at our data filter now, we can see that, we've brought back all our type 1s, but we've also got these others now. And if we check those, then where we've got an other, it's over 10,000, and obviously where we've got under 10,000, it has to then therefore be a 1. So you can say, is it this, or it meets this criteria. And just note that the or is this little line here, which is next to your Z character, and it is the line on the bottom left hand side of your keyboard, and it's the shift forward slash, I don't know, whichever slash way around, that's backslash, isn't it? So next to your Z or Z, depending on whether you've got an American or English keyboard. And you can obviously set up an OR. I always recommend not to use an OR if you can help it, because they can get very, very messy. Not quite as messy as they do in SQL, but they can really, really mess you up. So just be very, very careful if you use OR statements. Oh my goodness me. All right, here we go. So can you write a script that returns the organization codes for type 1 attendances where we have at least 24 submissions per organization code, and for bonus points, put them in the order by number of submissions? Blimey. And there is a little hint there as well. I would definitely recommend, just again, as with any sort of data sort of wrangly thing, is just break it down into its constituent simplest parts as possible and run one part at a time, just to make sure that that bit works before you move on to the next bit. And that is the quite nice thing about R, is that you can just run that little bit of code, has that bit worked for that bit, and then build up the next bit, rather than trying to write it all in one go. You want to stick a hand up when you're done. Submission. Yes, it does mean admissions. Oh my goodness me. No, it does mean submissions.
It's the count of the org codes,
I
thought.
Yeah, the count of the org codes is the number of submissions. Yeah. So if you count the org codes, that will tell you how many times they've submitted. And then, that will make a little bit more sense. Anybody got there? Maybe. Okay.
I think so.
Excellent. Excellent. Good to hear.
I'm trying
Anyone
for the
else?
bonus.
Did you get the bonus? No. How did you do it? Did you do it the slickest way? That's the big question.
Doubtfully.
So I would thoroughly recommend using the help function on the count function, because it's probably got something that will help you. Any other hands up? Raj, well done, Raj. Or is that a question? I don't know. Right. Give it one more minute. And I appreciate, I'll probably go for an answer and it will make total sense when I do it. And, you know, without a doubt, not necessarily expecting you to come up with the perfect answer each and every time on these. More a case of, right, I get that now. And I'll try to talk through my thinking so that when you do come to do it, you go, right, I can do it that way. And obviously this is a teaching experience, so I'm not necessarily gonna, you know, you're not necessarily gonna get the full answers straight off. So let's have a look. So let's do the easy bit first, is the type 1 attendances. So how do I get type 1 attendances? I can just do filter type 1. And if I run that, and I said that's what I normally do is just make sure that at every point, there you go, I've got my type 1 attendances. So that's great. I now want to have a look at my count, and I want to do a count by org code. So that will give me, and now the numbers of counts per org code, which is great. And if I press F1 on my counts, it will bring up the help for count. And let's have a look at what options we've got in here. If I want to do a frequency weight, no, I don't want to do any frequency weights. However, I've got this sort function. If true, will show the largest groups at the top. So rather than having to chuck in a separate arrange, I can do a sort equals true. And if I run that one through and have a look at my data, it's now put them in order for me, which is nice. And then I want to, what do I want to do? Have at least 24 submissions per organization code. So again, I could just add another filter in, and n greater than equal to 24. So this is one of those classic bits where people who are coming from SQL have a SQL hat on, and they go, I've used my filter, I can't possibly use another filter. It's like, you know, I've used my where clause, I can't do another where clause on top of that, or it will get silly. But, you know, I don't care, and allow us to build these beautiful pipelines. So now if I look at it, I've got my N, and if I scroll down, I can see that they are all above 24. Does that solution make sense? Did anybody get anything close to that, or did anybody get anything absolutely wildly different? And if you got absolutely wildly different that still worked, then yeah, please do share. That solution makes sense? Okay, let's have a look. So you did an add count. Let's have a look at that one. So you're doing an add count. What have we got here? No. So you've got your data filter. So you did data count to start with, which gave you an N here of that overall number of submissions. Then you then took that, where type is 1 and N is greater than 24. Fantastic. That gets the job done. I mean, potentially, I guess it's the clues in the, well, depends on the question. And it definitely worked, don't get me wrong. It depends whether you know, the question was purely just wanting the list of the stuff, but obviously this has got all the other data in there as well. So you've done it as a mutate rather than a summarize. So that's absolutely fine. And what have we got? This one. So we've got, well, somebody's done a rename. Look at that. So you have done it. Yep. So again, you've done a similar sort of method where you have done that, where we OTM, and you've added the submissions here. And I suppose what you could do, does it ask about putting it in order? It does put in order. You could have added potentially an arrange submissions into that one. Would that have added that in there as well? Yeah, and that would have put them in order, I guess.
I tried using order by submissions at the end.
Oh, right.
But it said it didn't like it.
No, so order by
I was trying to sort it.
Yeah, I think we sort of talked about that earlier.
Yeah,
so yeah, order by sits within a function. If you're going to want to do something in of itself, yeah, you would have to do that arrange.
Thank you.
So yeah, that kind of does the job. Yeah, but hopefully, yeah, you can kind of see that potentially that's a quite nice, simple way of doing it. I mean, potentially you could remove that step and have type equals 1 in there as well, so you could just make it even slicker. Oh, what have I done there? Oh, because I've removed type at that point, so that's not right. Ignore me, I am not as slick as I thought I was, because when I did my mutate, it removes the so when I did this count without a count add, it summarizes, so it removes that type column. So yeah, I would have to do it in 2 steps. So yeah, I think there's many ways to do these things. Hopefully that makes sense. And yeah, hopefully you sort of start seeing how you can sort of build up those pipelines. And yeah, you know, even this stuff is really nice in that you've taken this horrible N thing and you renamed it to submissions. I like that. So let's look at conditionals. So conditionals, again, really useful thing to be able to do. So classic, a classic conditional is if this, then this, else that. And I think that's something we've all probably used lots and lots of different times. So what we can do is use this to create a flag in our data set. So I'm going to create a flag that says it's going to be called above 20,000. And if my attendances, oh, I should probably not have the equals there, should I, for complacent. Yeah, if my if my attendances are over 20,000, then say yes, otherwise no, and we can run that one through. And we have a look at our data. Oh my lord me. And we've now got a new flag, and we look at our attendances. That one's over 20,000, so we've got a yes, and that one's under 20,000, so we've got a no. So yeah, a very, very sort of simple conditional. If we just look at, let's just close some of these down, because I've got 4 tons of these open. You probably have too. Do feel free to have a little bit of a tidy up. So we just look at the syntax of that. So it sits within another function within my mutate, and I have a if else open brackets, and then I give it the condition that I want to look at. So I will say this is my condition, and then I do a comma, and then the next thing after that is the true outcome, and then the next thing after that is the false outcome. And we're purely working on a simple sort of Boolean at this stage. So we give it a something that's either going to return a true or a false. So what's very useful, very important, is that our 2 output conditions need to be the same data type. So in this instance, I'm going to say is else attendances over 20,000. If it's over 20,000, I'm going to give it the numeric 100, and then here I've given it 99999, but in speech marks. So that's going to treat it as a character. And so if I try to run that, it's going to give me a horrible message in that it cannot. So each column can only contain 1 data type. So I cannot combine double, which is my true, which is this side, which is my numeric, and the false, which is a character. So if I make it easier, if I put dog in there, then that would make more sense. So I can't convert. I can't have a column that contains some numbers and some characters. It needs to be one or the other. So yeah, that's just something to remember. So that will throw a wobble. So that's the very sort of most basic sort of if else statement within the sort of dplyr. And again, it's like if else, if it meets this condition, then do this, else do that. So that's a simple sort of if else statement. What we can also do is a multi-part conditional, or what's a case statement in SQL terms. So I'll try to talk through this for those people who possibly more Excel based. So now I'm going to create a multi-part condition, and basically it will go through all the different conditions until it finds one that is true and then return that. Else it will then sort of spit out something else. So I'm going to create a new variable within my mutate, and I'm going to call it attendance grouping, and I'm going to use the case when statement. Works, I say, very, very similar to sort of SQL processes. So, and what it will do is evaluate line by line, and as soon as it hits a criteria that meets that, it will return that as a result. So if my attendances are less than 5,000, I will return the text string less than 5,000. If my attendances are less than 10,000, it will go between 5,000 and 9,999. I don't have to do a sort of a between, because as I said, it will evaluate them in order. So if I have 2,500, yes, that is technically under 10,000. However, it would have already met this criteria, so it will ping to the first criteria that it meets. So having your hierarchy of stuff is really, really important. So for instance, if I had my code written in that order and I had something like 2,500, it would meet this criteria first and not go on to this one. So it always goes in the order of the criteria. And that's one of my super handy tips of the day, is if you press the Alt key and up and down arrows, it allows you to reorder your code. lines. So if you wanted to move things up and down, it's really, really useful. I know this is just mind-blowing for those people. So where you have got those like select statements where you're trying to select all your different column names, so if you have them in order like this, it's really, really nice that you can just move your code up and down, which is really, really nice. Literally, I think it was about 2 weeks ago I learned that, and mind blown. So anyway, where are we? Yes, so this will evaluate my attendances. It will go to this, blah, 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 until it gets to the end. And then if it doesn't meet any of those criteria, it will then go to this default, which will be over 25,000. And now it's deciding to back up my R session. That's interesting. So just wait for it to do that. I did not go to sleep, honestly. I feel called out. Maybe it's a national outage, I don't know, or something. Maybe it did it to everybody. Okay, well, hopefully we're all back in the room. There we go. That's okay. Either we're all asleep or it's the problem. I'm going to go with it's the problem. Right. So if I run this little lot now and look at my data, we can see now we've got an attendance grouping column, which looks at this attendances and then gives it a sort of a category, which is quite nice. And again, you know, if we wanted to sort of pull our data together in some bits, that's really quite helpful. So this dot kind of gives us the default for our else statement. So a case when is just a fancier if else statement, and the dot default is the else else statement of our case statement. There is an old school way of doing this, and you might see this, or you might have been taught this previously, where it's exactly the same, apart from instead of dot default, you give it a true and use the tilde sign, which is shift and hash next to your enter key over on the right hand side, and you give it a tilde, and that will give it the else or the dot default. I'm going to use the dot default because that just makes it easier. It just makes it a little bit clearer, I think, about what the default is. Also, just be aware that obviously these use a tilde across the line in order to say if your attendances are this tilde, and then you give it what you want to give it. So let's make a deliberate issue. So again, if anybody sort of check this, potentially, if I have a result of exactly 25,000, technically my groupings are incorrect, because 25,000 is not between 20 and 24,999, and it's not over 25,000. So I'm going to use a horrible piece of base R here, and if you remember my slicing method, so I'm going to use my data $ attendances, and I'm going to use 1 just to say that's I'm going to use my first thing within that data set, and I'm going to assign it 25,000. So if we run that, and again just have a quick look at our data, we can see now that we've hard coded into our data using a horrible piece of base R 25,000 exactly in there. So let's see what impact that has. And if we run this same case statement up here again, let's see where it's put that as a grouping. So where we've got that 25,000, it's given it over 25,000. So not so good. And let's try this. So if we instead of giving it 25,000, let's insert an NA into it, and we run it. We do that, and we run this bit again. So just have a look at our data, we can see now we've got an NA in there. And if we run this, it hasn't crashed. And if we look at it, again, it's evaluated that and it's given our default, and it's told us it's now over 25,000, which I think is not the right answer. So that's not good. So let's have a look at our case statement and see if we can make it work better. So let's see if we can catch that error, which I always recommend to do as your default. Never on a default, always have it so that that's an error catch rather than just your final grouping, because it just means that, yeah, you can catch any errors here now. So if we did this version and we did, obviously I've still got the 25,000 error, don't worry about that, we'll come to that in a minute. But now when my NA gets evaluated, it's not going to hit any of these. So if we look at that and run it, and we also look at our data, now we have an attendance grouping of error does not compute. Also, if I put my 25,000 back in there and run that one, and we look at it, again, it's picked up that error does not compute, because basically it's evaluated as 25,000. It's not less than 25,000. My next things, Amal, if you put that in there, you'll fix it, which would absolutely make sense what we should do. So yeah, if we change that to greater than equals, and we would probably change that to 25,000 and over would make more sense. So now if we run it with our 25,000 and we have a look at our data, we've now got our 25,000 and it's coming through as 25. Oh, I've added an extra zero in the end there. 25,000 and over, and we're looking much, much better. There we go. So that would be the way to do it. So I would always recommend that you have your output as your default as an error catch. So let's just try this and run my case statement again. If I put my null in there, and then yeah, it will then pick up that error does not compute or something on those lines, something that's going to sort of ping out at you that this is an issue. If you're evaluating numbers, obviously you wouldn't be able to put that kind of text in there to say error not compute. So I often put in 9,999 or -1, or just something that is going to be you know, make sense, well, not make sense within that group, so I can do a quick search. If I'm obviously expecting integers across everything, if I put -1 in there, then I know that I've got a problem. I can just do a quick scan and see a -1. Or if I put in 99,999, again, I can see that that's coming up and that's an issue. So what have we got here? We can fix this, which is what Amal said. As in the if else, the case statement, as I said, needs all possible results to be of the same format, and it will check that that's the case. So if I say you can't mix that column up with different formats, so yeah, if dealing with numeric, magic error number, I think I discussed about that earlier. And also you can sort of set magic error dates if you're doing like date checking. So, you know, if it comes out with, I don't know, 1st of January 1900 or something like that, then you know that you've got an error date. Oh, look at this, we've got an over to you. So add a column and call it whatever you wish. And we're going to do a case statement. So we're going to have one column, one new column. So we want to do definitely call it an immutate, and we want to do a case statement, and we're going to do a bit of a weird thing here. So if it's a type 1 attendance, we want the result that it returns to be half the number of attendances. If it's a type 2, we want it to triple the number of attendances. And if it's a type other, we want it to quadruple the number of attendances. And then have a default of something that if it's none of those, that it comes up with a suitable error, and we'll break it in a minute just to test whether your case has worked. So yeah, over to you. Okay. And this is a bit of a bonkers example, but let's see what we got. Oh, we'll get back to that in a minute. Anybody got an answer? Still chugging through. Oh, okay. Oh my lord. Whatever you wish. I mean, not literally call it whatever you wish, but well done. If I say type in, not in. Okay. Oh, okay. Nice. Alberto, that's a textbook answer. Well done. Even adding in the NAs in there, that was didn't even tell you to do that. Don't know if you stumbled upon that, but yeah, that was a good one. Yours didn't work, Catherine. Catherine, show us what you've got then. Pop yours in there. Let's see if I can fix yours. It's good to see. So let me. So Alberto got top of the class with. Oh, let's see if we can just. Oh, that's still not quite right. That's right. Okay, let's see if we can fix some of these ones. Yes, okay. So let's have a look at this one that does work. And we look at that. And we've got this bonkers thing which looks at our others and then times it by whatever. So that's great. So Catherine, let's have a look at yours. And run that one. So yeah. So again, it's telling you that we cannot combine a double and a character. So these are coming out with numerics. So it's doing a numerical calculation. And our default here is coming through as a character. So that is not going to like it. So we can either do, we can say default will be -1. So if we run that one through, and then we look here, we can see, oh, that's interesting. Let's see like type calculation. So that's come up with the same answers. Oh, because I've got, it's not the type is different, it's the attendances is an NA, isn't it? That's why. So let me just change my data. Oh, no. Type. I can't spell type. 1 to 5 to be. Oh no, so let me do it. Is it? No. Okay. No, I'll go through that in a minute. But yeah, for reasons that we haven't got into our learning on yet, it won't work. But I'll come to that in a minute. So that will work because now we've got the same data type, and our default, if we had any, would come through as a -1. Okay, let's have a look at Mike's. You missed the last bracket, so is that fixed now, isn't it?
Yeah, it's fixed now.
Okay, yours is fixed. Thomas's edit changes to wrong. Let's have a look at Thomas's. Same issue. Wrong. Again, you're trying to mix up numerics and whatever, so it's not going to like it. So as I can't remember who found it. Alberto said you can put in an NA in there and that will work, and that's quite happy. Or you could put in sort of 999999 or something like that in there, and that would have happy. So NA works because obviously it's just a blank, and then it will be able to fit in within there. So, but NA is the nice solution. And again, we're not necessarily, you know, we don't have. I've done attendances in here. You're not limited. So I could have, for whatever reason, my type count thing could work on attendances for those two types and use breaches for the other. So, you know, just be aware that you can really mess things up. Does it make a difference if you type? So this is a fantastic question, Catherine. Does it make a difference if you type double equals 1 or type equals 1? Yes, it does. And it's kind of a little bit interesting around that. So speech marks with that 1 would generally would convert that into a character rather than a numeric, and it gets a little bit more complicated. We're also complicated things a little bit because this particular data set we're using it as a factor, so it also gets even more complicated. But yeah, do we want them to be characters because of the other? Well, I guess we still want, these are this data set is that data, when we look at that format for our type, it has come through as a factor, so it doesn't see that 1 and the 2 as numerics, except it sort of does with a factor, and it's a little bit complicated. We'll get into factors in a minute and it might make a little bit more sense, but if they weren't factors, then they would be treated as characters. So that's the main point, is that that would be a character versus that which would be just a numeric. So yeah, is character versus 1. Oh, I can't spell numeric. I don't know how to spell character like that. There we go, fantastic. So yeah, except in this instance we're using factors, which has just made it even more complicated, but we'll come back to those in a moment. So that's using the dplyr sort of if-else statement and case when, and we generally do that with mutates or summarizes in order to create additional variables out of other bits and pieces. And again, you could do, instead of attendances, you could do attendances plus breaches or whatever you wanted, and do lots of different things around that, which would be really cool. And again, if you wanted to stick dot by in there, you could also do that as a grouping thing as well to make it even more crazy and funky. So that's the sort of the dplyr version of if else, which is very much a simple conditional, and there's also a base R if statement which works completely differently, and it works much more in a programmatically way, or and more in a sort of programmy type way, which is a little bit more complex, but we're going to cover it because you can do some really quite nice things with it. So base R if statement. So in base R we can just assign a variable with the number 5. So now we have a variable called A, and if we look at A, it is the number 5. And then we can do a base R statement. And what we have here is the base R statement is if, and then we have open brackets, and then we give it the condition. And so if A is equal to 5, and then what we have is curly brackets. So curly brackets are above your square brackets, off on the top right hand side above your hash. And curly brackets denote what's called a scope, and a scope is a piece of code that is not always necessarily evaluated. So it is, in this case, it's conditional. So if A is 5, it will then run this piece of code that's between the curly brackets. If A is not equal to 5, it won't do it. So it's just quite an interesting and quite a powerful tool in the toolkit to understand sort of the base R if statement. So let's just have a look at what this does. So if A is going to be equal to 5, then we've got our curly brackets, and then it will evaluate all the stuff it will run all the code that's within the curly brackets. So if A is equal to 5, the first thing it will do is then change A to be equal to 10. It will assign it to 10. It will then print A is now 10. It will then create a new variable, and it will assign it to the value of A, and it will say B has now been created as a variable and is now A. So as you can see, before I run this if statement, we have got no B variable, and A is currently 5. So let's just change this to 4. And if we run this now, hopefully we can guess what's going to happen, which will be nothing, because A was not 5, so therefore it did not do any of this stuff. It just went, nope, it's not 5, so I'm not going to do the stuff that's in the curly brackets. However, if I say A is going to be 5 and I run this, let's have a look at what that does. So first of all, we can see that our value has now changed to 10. We now have a variable of B, which is also being 10, and it also printed out that A is now 10, B has been created as a variable and is now A. And then likewise, if I run that again, it's not going to do it, because it's not going to change anything, because in this instance, A is not 5. Does that make sense? So that scope is all the stuff which within those curly brackets, and it allows you to do some really, really nice things. You know, if my data has come up with errors, do this stuff to it. If it's fine, just carry on. You know, or whatever it is you want to do, or and you can set up whatever sort of conditionals you want. So we can also add else's into our if statement, our base if statement. So let's have a look at, just kind of run through this in our head. So we're gonna make A 5 again, and we're going to say if A is equal to 5, run this bit of code. So A will be reassigned to 10. Print A is now 10, and we're going to create a new variable which will be C. C is A. C has been created as a variable and is now A. Else, it's going to print A is, and it will give us the value of A, and it will say C does not exist. So let's convert that back to 10 to start with. So yeah, my A is 10. I can see I've still got a B. We're not using B in here, and I've not got a character. I've not got C. So if I run this, let's just have a look, and it will tell us A is, oh no, it hasn't actually printed what A is. That's silly. It should tell us what A is, and it should have said 5. No, sorry, 10. But it does tell us that C is does not exist. I need to change that. Okay. So that's what that does. And if then I change this, yeah, I know I do. Thanks, Claire. I need to do paste, don't I? Let's just change that to paste, and it will work then. If I run that one through, there we go. Why is it not doing it? I need to print that. Yeah, no, good grief. Right. There we go. A is 10 and C does not exist. So there we go. So if I now make my A 5, we will evaluate this, and it will run this bit of code that's running in this scope between these ones. So if we run those, we can see that A has now been converted over to 5, and C has also been created and is 10. So hopefully that kind of makes sense. Yeah, that's quite a lot to go in there, but it's more of a case of just kind of understanding that you can create these conditionals, and then you've got these curly brackets, which gives us a scope. And if that condition is met, run this code within the scope, otherwise don't. And that does become really, really quite funky around what you can do and whatever. Okay. I should set up a test for you for that one, but I haven't got one. So again, note to self to add in a little to do. Does that that base R if statement makes sense? Has anybody got any questions on that before I move on? It's relatively straightforward, but it is very powerful, but it does use those curly brackets, which does get people a little bit scared and confused. Happy with that? Any questions on that? Okay, I'll take silence as silence. Okay. Group and mutate to make subtitles. Okay. So grouping and mutating rather than summarizing in order to create totals and percentages by month and organization. So let's create a total number of attendances across organizations. It makes my brain bubble a bit. There's some good stuff in there, but yeah, that's totally fine. Yeah, there's a lot to go on there. I appreciate that. So let's have a look at, is that going to fall over? I think it is, isn't it? Because no. So I'm going to create an extra column, or 2 extra columns on my data set, which will be the total number of attendances, which is going to be the sum of my attendances. And then I'm going to create a percentage of my attendances, which will be my attendance divided by that total number of attendances times 100, which will give me my percentage. And then I'm going to group it by my organization code and my period. So what that should give me then, for each organization code and for each date stamp, I will have my total numbers of 1, 2 and other attendances, and then it will give me a percentage of that breakdown across those. So if we look at my data total per OC, and I look at my RF4 for November, sorry, I know it's not going to work on that one because I've still got my dummy stuff in there. Let's I am just going to reset my data frame up here and go, where are we? Oh, I've lost it now. Oh, that's all horrible pivoting. Is that what we're on next to? Oh, no. Yes, that one. Sorry. Excuse me. Sorry about that. Just resetting my data again. And then if I look at my data total percentage, so I've got my RF4, my total attendances is my 21,813 and my 2,850, which makes this, and that gives me my total attendances. And then if I divide that by that, it will give me my 85, which is my 85%. So very, very quickly, by using that sort of mutate and that dot by, I can then create a percentage. So this is 85 plus 3 plus 11 plus all these horrible fractions will give me hopefully 100% of a breakdown of how many type 1, 2s and others across each time period for each organization code. Does that make sense? So I've got a very, very quick over to you. So that's a little bit hard to see because we have got these horrible big percentages, big decimal points. So can you round down those answers to 1 decimal place? So just take that and round them down. to round them to 1 decimal place. And yeah, just be very, very, very careful of commas and brackets are going to mess you up horribly. I apologize for that. If it's any consolation, it messes me up every time I do it as well. Anybody got a solution they want to chuck in the chat? Nice. So there are a couple of ways of doing it. So possibly the simpler way that does not involve lots of horrible brackets is, where are we? That method. What have I done? Yeah, that's right. So you basically write a percatend, calculate it, and then overwrite it with the rounded version. So if we run that one, that will then give us a nice rounded number. Or you can do the more complicated version, which is where the horrible brackets come into stuff, where we want to put that in a round statement itself. And that's where brackets get really, really messy. So that's putting it into a round function, and you feed the, I mean, hopefully you sort of found round. And yeah, it just takes in your digit and then you tell it down. Rainbow parentheses, yes, absolutely. I'm not using them here because I've been told it doesn't show up on the video terribly well. But for those people who are struggling, there is an option within tools, global options, appearance, is it? No, it's not appearance, it's in code. Don't remember. To display. Don't remember. Yes. So if you go code, display, rainbow parentheses, it color codes all your parentheses so that you can see that's a red one that matches that red one there, which is really good. So yeah, if you click that and you click this one on the bottom, it will come through. I'm just told it doesn't show up in the video very well, so I don't use them here. You can also sort of click or hover over a parentheses to make sure that what matches up with which. So we know that this round function has that open there, which shuts with that one, and then this little bit is subcontained within that. Quite often I've seen people do that, which is absolutely valid. It's just adding a potentially an unnecessary, or yeah, you can double click on the parentheses and that will show you what's contained within it. So if you want to go, where does that one sit? It sits there. What's contained within this one? Those bits. What's contained within these? It's just that. So again, really, really useful to have those little tips. I mean, RStudio is a really lovely tool for helping you write code and to do all these bits and pieces. So yeah, massively cool little tip. Thank you, Claire, for reminding me of that one. So that's really, really nice. And okay, we've got a horrible piece of code here, and it's more for you to be aware of and kind of get your head around rather than actually understand and actually be able to code. But very traditionally, we look at sort of doing stuff in sort of column form, in sort of across our rows, and we have nice data that we do across. But say, for instance, here I wanted to do my attendances, and I've done my attendances across my total attendances, and maybe though I want to do that across my attendances, my breaches, and my admissions, and I want to do that all in one go without having to repeat myself. So I've got a whole load of numeric data, and I want to create that same percentage and do that all in one go across everything. So that is possible, and this probably came out from a question that somebody asked. It's like, I could do it for one, but how would I do it for all of them without having to repeat yourself? So I guess that is part of as you get better at R, is you try to write less code because you don't want to repeat yourself. So what you can do is this little thing here, which is a little bit more complex, and I'll try to talk through it. I'm not expecting you to learn this or get this. Kind of be aware that this is there, and when you have 10 minutes, half an hour, come back to it and see if you can unpick it and to do what it's doing. But if I try to explain what it's doing, so it uses this thing called an across function. So rather than just picking a single column, it's going to work on several columns at once. So it's going to work across columns all in the same go. So first of all, I've got to tell it which columns I'm interested in, and I'm going to use, a bit like we did previously, a tidy select, where I'm going to select anything that is numeric. Here I could specify and give a vector of which columns I want to use, so I could just do that, or I could say, I could use all those select verbs that we had earlier, like starts with or contains or whatever. But in this instance, I'm going to look at any column that is numeric, and that's what I want to have a look at. And then I've got a lovely tilde, and that says, so where I've got a column that is a numeric, do this to it. And this is where it gets a little bit messy and looks a little bit confusing. I've got this dot. So this dot is basically a placeholder for the column. So it's going to do exactly the same as we did up here, except instead of saying specifically I'm looking at my attendances, I'm just going to feed in the dot, because it's going to iterate over several things. And then it's going to take the first thing, the first thing that is the first column it meets, and then it's going to divide that by the sum of that thing, times it by 100. It's then going to name that new column, and it's going to give it a perk underscore and then the name of that column. And again, we're going to do that by the organization code and the period. So believe me, I'm not expecting you to remember this or do this. This is just kind of an example which hopefully you can come back to and have a look. So if we have a look at what that has done, it has now taken each of our numerics and has created that percentage across, for each one. So now I've got percentage of attendances, percentage of breaches, and percentages of admissions. And if I had, lots and lots of numeric data all in one go, and that would do. So is the dot always a column, or can it be a tibble? No, so the dot in this instance would always refer to the column. And how comes I've used the tilde? It's a function of the across bit, because it's a bit of a weird thing. It's like where it's doing this, it's kind of using Claire. I can't remember, I don't know if Claire's still here. Are you still here, Claire? Did we come up with an English version of what the tilde means?
You can think of it in equivalent to when you're giving small functions in line in R, and you sometimes use uppercase FUN, fun, to know what your function is. So tilde is sort of a shorthand for saying, to the stuff you've just selected, all your numeric columns, what are you going to do to it? And that's just what the tilde means, is then do this.
Then do this.
Okay. Yeah, kind of. It's not really a nice.
No,
phrase,
I say, like, double equals is like is equals to. And and a single equals is just is equals to. But yeah, we'll have to try to think of one. But essentially that's kind of what it's doing. And here's just an example that's using a tidy select version instead. So this version's just going to pick up those that have contains the ES, which if we have a look at that, I think it's just obviously just going to do percentages and percentage breaches. But yeah, I would definitely come back to that. This is, you know, definitely urging on to the advanced stuff. And also I would very, and we're going to come on to it in a minute because we come on to pivoting. Generally, you would want to make your data set a long data set and work on stuff within columns. You do not want to be working across or down. If at all possible, you do not want to be working across. If we had a type, I don't know, an extra column which was a breakdown of attendances, breaches and admissions, doing that kind of stuff you could just do in a, you know, you could use a simpler format to do. So this is quite a bad data set in that it's a wide data set rather than a long data set. So I would always try to, you know, if you are trying to do stuff across multiple columns, it's like, well, why can't I make that into one column and do it across, you know, if we had, I don't know, attendances, breaches and admissions in a separate column that said, I don't know, I can't use type, description or something, then I could add in an extra grouping feature by description, and it would be a lot easier to do it that way and then convert it out wider afterwards, rather than using these horrible across functions, which are great, but you know, that's not very human readable and it gets really messy. So yeah, but it's there, and you know, do come back to it if you want. Just a quick one on row wise operations. So these are quite nice sometimes if you've got sort of row wise stuff that you want to do. So let's just create a new column that's just going to look at our attendances, our breaches and admissions, and try to pick out which is the maximum of those, but for each column. So for each row. So we can just use this row wise, and this is, again, this is old school, so we're going to do an ungroup at the end of it. So if we look at our data now, we have got a new max column, and it's just going to pick out of these three for this row, which is the maximum. I'm just trying to think if there's any here that's it's going to pick anything else than the admissions. I don't think attendances. I think attendances is always going to be higher, which is a bit annoying. Let's try, if I did min, that might make more sense, wouldn't it? And then we look at that. Yeah, we can see obviously it's picked that one for here, and it's picked that one for, it's picked the 0 for here. So it's just looking at each row, and it's just doing a row wise operation. And essentially that would be the same as grouping everything, absolutely everything. So it creates each row as its own individual group, which is why you need to ungroup it at the end. But that's quite useful. Okay, we're going to get into pivoting wider and longer, which is a bit of a mare. Let's just take a quick 5-minute break, and we come back at, or let's do, yeah, 7 minutes. If we come back at 12 minutes past 5 with your best thinking hats on, and then yeah, we do some pivoting. But do feel free to chop any other questions in the chat, and yeah, we'll go from there. And then I think we're straight through till lunchtime then. Okay, hopefully everybody's back. So let's get some serious brain work in there before lunchtime. So pivot wider and longer. So hands up, anybody who's ever done a pivot in SQL before? Dan, you're a crazy man. Thomas, you're also a crazy man. Okay, so the good news is it's not as hard as that. No, it's not fun. So it's definitely not as bad as it's not as bad as SQL. So there is that. Hands up, who's done a pivot in Excel before? Catherine. Well, hopefully most people. Yeah, there we go. Sadly, it's not as easy as that. So somewhere in between. But potentially with a bit of our extra power to it as well, that we can do some bits and pieces. But you kind of at least kind of understand the concept of sort of what we're doing. Although it's more about the data structure. I mean, we've done a lot of pivot tables when we're doing our sort of summarize type functions. This is more about changing the data format. And let's have just kind of do an example. So say we had some data that looked like this. So we had our organization, our period, and our attendances. We've got our organization code in one column, our period in another, and our attendances in another column there. Say we wanted to convert that, and we want to pivot our data. So instead of having it in sort of this long format, we wanted it in a wider format, so that we had just, instead of 3 observations of let me just get this right, of 3 variables, we would have 1 observation of 4 variables. So we would have 1 org code, because it's all the same, and then we'd have separate columns for January, February, March, and then our actual numeric would be our number of attendances. Does that kind of make sense, what we're trying to do? Everybody kind of happy with that? Does everybody get that? Otherwise, numbers is going to make any sense. So we're trying to get our data that's in this sort of format, and we want to twist it around and sort of make it in that format. And also later on, we're going to take data in this format and we're going to convert it into this format. So let's just start with a bit of data and just do it in really simple. Have a look at it. So we got our data. We just got to filter it down to 1 organization, 1 type, and 1 period, and we're just going to select our org code, period, and our attendances. So hopefully it's going to look very much like this. So if we look at our data long, wherever that's gone, literally we've got a virtually identical data set to what I've just described. So we've just got our organization, we've got our periods, and we've got our numbers of attendances. So what we want to do now is shift it from a long data set into a wide data set. So what we can do is use a pivot wider function. So we can take our data long, and we want to convert it into data wide, and we can use this pivot wider. And what we need to tell it is these are the names that we want for our columns are going to be taken from the period, and the values that we want to put under that period we're going to take from the attendances. So probably make more sense when we run it and have a look at it. And now if we look at our data wide, which I can't find, where's that gone? Does it only work on 1 code? No, we'll get to the fancy stuff in a minute. But yeah, but if we look at that, now we can see we've got 1 organization code, and we've got a separate column for each one. Yeah, we will get to them more. I'm just trying to keep it nice and simple to start with, because so as you can see, we went from data long, which was in this format, and we've now split it out into wide. The reason where this also gets a little bit messy is obviously we know this number here is our attendances, because we know that there's nothing now in this data set that tells us that that's the attendances. We just have to know it. So yeah, just kind of be aware of that. So let's just run that again, and you guys just run it. So do it exactly the same as I did, but this time do it for breaches rather than attendances. Yeah, we will do wide to long in a minute. Good grief, you guys are so excited by this pivoting of data. I know. We will get to, yeah, wide to long. And without a doubt, when you are writing code and you're writing stuff to do stuff across code, working on long data is far, far, far easier. And especially if you can imagine, if I've got data in this format and I want to chuck that into ggplot, that's really simple. I can do that, I can do my period x equals period, y equals attendances. If I've got data in this format and I wanted to do a ggplot, yeah, absolutely a nightmare. So generally, long data is much, much easier to work with. It's much more explicit about what it is. So we will get into using long data where we can. Right, Simon, shut up. What we're doing breaches. Let's have a go. So I think it is just literally a copy and repaste job of attendances to breaches. And same with no, where are we? Here, isn't it? Breaches and breaches. But I think that again just highlights when we look at our data wide, there is nothing telling us that is now breaches. We just have to know that. So that's kind of important. So let's do a slightly more complex version. This time we're going to copy that same code again, but this time we are not going to have it by type. So we're going to have multiple types for our data set. And we've also got to include it within our select statement. So if we look at our data long and we run that now we've got multiple types for each date and attendance. So as you can see, we've added an extra feature. Potentially we could have added in some extra organization codes, but we've done it this way because of reasons. So let's do the same again, and we want to do a pivot wider, and we want to do names from the period, and we want to do values from the attendances. And if we run that and we look at our data wide, and a pretty fair job for us. So we've kept our type, and now we can see for our organization code that split it down by the types, and now we've got a separate date column for each one. Okay, does that make sense? Everybody got that? Kind of what we're doing. So who was it who was jumping ahead and wanted to do separate sites? I can't remember. Was it? No, it was that Catherine, wasn't it? There we go. So Catherine, let's answer your question exactly then. So let's do same again, but with sites this time, and again not removing the type. So this time we're going to have more of a complex data set, and we look at our data long. So we've got multiple sites with multiple dates, with attendances, and multiple types within that. So there's a breakdown within a breakdown within a breakdown. Okay, so let's have a look at that and see what it does. And again, we've got our names from, and we've got our attendances, and we run that one through. And again, that's done all the magic for us. So we've got our organization code, it's broken all those down, it's given us our types, and again, it's split out all those dates and it's put them across for us, which is nice. Okay, so that's quite good. So now let's just make it even more complicated, because obviously at the moment we've just been having that date, and we've just been having just attendances. So what happens where we've got another dependent variable? So if we want attendances and we want breaches this time as well. So let's have a look at this, and how does this one work? So we've got our data long, and just have again, let's just have a look at it. So this time we've got our organization code, we've got our period, and we've got attendances, and we've got breaches, and we've got a type 1 and other. So it's getting a little bit more complex now. And let's just run that again as we did previously, because this little thing has been really simple up to this point. We can do pivot wider, names from period, values from attendances, and run that. And look at it. And oh dear. That's probably not what we're after at all in any shape or form, mainly because we've split out the attendances, but we haven't split out the breaches, and it's all just gone hideous. So that's not right. So let's just reset the data again back to how it was. And this time we want to add in our values from attendances and from breaches, because we want to expand both of those. And let's see what that does. And if we look at our data wide now, oh, it's done something quite funky for us. So now it's created these new columns for attendances across each of the dates. And also, it's created new columns for breaches across all of those dates, which is much more what we're after. Fantastic. So yeah, so as I said, it's given us some automatic new generated column names, which are not just from the period, it's also sort of concatenated them with the values as well. There are, if we press F1 on our pivot wider function, there are all number of features that we can add into our wider, and it will do lots and lots of different things. So for instance, when I did that first or I did that mess up, and I realized that when I pivoted the data, there were some bits missing. So you know what you can tell it that when you pivot your data and you've got missing data, what to fill the gaps in with. So you know, rather than just coming off with an NA, you can replace it with a 0 if that's what you wanted. You can also give it sort of much more explicit naming convention if you so wished, and you can sort of tell it how to do that. And there are lots and lots of different arguments that you can give things, how it repairs the names if it's creating duplicates, and yeah, lots of other different things. And also at the moment we've just taken those values from, and we've just used the straight attendances. If, for instance, we wanted to have a function in there, so a bit more like a classical pivot table in sort of Excel terms, and we wanted to make those percentage over month or you know, the mean or something, we could also have it so that those values from actually use a function as well. So we can actually create sort of pivot our data and do functions on it at the same time. I wouldn't necessarily recommend doing that because that does get quite complex to unpick, but it is an option. So does that make sense? I mean, again, it's kind of a very, very quick run through of whatever. I think we have got an example for you to do in a minute. Let me just double check. I think there's a over to you. Oh no, there isn't. So yeah, any questions on pivot wider before we go on? Pivot wider is the easy one. Pivot longer is where it gets a little bit more messy. But hopefully you can see it's relatively straightforward. And you know, if we had our data set, you know, potentially we could make our entire data set longer, and that would make it a lot easier to work with, because at the moment we've got our attendances, breaches, and whatever the other one is in separate columns. Okay, let's start with a wide data set again, and we're going to start with our basic wide data set, which is data wide. So sorry, data long, sorry. start with our long data set again. So start with our absolute basic one. And then we're going to make it wide. So this is what we've got. This, and imagine now this is your starting position. So you've been given a data set and it looks like this, and you want to convert it into a long data set. So this is our starter data set, and we want to convert it into a long data set. So this is definitely a lot more complex to do. So let's just now, if we can make it long, so let's kind of convert wherever. So first of all, we've got to tell it which columns we want to actually pivot. So if we look at our longer data set, we don't want to pivot all code because that is our number, is our standard, but we do want to pivot all of these ones. And if we look at those, they are all coming through as sort of numerics. All the data types of these columns are numeric. So we can just say, in this instance, I want to pivot all my numeric columns. That otherwise, I might have to say I want to pivot, and you could feed in a long vector of I want to pivot March 19, February 19, January 19, December 19, blah, 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 blah. And you would have to put each one in individually as a way forward. Or I could do pivot everything that starts with a 20, because that would also sort of identify them. Then maybe that's the way. Or every column that ends with a 0, 1. That would also do it. So you've got to try to find a way of trying to minimize the amount of typing you want to do. And in this instance, I said, actually, I want to pivot all of my columns where it is numeric. I want to change my name to the period, and which is going to convert that period into a new column. It's going to convert. So my names to is what my new column that contains the old column names is, and then my values are what values I'm going to put in those boxes. And again, that will make more sense when we actually run it and we have a look at it. So if we run our data long, so it's taken all those ones where it's numeric, it's changed it to period, and it's changed it to attendances. So if we look at that again, this looks much more sort of old school, how we back were. So just to confirm that this is what we are doing, if we do new and change that to new, so we still got our data wide, which is this, and then when we convert it with our data long, just to show it's not just showing the old original data set, this is the new data set that we've created from that wide data set. We can confirm that because if we look at our new period in our data long, we can see that these dates are not coming through as dates, they're coming through as characters. So we would have to do a further bit of wrangling in order to convert them, because obviously when the data was in a wide format, when we converted it from those dates into column headings aren't data type, they're just going to be characters. So when we've converted it from the character back into a long data set, we've converted it as a character. So this has come through as a character rather than a date. Does that make sense? Any questions on that? Do shout, please. Okay. So, yeah, I think as it says there, not gonna lie, pivoting wider to longer is a lot more complicated and does require so much more fluffing about in order to get things into the right format and all of that, and just moving everything around is a lot more complex. So generally try to avoid wide data if you can help it. However, those sort of basic principles are the same, and there are some absolutely great tutorials out there on how to do it if you do have sort of more complex examples. But I think the hardest bit is just trying to do some of this stuff where you just want to identify certain columns at a time. And it's also worth knowing that sometimes you can do it in multiple stages, so you don't have to do all your pivot in one go. You can pivot half the data and get it in the right format, and then run another pivot on that to run another one. And I think I've solved quite a few issues by doing that before, rather than trying to make one pivot longer that does it all in one go from wide data sets, especially if you have got things like attendances, breaches, etc., and it's all in separate bits. Sometimes you'd have to like pivot each one of those sort of separately in order to make a longer data set. So yeah, I'm not going to go massively into it now, otherwise we will go down a rabbit hole. So let me just have a look at the next section. Yeah, I think we're good. So we're into 1, aren't we? So yeah, we're good. Oh, sorry, it's beaming down on me. So now I'm in the witness protection. Let's have a little bit of light. There we go. So let's have. So yeah, any questions on pivoting before I move on? Yeah, Dan's mentioned that you can do operations when you pivot, but probably bad practice. I think yes, because I think pivot is quite complex to understand, and I think if you're adding an extra level of complexity to that, I think it's just going to make your code a little bit unreadable, and yeah, potentially, I don't know, it's just adding an extra layer of something that could go wrong. Whereas I think there's nothing wrong with doing it piece by piece. Claire, have you got anything you'd add on pivots apart from it's horrible?
It gets easier, like everything in R, but yeah, it can be horrible. Being really clear in your head what you want to do before you start playing with the code seems to help with pivot. Like if you have it in plain English, that you understand that you want to keep the X and Y columns the same, but pivot everything else, that can really help, because you can get yourself into a bit of a rabbit hole otherwise.
There was, I'm just trying to remember if I can find it. Is this? I'm just trying to remember. I think, is this the one? You know, like a squeeze for ggplot. I am sure there was an equivalent for plotting. For pivots. I'll see if I can find it. So I think there is something where you can put your data into it, and it almost brings up a little add-in to do pivots. I will find it, and I'll definitely have it for tomorrow if we can't find it now, because I haven't got time. But yeah, note to self, I'll have a look. And again, if you are struggling with pivots, it's one of those things where you kind of do it on the screen and then it'll write the code for you, which is nice. I've definitely seen it. Anyway, we're going to do some rolling functions.
Sorry, Simon, just one. I did just think of something there as I was looking at your code. You will forget which one of pivot wide or pivot long uses names to or names from, and I forget that every single time. But if you just start typing it, it should auto fill for you and give you the right one. So don't worry about that.
Yeah. No, I think that is the big thing about, and again, it's even took me a long time before I even worked out which one was which, as in I've got my data in this format, is that long or is that wide, what am I trying to do with it, and just even knowing which one to start with is just a mess. So yeah, I totally get that. So we're going to do some rolling functions. So we're going to do some we're going to use the library zoo now. So I am going to add that into my little list up the top here. And we're going to use the zoo library, which again, some of these libraries sounds much more exciting than they are. And we're going to run zoo and we're going to install zoo. There we go. And where's zoo? It's fine. There we go. Back to zoo. Or you can do tools, install packages, and install zoo that way. Oh no, cancel. Anyway, because I've already got in there. Right. So that installs Zoo. So I'm just going to cleanse my data because I think I've been messing about with it a fair bit. So say we wanted to create a 6-month rolling mean of our attendances by each of the sites in our data. So yeah. So rolling means very, very sort of classic way of trying to sort of do some sort of smoothing over data sets, especially if you've got longer data sets, you know, doing a 12-month average just to sort of remove seasonality is a really, really good one. So yeah, it's you know, it's a really good function to be able to do. So we are going to create a new data frame called data role. I'm going to filter my data down just to 3 sites, just because it makes it a little bit easier. And then I'm just going to arrange it by the organization code, the type, and then the period, just so it's nice and tidy. And if I just run that bit to start with, and we can have a look at what that looks like. And again, this is one of those really nice things about R, is like I can just see what that bit looks like without having to run the entire bit. So if I look at that, I can see I've got my period, my organization code, my period, and by type, and then I can just see, obviously, it's just ordered those in that way, and I've got a little data set. So now what I want to do is add in a rolling average to it. So I'm going to use mean in this instance. So I'm going to use rolling, and I'm going to use this roll apply, and this roll apply is from our Zoo library, and basically it allows us to sort of add in various bits. So I want to do a rolling apply on my attendances. I want to do 6 months, so I'm going to do 6 months. The function I want to do on that rolling is a mean. However, I can put in other functions as well. So for instance, if I wanted to find the 6-month max, so the maximum value on a rolling 6-month basis, I could put max in there, and that would do it as well. How does my window align? So I want to align it to the right, which means if you can imagine again our data in that wide format, and it's all in date order. If I put my window on the right, it means that it's always looking at the past 6 months to create that, and it's putting the value on the right hand side. I could put the alignment in the middle, in which case it's going to take the previous 3 months and the next 3 months and create an average and put it there, or I could put it on the left, and then it's going to be looking to the future for the next 6 months and do that in there. And then where I'm going to have blanks, just fill those with NAs. So for instance, because I've got a right-hand line, my first 5 months are going to be empty because it's not going to be able to create a mean because I've got null values. So it's not going to do those. And then I'm just going to do that by organization code and by type. So there's a lot going on there, but let's just have a look at what that does. And if I look at my data role, what we can see is this has now created our rolling average. So for the first 5 months, it's going to come through as null, and then it's going to create, this is the average of these 6, and then this is going to be an average of from here to from here to here, and then this one is going to be doing from here to here. So yeah, hopefully you can see that. Oh, why is that doing weird stuff? Okay, yeah, hopefully you can then see what it's doing is a rolling average. And then as we jump on to the next either organization code or type, it will then give us our 5 NAs and then it's thing. So it's also grouping it, so we're getting a rolling average by each of our organization codes and by our type. And it's all important that we added that arrange in there first so that we've actually got our data in date order. Otherwise it's just going to look back at the previous 6 entries and just do it based on the order that they're in the data frame rather than necessarily the date order. Does that make sense? Because now we've got a bit of an over to you. So see if you can change that code above and change the window to 3 months. Add in an additional column with the median over the 3 months. And with that median, see if you can calculate it on the middle time period, so that it's the median of the month before and behind and the current month. And then also replace any blanks with 9999 instead of NA. So that should be pretty straightforward. But, you know, you could also have a rolling thing. So, you know, it's always going to calculate the total of the last 6 months or something along those lines. So you could do a sum instead of a mean. So, yeah, the roll apply is a really nice little function. You could do a roll apply of 1, which would give you a very basic lead and potentially lag function, although there are lead and lag functions that do that specifically. I don't think I'm going to cover them now, but yeah, if you did want to do things where, you know, lead and lag, that's totally possible. So, as always, just press F1 on the rolling function and see what we've got. Oh my goodness me, this one's a bit messy. So we've got what was the question? Change the window to 3 months. So the window in this instance is called the width, and this is the sort of the window width as in number of observations, and we want it to be 3. So we can just change that to 3. We want it to be the median. Oh, actually, just to show, we can actually add it as an entirely different column. So we can call this one rolling mean, and that one rolling median. So we wanted to do a window of 3. We want to do median. We want to calculate it on the middle. So how do I say middle? Well, I've got options of left, right, and center. So I want to put in center. 5 points if you managed to use the help function and worked out what the alignment for middle was. That was a reason to go into the help, and also fill equals 99. So yeah, when you're not sure about, okay, well, how do I get it into the middle? Because obviously if you put middle in there, it isn't going to work. Where do I find what the options are? Help is your friend. Yeah, because here it will tell you what are the options that you can put in. And might even give you some, I don't know, examples with it in. Well, these look really quite complex. Okay, so if I run that one and look at my data roll, so I can see that my mean has come through here, and then this, why have I got 90? Oh, saying why have I got a 99? 99 was my default position, wasn't it? So yeah, that doesn't make sense. It probably would make more sense if it was an NA, but I can see that that is the median of those 3. That is the median of these 3, etc., etc. And yeah, we see that's going. And also what I would expect to see is a 99 at the end of this little group, which is this little group here of our RDD ones. And then, yeah, we can indeed see that the last one is a 99 because that's come out as a default because it's trying to find the median of these 3. Just wondering if you can do NA or LM equals T in that. Not sure if you can. it doesn't like that. So I was just saying if there's a way to ignore the equals NA. Just wondering if there was a way that you could fill in. Yeah, it came out with it would just remove and it would just find the medians of the ones that you have got. Not sure whether there's partial work. Is that what that is? I don't know. Voyage of discovery. Yes. Okay. So is that right? Yeah. So if you use the partial equals true, that will then just take, instead of doing the let's just change that to NA because that will make more sense. It will just take the median out of those two, which I'm guessing, yeah, should be 10967 plus 11812 divided by 2 is, yeah. So yeah, it will then create that median just out of the available ones and not then throw an error if you did want it to be complete, which is pretty cool. Okie dokie. Did everybody get that? Okay, let's do row numbers super fast then, and then we can I'll let you have the rest of the day for your brains to dribble out your ears. Any questions on the role apply? Again, I think lead and lag functions is something you quite often have to mess about with, and also, you know, if you want to do sort of rolling stuff is quite common, especially if you are trying to sort of smooth things out in data sets. So row numbers and date manipulation. Oh my goodness me. So row numbers and ranking stuff is really, really cool. If you want to do things like, well, okay, this is my patient, I've got their number of contacts, but how do I identify which is their second contact? Because what I want to calculate is my referral to second contact and things like that. So how can I give all their contacts a number and to do that in order to order them? So, you know, that's quite a common thing that we have to do. Or, you know, how do I know whether, you know, what patients have had 5 contacts, or what is their 5th, or more specifically, can I identify what is the outcome of their 5th appointment, or whatever we've got. So row numbers are, you know, really, really cool. So, and there's also several ways that we can do it, and I don't know, definitely within SQL you would do all your partition by and over stuff, which gets really messy. R does it really simply, and I don't know there's an equivalent in Excel, to be honest. Is there a row number function in Excel? It's not something I've ever used, and I definitely don't think you can. Yeah, I don't know, there must be, but anyway. So at the most simple level, we can get our data row. I'm sorry, I'm just going to start and have a look at this and look at our data row. Let's show it raw before I add lots of stuff to it. That button there, data row. So I'm just going to take a sample of my data and we're going to look at it. And what I'm going to do here is basically mutate a new column called row number, and I'm going to use the row number function. This is really bad practice, Simon. Never call a variable the same as a function, because then you're just going to get really confused. So that's a variable name, which is called row number, and that's the function called row number. So now I have got a row number, which is basically just going to give all of my rows a number. Who'd have thought it would have been that simple, eh? Which is great. What we can also do is say we want a row number per organization code. Obviously, we haven't got a complex bit here. So imagine each of our organization codes is a patient code, and I want to know a row number for each of my patient contacts, which is going to be my my period in here. So let's run that one through. And if we look at my data row now, I can see obviously I've got a row number for this there, and again, when I get onto my new organization codes, it's given those a new number, and likewise when I've gone on to the next. So it's given each organization code has got its own sort of row numbers, set of row numbers there, which is great. What we can do is a dense rank, which will basically instead of a row number per organization, I want to do a row number per period. So I want to know, because obviously if we go back to our data here, we can see we've got several that are the 1st of April. So I want to make all the 1st of Aprils, give them, oh God, it just so happens in this case that that's the case, isn't it? All right, that's, anyway. Just let's pretend that they were this wasn't here. It's just the quirk of the data. But say I want to give all my period ones, all my first periods a row number of 1, all my periods of all my second periods be 2, etc. It just happens to be that that is the quirk of this data because I sorted it already. But anyway. So this time I'm going to take those, I'm going to arrange it by the period, and then I'm going to give it a row number per period. So let's have a look and run that one through and have a look at it. And that has done what I've said previously, but without having to do a group, because here I had to group things by the organization code and the type. Here I'm just giving it a row number directly based on the period, which makes it a lot quicker. So here I'm doing a dense rank, which means all everything that is matching will have a 1. So, and then the next thing will have a 2, and the next thing will have a 3. What we can also do, I think, is that the next one? Oh God, yeah. So yeah, again, this was based on somebody's question. So yeah, this was a horrible student question to say, okay, that's great, Simon, but say I wanted to know which was the latest period and then work backwards. So how can I give my period? So the row number 1 will be the latest thing, and going back to the oldest, which is just horrible, but kind of did it. So I had to, let me just remember how I did this. I had to do a row number which worked on the dense rank of the period, did a descending on that period, and then had to convert it into an absolute number because it would convert it into a reverse. So hopefully that kind of makes sense. So if I run that one and we look at the data row, now we can see the latest. If we see the latest data now has row number 1, and then we sort of work back in time. So as it gets older, it gets is that right? Doesn't look right. Yeah, no, that is right. Yeah, and as it gets older, it gives it the inverse number. The other way that you can do stuff is we can do a min rank. So a bit like when you're at Olympics, if we get a tie for first, what we then jump to is the next person would get first. So instead of going 1, 1, and then the next thing being 2, what we can do is 1, 1, and the next thing being 3. So that's using a min rank. So that basically jumps the missing rank. So if we run that one and have a look at our data rows, so we've got these guys are all tying for first place. So therefore we've got 7 people at rank 1, so the next thing then will be rank 7, and then 13, etc. So you can use that sort of method to look at your sort of row numbers as well. How are we doing? We're doing all right. We're doing good for time. So we can also do things like just check if we remove 2018 from our data set and then recheck it and just see whether that's worked. So just going to do a bit of bonkers filtering here. So just to show you the between function, because again, that's really quite nice. It's something you can obviously do in SQL quite well. And then instead of saying I want to filter this to be above this state and below this state, to do a between, you can just use a between function and say between, and I want this period to between this and this. So if we look at, if I just run that little bit and look at my data row, we should be able to see that 2018 is mysterious, is missing. So we've removed 2018 from the data set. And again, just to sort of confirm, I've put a bang in front of my between or exclamation mark. So I'm saying filter my data to these organizations where the data set, where the period isn't between these dates, and then arrange it and then add my row number by the organization, by the whatever. And again, that just adding straight simple row number at this point, and we can see that even though 2018 is missing, it's just, you know, it's just continuing, it's just giving it a flat row number. So yeah, the bang is super awesome. So for instance, what you could do is I could put it in org code and I could put a bang in front of that, and that would just reverse my filter now. So instead of filtering it only to those 3, it would filter my data to everything except those 3, which is quite nice. So yeah, bangs are great. So here we go. Adjust the code above to remove the year 2017. Return only the first 3 rows for only type 1 admissions. Oh, sorry, only type 1 for each organization. And then I think we are, yeah, I think we're done for today. That's a pretty good chunk. So, and also see if you can do it all in one pipe as well, as in one go. I think that, yeah, I think the previous version is, but yeah, make sure you got it all in one go. Okay. Oh, let's have a look. So let's copy this malarkey. So we want to move 2017. So that's quite easy to fix. I think I've got that one. What do we want to do? We also want row number for all of those. And then we can also just add a filter in at the end, can't we? Row less than 3. Oh. Better. Is that right? Don't remember. So what's the question? Remove 2017. Return only the first 3 rows for only type 1. So do we want to? We could add that in here, couldn't we? No. Where are we? Getting my brackets muddled up. We could do type equals 1 there. Try that one. Data row. Everybody got something that vaguely looks like that? Or not? Yeah, good. I think some thumbs. Yeah, excellent. Blimey. Okay, we are at 1 o'clock, so, or 3 minutes to, so I think we're going to call it there. I think that's definitely a good section. We got through Yeah, we've got through a fair chunk. Some of the stuff, yeah. I appreciate some of the stuff today. We've probably whizzed through really, really quickly, and you've probably run the code and gone, yeah, that kind of works, but I'm not sure I fully understand it. Hopefully it's enough to sort of see what is happening, and without a doubt it's kind of a go back to it and go, okay, I need to run it through with some more examples to make more sense of it. But hopefully there's enough examples there that you can start thinking about, okay, how does that work, some of the stuff we'll do in a bit. We will also pull on some of how do these bits all join together, and how do we sort of pull them all together. So hopefully we'll see you all bright and early tomorrow morning, and we will do some more of this stuff. If you want to, if there's anything that specifically you want us to cover, we should have maybe a little bit of time at the end of the session tomorrow. If there's anything specifically you want to cover, or you want me to dig out resources for, or whatever, do pop it in the chat now and I'll have a look. And yeah, play back multiple times, listen to my lovely dulcet tones on slow mode, and make sense of it all. But yeah, if there's anything particularly you want to that doesn't look like we're going to cover, then yeah, do chuck it into the chat, and we can pick up on it tomorrow. Otherwise, look at this, a massive 2 minutes early, and yeah, go and grab some lunch, and yeah, hopefully your brains don't fall out your ears.
Thank you, Simon.
No worries, and more tomorrow. Right, cheers all, see you tomorrow. It's good to see people coming back for more of this nonsense.
I wouldn't say it's nonsense, Simon. So
it's not nonsense. Hi, Louis. Hi, Philip. It's all coming through at random, so I can't say hello to everybody. Hello, Catherine. Hello, Thomas. Hello, Sean. I think there were, I can't remember how many people there were. I think there was roughly 20, so I will give it another couple of minutes for people to rock up. Morning, Paddy.
Morning, sir. How you on?
Yeah, not too bad. You ready for more?
Don't know. I'm still in shock from yesterday.
Yeah, I appreciate it. I have had feedback that definitely there is a lot going on from the lovely introduction course, which is very, very mild and gentle. This course is quite a ramp up. I appreciate that. Hopefully you see that it all follows that same sort of syntax and method, and it's just using those same sort of syntaxes and methods that you've used in that introduction in more advanced ways, and just kind of getting your head around that a lot. Without a doubt, things like using the help functions are super, super helpful. And I also appreciate, obviously, there's a lot more here where I say over to you and you guys have a go. Yeah, I think we did really well yesterday. From my perspective, we whizzed through a heck of a lot, so we may have a little bit of time at the end today. So I will do a quick recap of what we did yesterday, which is basically just skip through the thing. If everybody can just put in the chat if there is anything sort of more specific that they would like potentially to cover at the end, or if there were any bits that we did yesterday where we kind of touched on something and you say, oh, actually, I'd like to go a little bit deeper in that, chuck it in the chat and I'll see what I can do. No promises, but if you chuck it in the chat, we can see. And then, yeah, just any other feedback around just the speed of stuff, because obviously I know I whiz through it really, really quickly. And if you are getting if you are getting stuck on those exercises and not managing to complete them, then do shout and I'll see make sure I get a little bit more time for some of those exercises today. We will be jumping onto some more, even more complicated stuff than we've done previously. So yeah, do shout if you do need a bit more time for those exercises. Obviously it's really hard for me. I kind of you know, it's great that I can provide training to so many people, but you know, it's not like the old days where we would do it in a room and I can stomp around the room and see who's rocking backwards and forwards with their head in their hands, sobbing. Would be you know, a little bit of a feedback to me. So yeah, we're going to do a little bit more wrangling today. We are going to do a little bit of SPC charts using the SPC plot the dots package. We are going to absolutely scratch the surface of functional programming, which sounds really, really scary, but believe me, it's not. And once you kind of get the hang of that, it will help you understand how other functions work. And it just means that you can write sort of functions and, I don't know, make more sense when we actually sort of come to write them. But when you've got a repetitive task, you can just create a function that does that thing. And then you don't have to change your code up. I mean, we will be using an example where I think we'd make a function for a plot. And, you know, we've got the same plot, but I just want to do the same plot and I want to do it across 3 different teams. Rather than copying and pasting the entire code and just changing one bit for the team, we can pop that into a function and then we just change you know, what team we put in there. That'll make more sense when we get into it. And we'll also just cover very, very briefly loops, which is again a way of, I've got a thing for my data and I want to do it over and over again on this data set, but with different iterations. And we just do very, very, very sort of touch on loops. Some of that is more about just if you encounter them out in the wild in other people's code, that you have an understanding of them and sort of can see what they can do. Likewise with functions, not necessarily expect you to be sort of fully into functions, but at least it means if you see them out in the wild and you see other people have written them, you at least understand the concept of how they work and whatever. So that's where we are. We've got 16 people and we're at 5 past, so I'm gonna go that's okay. Let me share my screen. So we are gonna just obviously carry on with our lovely script that we did yesterday. So either get that up and running already. If you haven't done, then obviously go back to posit.cloud and go in there and log back in. Where's the chat gone? Let me pop it over here. Oh, where's that? And the chat. I know people have put stuff in the chat. Okay, I'll have a look at that in a sec while I am going. Oh, where are we? Let's. Oh, my Teams is being weird. Right, let's do that. And where are we? It will be that one there. My goodness me. It's quite scary. It shows you how many times I've run this course now, which is cool. Where are we? 2nd of June. That was it yesterday, wasn't it? Brilliant. And yeah, just generally any sort of feedback around sort of times and speeds, etc. Do chuck in the chat. So, gonna load back in my data. Oh, sorry, my script. And look at that, I saved my R data. That was very naughty of me. And what I'm going to do is just whiz through this again. So the help function, really, really useful. Cannot stress that enough about how useful the help functions are. Just so, you know, just understanding things like, you know, these are the functions and these are the options that go into the function. So when we did our role apply, be able to work out, well, if I'm trying to find the middle, what's the right word for middle for this function? So what are the options? And also tells you what are the sort of the default options within a function. So really, really functional, really, really helpful. Like I say, clicking on a function, pressing F1 brings up that help. It's my general go-to, or you can sort of type it or whatever. So yeah, cannot stress the help. I'm going to reload in my packages just so I make sure that everything is all clean and all up running and everything else like there. So again, that was a little bit of script where we used sort of an if statement. And yeah, so we checked again, a little bit horrible syntax here with a horrible bit of base R. I need to work out how to do this in a more tidy way so that when I come back to explain it, it makes more sense. But basically, checks, these are my packages, so it makes a vector of my packages, checks my packages to see if they're in the installed packages. So if you, basically there is a command called installed packages, which will basically list all the packages that you have got installed. So it just checks whether these are within that list. If it's not in that list, then it will put those into a vector. And then there's a little bit here which just checks the length of the not installed. So if it's not 0, it will install the not installed packages. Again, I think I probably need to clean up the syntax of this so it matches what we do further down, and then it uses this pacman load. So just to explain this, if I type in, let's see, I can never spell select. So if I type the word select, no, that's not a good one. Let's try filter. Yeah, there we go. Oh no, is that a capital F? That's annoying. Okay, so sometimes we can see here, if I type in filter, there's a base filter, which is basically a base R version of filter, and there is a dplyr version of filter. So sometimes, I think we sort of discussed it briefly in sort of introduction. So sometimes you can call in a library and it will have a command that is the same as another library, and then what we get is conflicts. So classic one, when we load up tidyverse, it's where are we? Right back here somewhere. I know it didn't do that because it's quiet. So when you load up tidyverse, quite often it comes up with those warnings saying you've got conflicts. So sometimes what will happen is the latest library that you've installed will be the one that it chooses. So if you, very much like we've done, been writing incremental code, and then we bring in a package halfway through, and we say, actually, now I want to bring in this package, and then it will overwrite what that filter means in sort of later iterations. So where filter previously I might have been using the base version, now that I've brought in the tidyverse, it's now going to be using the tidyverse version. So anything I've used with the base version is now not going to work. So what you can do is you can say, I want to use the filter and I specifically want to use the dplyr version. So if I want to absolutely implicitly say that I want to use the dplyr version, you can do you can put that in front of it, and that will say that's definitely now I am using the dplyr version of filter. And again, if you had, I don't know, I'm trying to think of something else that uses filter. But anyway, if you had another, I don't know, janitor doesn't, but just say for instance, janitor had a filter command, and I want to use the janitor version, I could put that in front of it just to absolutely confirm that it's the janitor version. So that's what that means. And also some people's, there is a train of thought that you should put that in front of all of your commands as good practice, and just so you know where it's coming from. But anyway, so it's a little bit different. For those people who use Python, Python's much more explicit about when you call in libraries and how you use those commands. R is quite slapdash in comparison, which does make it easier to code, but it does mean that it does fall over with some bits and pieces. So first thing we did was load in some data. So I'm just going to make sure that my data is nice and fresh there. We did a little bit of base R, just trying to get like unique values from a column. We talked about how this turns into a vector. We showed very, very quickly about square brackets and sort of slicing. What else did we do? We did a bit of slicing around heads, top and bottoms, which was really, really nice. And I think somewhere, was that further on, use the lovely base R table function, which is definitely one of my go-tos when I'm messing about, or not messing about, when I'm coding and I want to double check my counts are still valid, etc., or I haven't created duplicate rows or duplicate values, etc. So tables fantastic. We talked about renaming columns, and we talked about the backticks for putting spaces in column names. A little bit of discussion, and like I say, best practice would be put your spaces into your column names when it comes to putting them into charts or into tables. Don't do it for your just general data, because it just makes things really, really frustrating and annoying. Talked about, yeah, there we go, conflicted. We also talked about the janitor package and the lovely clean names function, which just puts everything into a nice snake case format. It does have options. You don't have to use snake case. There are other options within the clean names, but I just use that, and it just makes things nice and consistent, nice and clean, and it's, you know, really, really clear then about what your variables are, which is really good. And what do we do there? Yep, we move some stuff around. Talked a little bit about the select statement and how you can use the select statement to sort of reorder your columns. There is a separate reorder command, which I haven't talked about here, but if you specifically just want to move one column, I don't know, 2 columns to the right, there are ways that you can just do that using the, it's not called reorder. Oh man, what's it called? Reorder something else, I can't remember. Anyway, there is a command that do that. Sorry,
I was wondering, was it arrange? But no, sorry.
No, arrange is,
yeah, different.
Relocate.
I'll find it in a minute.
It's relocate.
Relocate, that's the
Yeah.
one. Brain fog on a Tuesday morning. So yeah, so you can, if you just want to move one column, there are sort of bits around that. We talked about how we could negatively select out of a select statement, which is nice, and just the weird ways that the bang doesn't work, but yet the minus does. We talked a little bit about the contains and also the where command, which allows us to sort of select data types, which is really, really cool. So if you just want to select all your date columns, or you want to select all your numeric columns, etc., you can do that. And again, you can do things like select, oh my goodness me, where you can do things like select where is numeric and then remove a couple if you just wanted to remove a couple. Oh, I jumped around a bit there. What happened there? Let's go there. So we talked about that. Blah 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 blah. Then we talked about other types of joins. So that was more about concatenation. So rather than traditional left and inner joins and bits and pieces, or your VLOOKUPs, basically the literal concatenation of data, sort of chucking it onto the sort of the top and the bottom and the sides. Generally, binding columns is not something you do that often. It's more about binding rows, and that's usually about having a data set and a refresh and bolting your new data onto the bottom of your old data, which is really good. I won't go into it now, but I had something the other day where I was showing how to the published general practice data, the GP data, all comes in a zip file, which has an individual file for every single month. And I wrote a script in about 4 lines, which basically downloaded the zip file, unpacked it, got each of those individual CSVs, and then joined them all together into one data frame in and it just created this like 9.5 million row data frame out of all these individual little files, and you can do that in a handful of lines of code. So that was super clever. What we're doing here, we're binding rows, and we were doing that. Then we did some weird slicing and dicing and sort of selecting, and yeah, we did that one. Again, when I finished, I will save my version that I've written here, and I'll put that on my GitHub. So if anybody wants to see the code that I've written for this particular course as we go along, you can have that. We looked at unions and intersects and difference. So intersects was really useful. So if you wanted to find identical columns, or the set diff where you want to find columns or find rows that don't match. Also, again, I would definitely recommend going and having a look at the janitor package. That's got some really nice functions around finding duplicates and doing bits and pieces there. So it's, yeah, if you want to find, you can sort of specify these columns are fine and they can be sort of wildcards. However, have I got any duplicates in this column, and this column? And it does some really nice things around that. And you can say, well, where have I got duplicates, or where have I not got duplicates, and do all of that. We looked at using the .by function to do within summarize. I think that's pretty much covering a little bit of what we did. We also talked about using the .by within a mutate function. So I think in the introduction course, we very much use .by within summarize. Mutate is also really, really useful to sort of group things within your actual main data set. So I always probably go back to the sort of like pivot table in an Excel terms. So summarize kind of gets your data and creates a summary of it, which is your Excel type pivot table. And then when we do mutate, what we're doing then is adding new columns onto our actual core data set. So we're not actually sort of summarizing it, we're using the main data set. And again, being able to do groups within that is really useful. And I think we talked about the sort of the old school way, which you might see is this old group by and ungroup, but the new way is much nicer. Shows you the count functions, which is really nice. So there's a count function. The traditional one is just the count, and that does a sort of a summarize. And then there's the add count, which does a sort of a mutating type count, which is really nice. We talked about fancy filtering, and again, just some of the bits and bobs that you can do with the filter command. And I absolutely love this one. This is one of my favorites of, just being able to pick out the latest data from something I encounter all the time is like we get submissions in, so I want to know what is the latest submission by each of the organizations, and just being able to do a really quick filter on that is really simple, and really nice to be able to pull that through and have that in the data set. So yeah, we also talked about the OR function, which was this, just so you can write OR as well. Or no, you can't. Is it capital O? Just trying to remember what it is. How do you write OR? Because I never do it. Well, maybe you can't. I don't know. Anyway, I think there is an OR. I just remember what it is. Anyway, just to say that is the line to do an OR. So then we did a bit of an over to you. So yeah, we did a weird submissions and counting the submissions, and then a sort. So again, this was about how can I arrange my data, and again, that was about using the help function to go and have a look at the count function and seeing what other options are in there that could help, which was good. We talked about conditionals. So classic conditional being the if else statement, and again it's if else, then you give it your condition, and then you give it the result that you want if the condition is true, and then the result you want if the condition is false. And it's always important to make sure that your conditions that come out are of the same data type, so you can't mix your data types within your conditionals. So that was quite nice, and yeah, there's an example here that that was kind of go through as 100 as a numeric, and that was obviously dog is a character, and that will not work. It will say it's not happy. Then we looked at case statements. So case statements is sort of a multi-part conditional, where we can give sort of multiple conditions to our data set. And what's really quite interesting how they work, they will evaluate and they will return the result whether you hit the first condition. So just again, on this where I've got attendance is less than 5,000 here, I could say that would be breaches if I wanted to, and then first it would check if the attendances are less than 5,000, then it would check if the breaches are over less than 10,000, etc. So you're not limited to a single thing, but yeah, that was really nice, and good to see that. So, and yeah, we talked about using there's a bit of discussion then about using this, which was the new school way of doing a .default, but you might see out in the wild the older version where you've got the true. I then put in some spurious values and we sort of checked this through. Talked about how, you know, rather than using your else statement as a catch for your final bin, it's usually a good idea to have that as an error type thing, and you know, possibly have your default as an A would be good practice so that you can find those. Or if you've got a, you know, if you've got a visual here, I quite often like, you know, chucking in something that's really sort of in your face that, you know, shows what's going on. So that would be good. And that's a couple of other people's versions. And then we talked briefly about the one, which does get a little bit complicated in this version because type is a factor, and we're going to cover factors later on today. We then talked about if statements, and this is sort of a base R if statement, how you can create an if statement and your if, and you just give it a Boolean thing to evaluate. So and that could be whatever you want, and then if the condition is met, it will run the code within the span, within the scope of the curly brackets. So again, that feels a little bit more programmy than sort of R and whatever. I think when you start using curly brackets, that's when that's when you're a hacker. That's when you're in full. Look at me, I'm a programmer. So yeah, just to sort of show you what those do. Which was all that, and yeah, say how we can use the sort of if and else. And again, you can also you can add another if statement as well after your if as well, so you're not limited to one. So you can do if this, do this, if this, do this, if this, do this, else do this. So you can sort of really nest those up. I would probably recommend not making them too big and too complex, but yeah, it's definitely a really, really powerful tool. What did we do then? We looked at how we could use sort of those grouping functions within Mutate to make sort of subtotals, and also do things like percentages across groups really, really quickly and easily. So from this, we could work out what our total attendance is for that organization and that month was, and then we could then calculate across the different types what proportion, what percentage that was. And I think you guys, yeah, put a nice little round statement in there. I have added in the extra bracket, which I should probably remove. Which was that one there? Yeah. So that was there. So that all was there. Then we did some column-wise operations. So this was looking at whether we could, what could we do? We could do that same sort of percentage across all our numeric features. So this is using data using the across function, which is quite messy, uses this tilde, uses all these dots. It's quite a complex thing to try to understand. I would definitely 100% recommend that you pivot your data and make it long, because then doing all those sort of groupings, etc., is much, much, much easier. So I would recommend that, if you have got a thing where you are having to do this, if at all possible, pivot your data so that it's long, do your calculations like that, and then if you do need it in that wide format in order to pop into a table or something else, do that afterwards, which I know doesn't segue nicely onto pivoting, but
morning. I'm all right, and you?
Not too bad, thank you. Bit wet, put my boots back on.
Hello.
Like it's winter again.
Hi, you seem to be off mute.
Good, is it?
The rain.
The rain.
I actually don't mind. It's been a while.
Oh, there we go. Fantastic. Then we went into row-wise operations, which just showed if we wanted to do a function across each row, in this instance, we wanted to find what was the minimum value out of the attendances, breaches, and admissions across each row. So we could use this row rise function, which basically makes each row its own group. So make sure that we always put our ungroup at the end of it, otherwise it will go a bit shonky. Then we have the fun of pivot wider and longer. I think somebody said that it was harder than SQL. I still would take issue with that. It's definitely not harder than SQL pivots. Obviously, it's, you know, and what we're talking about here is actually changing the data structure to pivot it, which isn't necessarily what you would do within a pivot table. I think we're not talking about pivot tables here. We're talking about actually moving the shape of our data, which I guess you sort of can do with a pivot table, but you would kind of put it in a pivot table, move it around, and you'd kind of have to copy and paste it out of that into another like raw table if you were going to do something with it. So I don't think it would be particularly easy. It certainly wouldn't be automated in Excel. You'd have to mess about with lots of stuff. So yeah, I still think it's never an easy thing to do, just because it's a horrible thing you have to do with any data set. But I think, you know, especially if you're trying to make stuff wider, it's, you know, really, really easy. Making data longer, definitely more of a challenge if you are given wide data to go through. Power Query is great for it. I wouldn't know, I did not use such a thing, but yeah, Power Query sounds like that might be good for it. And we can go to Dan's Power Query lecture at some point. But yeah, it's good, and once you get a hang of it, it does get much easier as you go. So with all these things, practice, but hopefully don't get wide data, and, you know, try not to get wide data. Although if you look at the amount of publications that NHS England sets out, it sets out a lot of stuff in wide format, which is very, very poor. Then what did we do? Then we did some rolling functions. So that was just looking at things like rolling means and things like that, which are all sort of rolling averages, which is quite a common thing that sort of comes up that people want to be able to do. Like I say, you can use the roll apply for, you know, you're not limited to just doing a mean. You can do, you know, you basically can feed your end functions in there when we get to write our end functions. But yeah, you can chuck in whatever function type of stuff that you want in there. And you can also potentially use it for sort of like lead and lag type stuff if you want to. However, there are separate sort of lead and lag functions which work very, very easily. And, you know, if you want to cover those, we can have a look at those. And we did a weird thing. We then looked at row numbers. So row numbers and sort of adding those rows in there is really useful, especially when you want to do things. I mean, my classic one was referral to second assessment. So we'd have a referral date, and then I would have dates of all the patient's contacts. So I need to work out which was their second contact. I think I had something, I can't remember what it was. I think it was in some weird talking therapy thing where I had to like find that how many people had an 8th contact and sort of beyond, and the time to their 8th contact. So again, being able to sort of put things in that kind of order, really, really useful. Showed how you can just use row number, which just gives it a pure row number based on whatever you've got. Do be careful if you have got there's lots of additional functions which I probably didn't go into about what to do when you've got ties. So if two things have got the same number, which one to give it, which one do you give one to? Is it just the first one in the data set, or you can say you can give it other columns and say, well, actually I want the first one, but if there's a tie, do this, or if there's a tie, do that. So you can be a bit clever about how that works. We talked about dense rank, how if a date or whatever was tied, it would get everything the same, and then when it came up to the next thing, it would give it the number 2, and then the next things, even if they were tied with number 3. And then we talked about min rank, which is more about the sort of, I always see it as the Olympics sort of ranking system, where first person gets gold. If there's 2 people get gold, then the next person gets bronze, you know, because they then skip anything that's gone through there. And that's that one. blah, 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 blah. And, oh, that's where we were. Blimey. Whew. Any questions? I didn't see any hands apart from, yeah, going through there. Yeah. Any questions over what we did from yesterday, apart from Simon, can you go over it all over again, but much, much slower and get it into my brain? Because I'm not going to do that now. Okay. Everybody ready to go for the next bit? Everybody got all their stuff going? Any problems there? Got some thumbs up. Excellent. Catherine. I don't know, I assume that was a yes. That was a yay, I'm ready and raring to go. Excellent. Right then, so what we're going to do, we are going to group by dates. So what have we got at our moment? So make sure that you've run your libraries again right at the top there, and that you've got the data in there, and let's have a look at what we're going to do. So if I read through the code and we sort out what we're going to do. So what I want to do is group my data and get a year's total. So if we look at our data, if you remember correctly or rightly, we've got organization codes, and then we've got all these sort of it's monthly data. Hopefully we can see. Yeah, you can obviously see sort of data by month. If we had daily data, it's very often that we want to aggregate stuff up to a monthly sum, or we might want to do like the weekly count or whatever. So quite often you're given dates and you want to sort of put it, you want to group it. So rather than counting the daily stuff, I'm going to count my weekly, or I want to count my monthly data. Just so happens that this data all comes through as the first of the month. So unfortunately, for purposes of training, obviously I just have to show you how to do it as a yearly thing, but the principles are the same. So if I start with just this little bit here and run data year and have a look at that, obviously you can see I'm just filtering my data down to one organization, one type, and as you see, I've just got my monthly data. So what I want to do is create basically strip out and group all the 2017s together, all the 2016s together, 2019s and 2018s together to get the yearly total. In principle, if I had daily data, I could do exactly the same sort of thing that I'm showing you here and do monthly data. So this is how we're going to do it. So we're going to group our data, and we are going to use more of a group by in this instance. So we are going to go a little bit more old school, and I've noticed I've been really naughty. Don't look. There we go. What's that doing there? Yeah, you didn't see that because you always use the ungroup at the end. And I'm going to do a group by. So what's really interesting, and if you have used a group by before, is I'm actually creating a new variable within my group by. So this is a little bit confusing. So I'm going to create a new variable which I'm going to call year total, and my year total is going to be the floor date. So basically floor date means I am flooring it. I am, oh goodness me, how can I explain this? I'm putting it to the first of the month is usually how you would do it. So if I had the 21st of the month, I would floor a date and it would be to the first month. So I'm converting all my dates to the first of the month. In this instance, however, I'm flooring my period to the year. So this is really, really complicated bit of code. Why have I got that there? So, so yeah, note calling a new name to the grouped variable, which is this bit here. And then I'm just feeding in this floor date, and I'm flooring the period, which is my month data, and I'm going to floor it to a year. So just show you, if I did floor date and I did sys.date, which would be today. Actually, let's just do sysdate to start with. Sysdate comes up with today's date. If I do sysdate and I floor it to that will floor today's date to the 1st of the month. And then if I did, where are we? If I did that to the year, that would floor it to the 1st of January. So that way I can group all of my things, all of my stuff that's within that year to the 1st of January. Then what I can do is a nice summarize based on those groupings. So my total attendances will be the sum of the attendances. My total breaches will be sum of my breaches. Median admissions will be the median of my admissions. And then obviously always put an ungroup in there because, you know, you'd be very foolish not to do that. So now if I look at my data year, I've now got a year total, so everything is down as that year. I've got my total number of breaches, total number of breaches, and just showing that obviously you're not limited to just sums. You can, you know, add in other functions to do stuff across there. So that's given me my nice yearly totals. Oh my goodness me! So that's a great start. So let's have a look about how could we, and again, I think this came from a student question, so blame one of the other students. It's like, how could I convert a date into a financial year? So, you know, as you know, where we quite often work on financial year. So how can I convert that date and then group it into a financial year? So again, we're just gonna start off with our data. And again, just always worth just eyeballing it. So we've got our period here, and we've got our single bit here. So what we can do is create a new column which we're going to call finance year, and what we're going to use is something called month and year. So we're going to just, so let's just show you what this month, where are we? So we've got our sys date, which is today. If I put that in a month function, it will strip out the number 6, as in that's, you know, we're in June, that's the year. Obviously, if I put in year, that will strip out the year, and I'm sure this is going to be a massive shock to you. If I pop in day, it will pull out the date. So if I want to strip individual parts out of a date, you can use the day, year, and month function, which are part of Lubridate, which is part of tidyverse. So that gets loaded in when you do tidyverse. So if you want to pull out individual bits of the year, you can pull that through. So with that, what you can do, obviously, is write a little bit of an if-else statement. So if the period, if the month of our period is greater than or equal to 4, then the financial year is the year plus 1. So for instance, if I put in, let's just work that through because it's a little bit complicated. So our system date is today. So that's today. So if I look at the month of the period, it's 6, and then therefore the year of our period, which was that plus 1, would give us 2026. So we're in the 2026 financial year right now. Does that make sense? Because I know a couple of people got really confused by that. And obviously, if the month is less than 4, then we're in the previous financial year. So we can then pull that through. So if we run that and then have a look at our data, we've now given it all a financial year so that we can see, where are we? I'll put those in order, that will make more sense. So we can see this is all 2017 right up until we get to April, where it goes into the financial year 2018, up until it goes up to April again, and we are in then financial year 2019. Does that make sense? Does our identify American dates written differently? We will come to passing dates in a minute, but essentially R will always try to convert a date into ISO format, as into this format. I think when we did our introduction, we loaded in some data that was in I think it was in an English format or is in a Shonky format, and it doesn't do that. So R will always store dates in this format, in the ISO format. Obviously, when it comes to wishing to display your data, you can then reformat it for its output. So if we go back to sysdate, which obviously brings back to today's date, but what we can do is format sysdate, and then we can give it whatever format we want. So we can do D B dot just trying to remember, yeah, is it, there we go, got an extra Y on the end there. So yeah, if we want like something along those sort of lines, we can reformat our date. That will then come through as a character. If I did structure of that, that then turns that into a string. So you quite often you'll have a date which is sort of data, and then sometimes you might then convert it into another column where it's like the human readable version for when you want to put it into a chart or a label. But again, you have loads of options. So B is just shorthand for putting it into text. If I put an M in there, it would change it into a number. And I'm just trying to remember what other options are we got. We've got, yeah, we can also do, if I do a small y, it will concatenate it down to 25. So you've got loads and loads of options that you can chuck in there. There are some nice packages which also convert dates into like 3rd of May with the RD after the 3rd, and then like 5th with TH after it for whatever. And there's some really nice like human readable sort of numbers to sort of convert things into. So that's really nice. But as far as the data is concerned, it's, when we're dealing with dates, it's always going to be in this sort of ISO format, and that just keeps things nice. So yeah, we don't usually deal with American dates or English dates. We use this ISO format, and then when we sort of publish our data or we output it, we do it anyway. Oh my goodness me, very, very sorry, that was a random tangent. So, oh goodness, look at this, straight early in the morning, we've got an over to you. So what have we got? Create a data frame that contains a summary of sites RF4 and RQ3 and returns the maximum number of type 1 attendances across those sites by financial year. My goodness me. Yeah, there we go. That's a horrible question. Yeah. But obviously using a bit of the stuff that we have done here and mixing it in with some of the stuff we've got here. Do stick your hand up or whatever if you've got it. Fantastic. Philip's trying to write something, but keeps doing that way. Is there a recording yesterday's sessions available? Oh, sorry to hear that, Philip. Yes, there is a recording of the beginner's course. That's on the R YouTube, our NHS-R community YouTube. I will send that out to you. Obviously, this is being recorded, and I think what we try to do is, I think Kaylee or somebody will whiz through the video and remove anything that I shouldn't have said and bits and pieces, and then probably about a week or so afterwards, then that will be released as well. So there will be an option to obviously go over some of this. Appreciate, yeah, this is quite a ramp up from the previous one. As I said, I'm not necessarily expecting you to fully get all of this into your brain stems, but hopefully make a sort of a go of it would be helpful. So let's have a look at what we are doing. So what are we doing? We are copying our code. So what are we doing? RF4 and RQ3. So that's our first bit. Create a summary sites of RF4 and RQ3 and type 1 attendances. So nice little filter does that. We then want to create a financial year. So look at this. Here's some code I prepared earlier. So let's just reuse that. Then we want to find the maximum number of stuff. So again, we can nick some of that. Don't need all this. What was it? Max attendances. So max attendances equals max attendances. And we want to group it by where are we? Sites and finance here. Oh, what have I done? Now I do that, don't I? So I don't need to go in there. All right. Oh, it's org code. Dope. That's what we are. Yes. Sorry. So I was right the first time. There we go. Goodness me. So, so yeah, filtered the data down to the RF4 and RQ3, then created this new column, which was going to be my finance year, and then just did a summarize on my max attendances. I've added an RM remove true, but I know that's not necessarily required. It's just good practice. And we've got our summarize. And because I've done my group by within the summarize, I've just kept it here. You could have, and again, you know, kind of lead you up a little bit of a path there earlier. That's them. And just double check my answers that you've got the same. Oh, thank you. Alberto has put something in the chat. Let's have a look at his version. So where are we? So Alberto, yeah, very much did his group by sort of separately. So he added that in there and did that there and did data year. Let's just add an A in there so we can just see that comparison and check that we've got the same answer. Yep, same answer. So yeah, going much more doing the group by here. So it's quite nice doing that. So I've done it as a finance year as within my mutate, but obviously you've also created a mutate, well, sort of done a new bit within your sort of summarize and done it within the group. So again, different ways to achieve exactly the same result. So anybody not get that or went off down the garden path and got horribly stuck? No, we're all good. Do shout if not. Okay, fantastic. So cutting up strings and passing numbers. So I think I sort of touched on it a little bit at the start. Oh, sorry, there I've got another version as well. So if we look at our data, so again, this is something that possibly somebody asked. So this finance year is okay. I will do a little bit of one I prepared earlier. So somebody was asking, could they, sorry, somebody asked it in another question, another course, could we make that financial year, instead of just 2017, could we make it 2016/17 so it actually looks like a financial year? And the answer is yes, we can. So just going to take the data that I've got here. sorry, that I've got here. So this gets a little bit messier. So instead of just returning that period, can I return it so that it looks prettier as an actual financial year? So the short answer is yes. However, it does get a little bit messier. So what I'm going to do is paste some stuff together in order to do a format. So let's have a look at how to do that. So we're going to use a paste command. Paste command is basically, I think we'll use it a little bit later on, is how you can paste sort of text together in order to sort of bring a string together. So if we still got, yeah, so if I did paste, I can't spell. Paste, I can't spell at all today. And if you do paste 0, it means you've got no gaps in there. So as you can see, I've got values still here from yesterday. So if I did paste A, B together, that will give me a result of 1010 as a character. So just be aware that's not as a numeric. And if I did a space and then hello, it allows me to paste strings together. Those strings can be anything you want, and that's basically what I'm going to be doing here. So just pasting the string. So we're going to paste my year. Then I want to have a slash in there. And then what I want to bring through is the period of, so that would at the moment just bring in the 2027 slash, and then I just want to do 18 rather than 2018. So the format I'm trying to get to, whoops, just so I can show you here, is I want to bring it through so that it comes through and it looks like that at the end. So it does get a little bit messy. And again, I will share this so you can have a look at it. So I'm going to take a substring of my, oh no, I've got an extra year, and which is my period, and then that's +1 this time, and I want to take the 3rd and the 4th character out of that. My goodness me. And then, oh, I need another end bracket to end off my, oh no, that is my paste. Good grief. And then if it's true, so this is just, that's my true. And then if it's false, I'm going to do this. So again, I want to do a paste of my year, period, and I want to do this -1. And then I want to add in a slash. And then I want to do sub, and that should be substring, no, string sub. Sub, and then like year, period, and 3, 4, and I've got an extra bracket somewhere. Okay, that is that right? Oh, it still doesn't look very happy. Sort that through in a minute. Work, where are we? You can spot the extra bracket, so that one's right. I think it's here somewhere. Oh, I just need an extra bracket on the end of that because I haven't got a matching one there. Oh, no. Oh, bracketsy, bracketsy, brackets. So if that one's right, that goes to there, that one goes to there. So that's right. Ah, not enough brackets. There we go. Sorry about that. So now, and again, we can have a look at it. Now my finance year is not quite right. Okay, got it close. let's try. So it's working for my first one, but not my second one. Let's change that to a paste 0. What have I done here then? So which ones are right? I'm just going to work it out. So I haven't got my original date in there, have I? So I can't see. That's not coming through correctly. Sorry about this. No, that's worse. No, so that one was right. It's this one that's wrong. See, it's good to see that, you know, supposed people who know what they're doing also get their brackets horribly wrong. Hey, there we go. Goodness me. Yes. So yeah, that was just showing how horrible brackets can be when you've got subqueries within or sub-functions within other functions. And yeah, who doesn't love a bit of debugging and trying to sort out where your brackets in? Obviously, if I had nice rainbow parentheses on, that would have been much easier to see. But again, very much trying to understand where do my brackets match with other stuff. And then the fact that, you know, I've got 4 brackets at the end here does mean it all gets very, very messy. But hopefully you can see that you can eventually debug it with a bit of persistence, and then actually get to a really nice result at the end where you've got a nice human readable sort of financial year. So, you know, that kind of stuff is absolutely possible. And again, you know, being able to pull bits and pieces out of our data to sort of pull together to make new data, you know, trying to create this finance year in a more reasonable format is much nicer. Blimey. So we're also now going to cut up some strings and pass some numbers. So yeah, we've got this pass number. So we've got, if you remember our lovely data set, when we look at our original data set, we've got all these organization codes. Some of them have got numbers in them and some of them haven't. So say we wanted, for instance, to run a script across these organization codes and just pull out the ones with numbers in, and just pull that number through as a separate column, which is quite interesting. I have had to do something similar to that when I've been looking at sort of diagnosis codes or ICD-10 codes before, to try pull through the numbers of stuff out of there. So it is a kind of a real world example, and I think I've had to do it with sort of like treatment function codes, or was it HRG codes or something like that. So if I want to pull through, I'm going to create a new column now, which is the org code number, and I'm just going to pull the numbers out of those org codes. So I can use this pass number function. And it also tells me I've got a warning message. So R is quite lovely in that error messages are in red and also warning messages come up in red. So it's giving me a warning, and basically telling me that I've had 7,218 passing failures, which sounds really, really scary, essentially, and telling me, it's giving me some examples here. So this pass number is expecting a number to be in there, but obviously it's given me these lists of examples where it's failed, and as we can see, it's failed in those organization codes where we don't have a number. So actually that's exactly what I expected it to do. You know, that's the right thing for it to do. So if we look at our data org code numbers, we can now see that we've got this new column here called org code number, and it's pulled the 4 out of the RF4. It's pulled the 1 out of the R1H. It's pulled the 913 out of the AD 913, and obviously where we've got an RYX, it's come through with a null. So quite interesting how that does, how it pulls that through and sort of passes that as a number. So that's quite nice. I did use a string sub earlier, a function, to get a the sort of the third and the fourth character out of something. So there's a whole bunch of str_ functions which do loads and loads of different things within sort of manipulating strings, or if you want to find certain bits. So here we're going to have a look at whether we can filter our data to any organization code that contains an R or a P and anywhere within the thing. So it not necessarily starts with an R or a P, just has got an R or P anywhere within the organization code. So again, we've got our lovely little line to denote our OR. And if we look at our data filter now, all these organization codes either contain an R or a P anywhere within them. Have we got any P's? There's a P. Yeah, so obviously the P there is within there. So it's just looking across this string and doing a string detect on the org code, and does it contain a P? So yeah. So that's sort of a way of doing that. And, you know, there are ways of, you know, saying, you know, does it have an R as at the second thing within an org code, or can I find any organization code that ends with the letter P, or sorry, or a P is the fourth character within that string, etc. So you can get really, really detailed into how to do sort of string detects and bits and pieces. So what have we got here? A very, very quick over to you. What organizations code have a number in them over 50? Can you return a data frame with just the org codes of those with a number over 50 in them? So yeah, have a crack at that. And my lovely DHL people are telling me I've got a shipment today between 10:45 and 12:45. So if there's a slight knock and I suddenly just get up and run, that's my excuse. Yeah, I might not be. I might just be running away because for reasons. But yeah, anyway, I will be keeping my ears out, and I might suddenly up and dash because I've got a package arriving. So sorry about that in advance. Okay, what are we doing? We're doing a very random thing here. I don't even sure why we are doing this, but let's copy our code. I think it's very much copying that one, and I don't think we're doing anything particularly clever. I think we're just adding a filter to our org code number, aren't we? Greater than 50, or 50 even. Again, it's coming up with our error, and we're doing that. And what are we doing with just the organization codes? Oh, right, okay, so let's do select org code, because that's all that we need. And then we can also do unique if we just want the unique list of org codes that have got over 50 in them. And then org code numbers. So yeah, that will just give us our list then of those that have got a number greater than 50 in them. I realize that's a real cheeky thing. I mean, going back to the unique was something we did right at the start of yesterday. So not sure if anybody remembered that. But does that make sense? Obviously, that's a little bit fairer when it's on the same day that we've done the unique function. That makes sense? Yeah, All good. Excellent. Right. So here's an absolute classic thing. So sometimes we want to shorten strings, and we will use it. We'll come up with an example in a minute. So as you can see, and I think I've discussed this before, is there's this faint grey line here, which is the line of 80, which is generally your code should not cross that line. If your code is crossing that line, it means you need to put some returns in it and make it a little bit shorter for whatever reason. But sometimes you come up with a sentence or something that is really long, and we will come to a real world example in a moment where we have hospital names which are, we have things like, Plymouth University NHS Hospital Training Trust or something, which is obviously their long foundation trust, and it's their really great long name. But however, when it comes to putting that name into a chart or a table, absolute nightmare, because it's just too long, and sometimes you just want to convert that down to Plymouth, and that's more than sufficient that you want. Or you have North Region Occupational Health Care Therapy Service, crisis service or something like that, and it's like, I don't need to know that, I just need to know North or whatever. So sometimes you've got this big long string of stuff and you want to shorten it down. Or if you've got things like ICD-10 codes or treatment functions, sometimes you want to shorten them. So let's create an example. So now I've made myself a little variable called example, and if we have a look at that, we now have an example of a long sentence I would like to shorten as it is far too long. So what we can do is a couple of things. We can use a substring. So substring, and we feed in our example, and we tell it we want to start at number 1 and stop at number 15. And this will look, and if we run that one through, that will pull through the 1st to the 15th character. So in this example, it will convert that to this is an exam, which is kind of nice, but potentially, we could be chopping our way through a middle of a word. We also have this really lovely word function. So we can do a word function, and this one, instead of stop, it uses end, which is a little bit annoying. And we're going to say, actually, we want the 1st to the 4th word of our string, and that will say, therefore, this is an example. So really, really nice. And we can just say that our separator between our words is a fixed space. If for whatever reason you've got other things splitting up your words, you can specify that. And obviously we're not limited to the 1st to the 4th. We can say, if we want to start at the 4th word and end at the 9th word, we can pull that through. Let's have a look there. If we put it as an 8, that looked really nice then. There we go. Example of a long sentence, which is really, really nice. So if you want to sort of pull words out of a long sentence, again, really, really nice. And I think I've done that with sort of like treatment function codes, or where potentially things have got the same thing at the end. And you can also get a little bit clever in that you can remove things. So for instance, if all your teams, I think I had something where all of my teams had community mental health team written at the end of them. So it would be North Community Mental Health Team, but the next one would be Torbay and Southwest or something, Community Mental Health Team. So there wasn't a consistent thing on the left hand side where I could say I just want the first 4 words. That didn't make sense, but I knew that the last 4 words were always the same, so I could then specify to remove those, which is quite nice. So we're going to do an example together now where we're going to look at a long hospital name. So if we look at our long hospital name, we've got Boggins University Hospital NHS Trust. And that's great, but we want to convert it to just Boggins Hospital, and potentially we've got a big long script with loads of different hospitals in a similar sort of format, and we want to drop all the universities, all the NHSs, all the trusts, and just bring back Boggins and Hospital or that or whatever. I'm going to just show you the library TM, and we're just going to use a tiny little bit of it. But it's, if you ever into sort of like text mining and go down sort of that route of actually trying to do sort of textual analysis, library TM is fantastic. So rather than jump up to the top of the thing, I'm just going to do it old school way, and I'm going to do library TM M and install it that way. Chug. Or alternatively, you want to do it properly, zip up to the top of your code, add it to your libraries, and then zip back down again. And I will then call that library. So library TM is absolutely fantastic. It does some amazing things if you're doing sort of text manipulation or actual proper text mining, when you're looking at sort of tokenization and sort of trying to work out similar words and things like that. It's or if you're doing sort of thematic analysis, the library TM is amazing. But we're just going to sneak a few little functions out of it just because it's quite nice to do that. So one of the functions we're going to use is the remove words function. So we're going to take our short hospital name, and we're going to remove the words from our, so we're going to create a new hospital name, which is going to be our short hospital name, and we're going to remove the words university, hospital, and trust. So imagine if you've got a long list of these hospitals, and you want to do that consistently across the whole lot. Yeah, you know, we can add that into a pipeline and do a mutate or whatever, and remove all our names. But we're just going to do it on a string because it's easier to work with what we're doing here. So now, if we look at our new hospital name, it's betterer, I guess. But what it has done is has literally removed those words from our string, but it's kept the spaces because obviously we haven't told it to remove the spaces. So I think it's my absolutely favoritely named function in all of R, and it's called string squish. Which is just fabulous. I don't know why it's called string squish, but it absolutely does what it says on the tin, and is going to squish our string to our string of text into normal format. So what it will do is remove any leading spaces. Where we've got a double space or more, it will convert it into a single space, and where we've got a trailing space, it will also remove that. So it's a fabulous function when you've got horrible string like this. And if we run that through, and now we have a look at our short hospital name, the lovely string squish function has indeed squished it into a nice format. So yeah, I love things squish is cool. So gone over to you now. As you can see, Boggins Hospital has still got a bit of a rogue P, capital P, in the middle of hospital. So time to use a bit of your Google foo and see if you can fix that using a string str_ function. And see if you can then, yeah, convert it to Boggins Hospital. And again, there's more than one way of doing it. Okay, let's have a look. Catherine's had a go. String to title. And what has that done? Boggins Hospital, yep. Fantastic. There are some other ones that you can do. Can you do that for a whole column before removing words? Yes, you can. So, oh god, we haven't got an example. Let's make an example. Equals. Let's do. Oh. Okay, so just created a new data frame called names. And if we look at names, oh no, what do I need? Right. Yeah, there we go. So I've created a mini data frame on the fly, and we've got a Boggins hospital, we've got a Boggin hospital, Boggy hospice, whatever, and we want to do that across the whole board and redo that. So what we can do, so that's my data frame, much like we have done previously, and we can mutate. We can overwrite our original org name, but I'm just going to do it so that we can see new org equals string to title and our, what was it, org. And if we did that, now we can see we've got that. We can also see that this one's got a leading space on it. So if we wanted to fix that, we could also do new org equals string squish new org, and run that one through and look at our names. So now we've put them all in the same sort of format, and we've squished our strings and made it all pretty. Does that answer your question? Yep, excellent. And like I say, I will share my code and make that available if anybody wants to have a look at how I'm doing that. The only problem that potentially does come up, and it's really annoying, is if you do want to keep NHS in there, you can fall foul of it doing this, which is annoying. And so what you can do then is a string new org equals string replace, and we want to replace new org, and we want to replace NHS with NHS. So you kind of have to do it in order, which is a bit of a flaff. But if we then run that one and we look at our names, we then manage to convert it all back over again. Dealing with hospital names and team names is just awful generally. So yeah, but again, like I say, you can obviously put that into our mutate function, and then we can do all those whatever, and we can, yeah. And if you wanted to, we could do that without creating a new variable. So we could just do that on our org all the way through. and then that would just give us a Can you do squing squish? Yes, you can. So somebody asked, could we put our string squish? If I can spell it right, squish around our string title and do it in one. Let's see. Yes, we can. So yeah, absolutely. Whether, I don't know, whether you want to do that. I mean, I guess you could do. I think we're getting into that realm of potentially making it a little bit harder to read, potentially. I don't know. I mean, I guess this sort of method, you can see what you're doing at each point. However, you are, computationally, you're adding more to your bit because you're adding more and more functions to it. I don't know. But yeah, that would work without a doubt. So yeah, fantastic, Alberto. Right. Where are we at? We're at 10:30, so we've been going for an hour and a half. Let me just have a quick jump forward about where are we? We got factors, we've got SPC. Okay, we've got a fair bit. All right, let's take a quick 5-minute or 7-minute break and come back at 10:35. Is that all right? If you want to grab a quick drink, I know I certainly need to. Yeah. So yeah, let's come back at 10:35. Thank you. All right, it's 10:35. Hopefully managed to grab a drink. Okay, so where are we? Yeah, any questions on sort of basic string manipulation? Again, that's a massive rabbit hole that you can go down, but the string underscore set of functions are really, really powerful, and yeah, you can mess about with lots of things to kind of convert them. Like I say, my usual one is converting big long ICB names or treatment functions and various pieces of that into something a little bit more human readable without having to do some sort of lookup table to sort of manually do it. So yeah, if you can do it programmatically, it makes things a lot easier and a lot more dynamic, especially when a new thing suddenly appears in your data set. And now I've got to add that to my list of stuff. So that was string, a little bit of string manipulation. So what are we now? We are factors. Okay, so we talked about factors a little bit, and I think I've mentioned them a fair bit today and yesterday, and we're going to actually have a play with them. So factors are a data type that converts a character into an ordinal data type. So classic one is thinking of like low, medium, and high. So that low is the lowest, medium is above that, and high is above that. It's also really useful if you've got hierarchies of teams or of things like that, where something sits under something else and you want things to sort of show in a certain order, which is not necessarily their alphabetical order. So again, quite often we had things where we would we'd want to produce reports, and we would want to put all our referral teams grouped together to start with. Then we would have all our assessment teams together, and then all our sort of treatment teams sort of under that. So we had a big long list of teams, but I wanted to make sure that when they sort of displayed, they always came out in that order. So that was quite useful way of doing it. And again, with things like hospitals, etc., sometimes you want to produce a report where the hospitals are linked to their ICB. So you want to create an order where all the hospitals of a certain ICB are linked together, and then the next ones, and then the next ones, etc. So just reloading your data for your AE attendances, make sure that's all pretty. And we're going to go back to something we did earlier, which was adding in our attendance grouping. So if you remember, yesterday we wrote a nice little case statement where we added in a grouping variable for our attendances. So we are going to look at our data factor, and we're just going to filter our data to a single period and our type ones and arrange it by our data grouping. So if we look at our data fact, just to see what that looks like, yeah, we've got a bunch of organizations here, and we can see that our attendances, we've got this attendance grouping where we've put things in order. And as you can see, if we've ordered it by our number of attendances, our attendance grouping, I haven't ordered it by attendances, I've ordered it by date. So if we ordered it by attendances, we can see that we start off and as it gets higher, we can see that it goes through the bands of our attendance groups. However, I'm sure I've shown you this before, that obviously you can sort of click on the top here and see those filters. However, if we click on the, oh no, it's not going to do it on this one, is it? Because I haven't got that enough. All right, we'll come back to that in a minute. So let's have a look at that then in a super a quick and easy plot of what's going on. So we are going to do a bar chart of our attendance groupings. And if we look at that, what do we see? Oh, sorry, my laptop's telling me it's about to die. So maybe I need to plug it in. That will help. Let it go in now. Come on. Oh, we're plugged in now. Good. That will make things a little bit better. It's not in order. No. So, well, technically, it is in order. It's in alphabetical order for the attendance grouping, which is not really what we would want. So, you know, R just sees that attendance grouping that we've done as a set of characters, and it's just put them in alphabetical order, which is not what we want. What we would like to see is it in, this one over here, the 5,000 in the right place, and etc. So what we need to do is tell R these are our groups, but actually these are the order that they go in, as in less than 5,000 is the lowest and 25,000 etc. is the highest. So what we need to do is mutate our attendance grouping, and if we look at our data factor, our data type here, our attendance grouping is literally a character, which is why it's put it through as an order. What we want to do is convert it into a factor, and if we give it a factor, we can tell it what order those go in. So that's what we're going to do here. So we're going to take our data, we're going to mutate our attendance grouping, so we're going to basically overwrite our attendance grouping, and we're going to tell it now that it's going to be a factor, and these are the levels within our factor, and these are the order that they go in. So what we will do is overwrite our data and turn it into a factor, and also tell it that this is the order of our factors. So if we run that one now, we can see, if I close, oh no, it's not that. If I open up this one now we can see that our attendance grouping has now changed to a factor, very much like we've done with our types and our attendances. So if we do exactly the same plot again, we can see now it's put that in the right order. Might be easier if I zoom that, and then you can see a little bit better. So yeah, you can literally see now we've given our data set its order, and so it's actually put those into the correct order, which is really nice. We can also use that within an arrange function if we wanted to. So if we wanted to take our data factor, at the moment, if we look at it, it's not in that order. So if we take our data factor and then we did arrange by attendance grouping, so we can rearrange our data now, and now where we look at our data factor, it is in that grouping order. So literally, we can use that for in that order in other ways. So that works really well. And yeah, if we want to do it in reverse order, we could do that or whatever. Can you see the levels when viewing a data frame? Not when you look at it. So when we look at it here, we can just see that it is there, because it's basically, it's a bit of metadata that sort of sits under the data, so we can't necessarily see it there. What we can do is see it when we look at if we look at a string of our data fact, it will tell us a factor, and I think if we do data fact $sign attendance grouping, does that go into more detail? No. Where are we? Just try and remember. There is somewhere where you can actually tell it to bring back what are the factors within that thing. I can't remember what the command's called off my head. I'll do Google in a minute. Or we can do it now. Let's do that now, because that's, you know, live bit of Googling.
Is it just levels you're looking for, Simon?
Yeah, it's just levels, isn't it? That's the word I'm looking for. Is it just?
It's probably summary.
Ah, there we go. Levels. I knew there was something. Yeah. So I just couldn't remember what it was off the top of my head. Yeah. So if you just use levels on that, it will tell you what the individual features of your factors are. Factors do get a little bit messy in that now that we've set these factors on our data set and our data frame, you can't just easily add something new to it, because it wouldn't know where to put it in that factor. So we can't just add in something new to that factor level. We would have to actually not just add in the data. So if we had I don't know, an additional grouping that was I don't know, we suddenly wanted to do a 35,000 and over or something, we wanted to add in a new feature, we couldn't just add that in within our case statement. We'd also have to add it into the levels at the same time and add that in there as well. If we did it without doing the factor bit, it would throw it out, because it wouldn't know where to put it. So there's always a bit of a metadata bit that you have to worry about when you're playing with factors. So now we've done our plot again, and we can see that has worked. We can sort of reorder our factors, which is good. I think I've added the warning about doing the factors. You can reorder them. You can set your levels based on another variable as well. So you can sort of set up bins and bits and pieces there. Yeah, this is very much just to get an idea of what those factors are and where we've got a problem. So I think when I was showing yesterday, I was talking about adding an additional type into this into the type. Let's say the factor will not allow you just to add in a new piece of data that is like a free. So where we've got our data type, and I say if we've got 1, 2 and other, if I say that I wanted to make that the third entry, I want to change that to monkey, because that's not one of the factors within that data set, it will not allow me to, well, it will allow me to do it, but it will warn me, and it will also convert that to an NA. So if we look at my data set now, where I try to insert a monkey into type for the third position, it won't allow me to do it. It will chuck it through as an NA, because it's not one of the factors within that data set. Likewise, if I want to change, that to, if I want to try to insert a monkey there, which would be attendance grouping at 0.2, and I'm going to change that to monkey. It will allow me to do it. Why are you being so annoying? Okay, that's very interesting. Why is it let me do it there but not on the other one? Okay, I've just over-talked myself and made myself look silly. I'll come back to that. Anyway, I think the bit you need to know is obviously factors can be a little bit funky about what they will and will not allow you to do. That's really odd. I don't understand that. I will come back to that and see if I can find an answer to why it has done that during my next break, if I remember. But the main thing is that you can set a hierarchy to your data set, and I think that's the useful. Yeah, class attendance grouping. Let's have a look.
It should be factor because it says so in your summary of the data fact.
Ah.
I do data is data fact has attendance grouping as a factor, but data doesn't, and you've used the data attendance grouping.
That's what I did. You're absolutely right. So if I did data fact 2, that's data fact attendance grouping 2 as a monkey, that will tell me it's wrong. Sorry, yeah, looking at the wrong. There we go. Looking at the wrong thing. Yes, you're absolutely right. So if I go now and look at my data fact, it has indeed put an NA in there. So again, a bit of learning there. When you've got lots and lots and lots and lots of little mini data frames that you're working on, keep them kind of to a minimal if you can, and don't get your don't get them muddled up, because otherwise you'll do that in front of the class, which is not what you want. So yeah, just to show, say obviously you can create those hierarchies, and that's really, really useful. And like I say, I quite often use it for things like grouping teams together, or literally if you've got this is a classic example of why you would want to do that, and also sort of show it in the right order, which is cool. So what have we got? Dynamic text. This should probably be after the previous bit, but anyway, obviously my brain was jumping around. So dynamic text. So dynamic text is really good. I think I sort of shown a little bit of the paste command earlier, although glue, well, I think we use paste here. There is another command called glue, which is possibly nicer, but I think we use paste, so that's fine. So maybe we want to pull out a bit of data from our data set in order to write a bit of dynamic text within our report. And this is really, really good when we're writing to dynamic commentary to go with report, or if we've got later on, if we create a function to create a plot, how can we get it to pull in the the name of the hospital site within the plot title and things like that. So that's really, really nice things to be able to do that. So yeah, without having to sort of manually type what it is, how can I change that title and also have it a bit of a mix of my freeform text and bits from the data. So in this example, I want to say the maximum number of attendances was, and then whatever it is. So what we can do is create a string and create that text. So what we're going to do is use this paste command, and we're going to say we want to paste together the literal string, which is my freeform text, the maximum number of attendances was, and then we can do a comma, and then we can work out what the max number of attendances are. So if we look at that and just pop that out separately, so we know the maximum number of attendances was 32,209, but I want to put that all into a single line, and then if I run my text here, I can see now it comes through with I should probably put it up here actually and run that. We can see that now that's created a string which says the maximum number of attendances was 32,209, which is pretty cool. And then you can sort of switch between either text or other variables to sort of create more complicated things. So, oh no, I do cover glue. Yeah, didn't realize I did. I've forgotten. So what we can say is the maximum number of attendances was max attendances, and the lowest was min attendances. So if we run those, we get a single sentence which sort of pulls those through, which is quite nice. So yeah, you can start using those to sort of pull through various bits and pieces around stuff. So yeah, there is the glue library. So I'm going to be a good boy. We're going to add that back into my bit up here. And we're going to use the glue library. So glue library is essentially an advanced version of paste, which is, I don't know, one of those things. So, okay, that's loaded that in super quick. Or maybe I had it in there earlier. And then Control F and find out where glue is. And yeah, there we go. And glue kind of works quite nice in that you don't have to do all the commas and brackets and stuff within your paste function. So I do find it is quite easy, much easier to use. So outside of our paste function, we're going to create a new variable for our min attends and our max attends, and then we can basically within a glue function write our text, and then where we want to insert our variables, we can pull those through here. I mean, if you wanted to, you could still you could still add that in there as well if you wanted to, but I find it's nicer to sort of have them outside, and then it's much easier to read and sort of pull those through, and we can do that. Which does exactly the same sort of stuff with much sort of much less hassle. We can also do things like I'm trying to remember what it's called, pretty num, and convert that into a pretty number. If I can remember what other features for pretty num. We want big mark equals comma. I think that's right. And basically I wrap that into a pretty num feature now. So when I look at that, it's added a comma into my number, which again, for accessibility and human readability, doing things like that is really important to add things like pretty num. Pretty num does convert my number now into a character, so again, just be very mindful if you do things like that you do those at the last possible bit for when it actually comes out to display that, because again, good practice is, if you're putting big numbers into tables or into charts, you should sort of comma separate them for accessibility purposes. But yeah, that's the very quick overview of sort of glue and paste. I would shout out, I did a massive tutorial on sort of writing that sort of automated commentary, and there's something up on my GitHub, and I'll make sure I send a link out to that. Where I showed you and it basically shows the how to write sentences like the maximum number of attendances was in RF4 and the number was such and such, and this is statistically higher or lower than the average, which was such and such, and uses of sort of various number of things about how you can write glue these sort of strings together to write automated commentary that sort of works like that, which is a really cool stuff to add into your reports to say what's going on. So I will make sure I share that with the class when I send out my updates for further links, etc. Any questions on glue and paste? drink of water. And like I said, I think I showed earlier about I use the paste to do those financial years. Probably could have used glue, which would have been probably a lot less hassle, because you saw me fall over with bloody brackets and whatever. Oh, what's going on here? Okay, apparently my parcel will arrive soon. So yeah, I might nip off in a second. Apologies for that. Apparently I can see it on a map coming in. Isn't technology amazing? So I wouldn't be that bothered. It's just that it is coming from Germany and I don't want to miss it. Courier is 4 stops away. Okay, I'm going to keep an eye on it and I will nip off very shortly. Amal's also accepting a parcel as well. So yes, very exciting stuff, like sort of Christmas, but more expensive. Okay. If that's all good, let's go on and have a play with the Plot the Dots library. So big shout out, this is part of the sort of making data count, Plot the Dots use of sort of SPC, which I thoroughly and super endorse. We should definitely be looking at our time series as sort of statistical process control where it is appropriate. And looking at sort of variation and sort of common cause variation and special cause variation and understanding trends much more than lovely up and down arrows of this increased by 2 from last month. Which please don't use automated commentary to do that kind of stuff. It's like, can we use more statistical known approaches to sort of analyze our data? Obviously, there was a big push from Sam Riley and the sort of making data count team to do statistical process control. They released a lovely spreadsheet version, Excel version, where you could put all your details in. It's really clunky and really difficult to set up. And then you have to sort of copy and paste out of there if you will put it into another report. So a bunch of us got together and said, we really like this as a concept. How can we create an R package which basically creates SPC plots using the NHS England Plot the Dots methodology? And so that's exactly what we did. So we created an NHS-R Plot the Dots. So this is built by the NHS-R community and is a fantastic, lovely little package. And again, a really good example of sort of cross collaboration across the NHS and how, being able to write code and share code really enables that kind of work. So, that is quite a fantastic opportunity to be able to get involved in sort of bigger things like that. So I've added it into my packages up here, or you can just do a separate install and pull that through. There we go. Yes, where are we? I've lost it now. SPC, that's what I need to do, isn't it? There we go. So I've called the library in. I'm going to create a data set which will be really, really small. I'm just pulling in one organization code and one data, one type. So if I look at that, that just purely gives me my organization code and my type, and a very, very simple. It just gives me 36, which again, possibly is too many data points for an SPC, but let's not worry about that now. And that's just going to give me the data that I want to chuck into my SPC. And at the most basic level, we plot the dots SPC function with the most minimal amount of input. So I'm just going to say my value field is my attendances and my date field is my period. And I can create from that, not a very exciting looking, but a very, very basic, within a couple of lines of code, SPC chart using the plot the dots methodology. Obviously this is ggplot that it outputs, so we're going to go through and we're going to amend lots of the bits and bobs in there, but we can see obviously it's calculated all the control lines. it doesn't come up with the sort of the pure icons, as it were. That's something that is being worked on, but it's calculated all our control lines. I've picked a really bad example because I've got none of the colors in here, but it does do all the appropriate colors. So it does its blue for improvement and orange for deterioration. And yeah, it does all that. So there we go. Absolutely basic, you know, pretty much one line, well, a couple of lines of code to produce that. So over to you. We want to add in a little bit more information into our SPC chart. So we want to add in now that there's a target of 17,500, because obviously plot the dots is very much about your target and your achievement against target. And we also want to show that actually what we want to see is a reduction of attendances, and that improvement is a reduction. So how do you add those into that that data? Into that function. So I would very much recommend that you get some help and see if you want to get some help on this plot the dots function to work out how you'd add in a target and how you can show improvement is a reduction. Over to you. Korea is free stop away. This is really exciting now. It's just past Sainsbury's. I don't know if it's like updates literally like live. I can see it moving. Can you chuck any time series in SPC? Yes, is the short answer. I mean, generally there are some rules about what should be SPC and what shouldn't be SPC. Generally, you want a metric or something that is you're expecting it to be consistent. I've got scared off by if distribution like X, you need to do XY transformation. Yeah, I think that's where it all gets really messy if you get into. So I think the plot the dots team use XMR type SPC charts as a one size fits all. There are various trains of thought around that. I think it's probably, you know, personally, statistically, it's probably good enough and usually gives enough of a correct answer for what you're trying to achieve. If we are generally looking at improvement or detriment and consistent achievements of targets or inconsistent achievement of that targets, it's really good. You know, you're using sample data targets when consistently passing never happens for in the real world. And I think that's some of the problems in that sometimes if you use SPCs on things like waiting lists, where waiting lists are just continually going up, it's definitely not a consistent process. And if you've got like a straight line that is going up just through the quirks of how SPC calculates things with the confidence intervals, they do look a bit funky sometimes. However, the overall story will still be that you've got a special cause and an increasing trend. So it's less than ideal, but it will do the job. Oh, sorry, I'm yabbering away, and I can see people are popping stuff in the chat to say, shut up, I've finished. So yes, let's steal Catherine's code. And pop that in there. And yeah, oh, that was the door. 2 secs. Was the door, but it wasn't my package. So still going right. Oh, there we go. Somebody came up with a better example of using a different organization code, and you will see something. We'll get to that in a minute for sure. Oh, and now it's gone to sleep. I was away for 2 minutes. I don't know if everybody's gone to sleep. Yeah, Catherine, around what the well, okay, let's do my 5-minute explanation of SPC, if that helps. Yeah, mine's so imagine Simon is cycling to work, and on average it takes me 10 minutes to get to work. Sometimes it takes me 8 minutes, sometimes it takes you 12 minutes. There's always going to be a little bit of fluctuation, but I can say with pretty good confidence that on average it takes me 10 minutes. And what the SPC will do is put some confidence levels around that, which is what those lines mean. So it will say it is pretty confident that 95% of the time I'm going to be arriving at work between 6 and 14 minutes. And those are my control lines. So, you know, it's an average of 10, sometimes it's 8, sometimes it's 12, but it's pretty confident, you know, I'd say 6 and 14. So it's given me some control lines of, you know, definitely if all things are normal, you're going to be within that sort of time period. So that means that one day where, I don't know, there's some roadworks or I fall off my bike or whatever, and it takes me 20 minutes, that's unusual activity. That's outside our expected range of stuff. Therefore, it would then flag it that that's outside the confidence level, and you know that something different has happened, and it's just flags that statistically something has occurred differently on that day. Also, if we look at our chart, and what SPC does is says, you know, how can I identify an increasing trend? So if we see sort of 6 observations in a row going in a direction, we can say, yep, that's a trend, and we can see it's going in a direction either improving or getting worse. Or we can do 6 points, not necessarily each improving on each other, but say if we've got 6 points suddenly arrive above the mean. So if I see in the last 6 weeks it's taken me 12 minutes rather than my average of 10, we can also say that, oh, that appears to be an indication of a trend which is happening. So that's the sort of the first side of it about, you know, how we do those control intervals, and we just kind of understand, you know, what that trend is. We can also use that SPC chart to then compare against the target. So if my target is, you know, if I know that I'm, you know, it's taking me 10 minutes and my control intervals, my control limits are, you know, I know that I'm very, very confident that I'm going to be arriving between 6 and 14 minutes. However, if my target is that I've got to arrive at work within 5 minutes, we can be pretty damn confident I'm not going to hit target. That's just not going to happen within our expected sort of range of example of what's going on. So we can say, yeah, we've got no confidence Simon's ever going to meet that target, because his, you know, bottom control limit is above that target. He's, you know, just going to reach it. Conversely, if my target is that I got to get to work within let's say 9 minutes, you know, that's within my confidence intervals, but it's going to be really hit and miss. I'm going to miss it probably more often than not, but you've got, again, no confidence whatsoever that I am going to consistently hit that target, and therefore we would say, you know, it's just going to be hit or miss whether I hit it. Likewise, if my target was I need to get to work within 20 minutes, again, you could be really confident, yep, based on those confidence intervals, yeah, we're really confident Simon is going to get to work on time. We've got really, really good assurance that, yeah, we're going to consistently hit target. And then likewise, if I suddenly saw an outlier and it took me 30 minutes, we would say, yeah, that's really unusual activity. Something odd has happened there. Likewise, if it suddenly took me 2 minutes to get to work, you would say, wow, what's happened there? And you would explore that and go, yeah, that's the day that I met up Dave and he gave me a lift in his car rather than me cycling on my bike. But something different has happened. Something is unusual. So there you go. That's sort of the basic concepts of SPC in a nutshell, and you know that basically is what SPC can do. I would thoroughly recommend going and having a look at the sort of the Making Data Count team. All the details are on NHS Futures. I make sure that I add it on when I send out my outputs, and they do lots and lots of training around this and to do that. So the C and the P. So the C. So there's two parts of the bit. So there's the variation, which is either common cause or special cause, which is the variation that we're seeing within those confidence limits, and therefore, you know, we're quite confident that what's happening. So in my example here, everything here is sort of common cause variation. It's just within the expected value, so there's nothing exciting going on. Exciting, is that the word? So if we look at our, oops, where are we? Oh, that was odd. What happened there? Was it RQX? Somebody found an alternative one. And if we run that one, there we go. We zoom that. Oh, it's probably not on the latest ones. We can see here we've got 1, 2, 3, 4, 5, 6, 7. We've got 7 under our mean. So therefore we can see that there we had a little bit of a downward trend. Doesn't necessarily look like it, but because we've got those in there, that's a concern, because we've got those which look like it was a special cause concern. If that was towards the end here, this icon would change then to show that we've got obviously a downward trend going on. So that's not necessarily massively apparent when we just compare that to that. You know, there's not a great deal of difference. However, because it's transgressed that rule, therefore it's popped it in blue. So the one icon just tells us about the trend and whether things are going up. The other icon, or the P, talks about our assurance against target, and that's about that only appears when you put a target in there, and then it tells us whether we are assured about our target or not. So if we look at this one, and we zoom it, so we can see that our performance is here, and obviously we've said that low is good. I need to run it back to what you guys had previously, which was that one, wasn't it? Just so we are talking about the same thing. So yeah, if we add our target in there and we look here, we can see that our performance is, nicely within our expected values, and we are well below our target. So based on our expected range of activity, we can be 95% confident that our activity is going to fall between these two lines, and that's well below target. So we've got a blue P to say, yep, we are very, very happy, and we can be assured that we are constantly gonna hit target. If, for instance, our target was 1250, and we run that one through and we have a look at it, so this is our target now, and we've got no confidence. Sometimes we're going to be above target, and sometimes we're going to be below target, and so forth. We've got this question mark, so we've just got no confidence about whether we're going to achieve this target consistently or not. It's just going to be random, more or less. Obviously, depending on where it is, you might be more likely to it, but we cannot be assured that we are constantly going to hit target. And again, if I don't know, put in 2,500, and we look at that one. So again, our target is that we need to be below this line, and we can be quite confident that we are going to consistently fail based on the current system as things are. Even though we've got some fluctuation in our system, we're never going to hit our target, and I think thinking of performance metrics in that way is really, really powerful, rather than saying, oh look, it's gone up by 3,000 this month, hooray. It's like, well, it has. Well, actually, that's a boo, isn't it? Because we're saying low is good. But in this month we go, look at it, it's gone down by 1,000. It's like, yeah, so what? That's just common noise, and things are just noisy. There's always a bit of noise in the data. So yeah, trying to do that is really good. Somebody's popping something in the chat. I'll just cover that before I go on the next bit. Can you pull out the pass fail from the test rather than visual, if that makes sense? Yes, you can. So we can assign oh no, not data SPC. I know we've already got an SPC. Let's do data SPC data, which is probably not ideal. And we can run that, And then if we actually have a look at that as an object, it actually creates a data frame with the actual gubbins that sits underneath the chart. So it will then tell you those are our control limits, that's our mean, and then we can calculate if you wanted to, and I've done it in other places. So if you want to pull out commentary that discusses that data, that SPC chart, and converts that into English, I've written some code that does that, and likewise I'm happy to share that. So if you want to write that commentary, and again, sort of Plot the Dots have very sort of specific commentary they've put around SPC charts. So if you want to write some commentary that goes along with your chart, I've got some code that can do that, and you can pull that through from here. But yeah, you know, in this instance, we can see that our target is below our lower control, lower process line. I think they LPL, yeah, upper limit, lower process limit, upper process limit. I don't know, I keep calling them control lines, but they're process limits. But anyway, yeah, we can then from that calculate whether you're consistently hitting target or not. But yeah, it also creates it as a data object. If you don't put it in as a data object, you can yeah, you can also create that, and I think you can put that into a plot function. Does that then plot it? See, that's not going to clear my plots. Yeah, that allows you to plot it. So you can have it as it's very well written by a guy called Tom Jemmett, who is just a magician when it comes to R. It's a magic object, which is a chart and a table at the same time, because he uses witchcraft. And that's true facts. Claire, you'll back me up on that. He's a magician, isn't he?
100%, yes.
Yeah. That's no word of a lie. But please don't burn him. Right, so let's say a bit like we've done previously, we've used sort of facets, and you know, those are really helpful. So again, we can pull data in, and we can run a facet field into our data set, which if we zoom that in, we can now run based on our data an SPC chart for our ones, twos, and others. Obviously, we can see we've got a bit of a scaling issue here. So what we can do is, do we not do that? So yes, we can change that. So first of all, what we're going to do is, yeah, see if we can fix all this and make it look much prettier. And there's lots of bits and things to do. So the plot the dots SPC function does all the calculations and bits and pieces in order to calculate the data that goes into the SPC. And it's quite basic and comes up with a standard format. And as I've shown just now, that we can then add that into an object, and then that, as we saw earlier, that creates a data frame with all the workings of our SPC chart in it. We can then feed that SPC into another function called plot the dots create ggplot. And we can use that, and that has additional functions that we can use to make it much prettier. So at the moment, so we've got plot the dots, create the plot, to create ggplot, and we're going to add in some extra features to it. So fixed y-axis, multiple. So we've got multiple y-axis at the moment. In our example, it was a fixed y-axis across each of our facets. We want to make that false so that we can give each of our plots its own y-axis, so that we can see them side by side and we can see that variation, but they're all going to be on a different scale. So yeah, we can go into whether that's a good idea or not. Generally not against comparing things of the same type. We can also lovely dates. They're all down as 01/12/17. So we're going to change the format of our dates to make those a little bit more human readable. And sorry about that. Sorry, professional, but I did get my box, so we're all good. I'll do the unboxing afterwards. Where are we? We were fixing the format and also adding some access breaks in there. So now if we run it and have a look at it, starting to look a little bit better. So on this version, we haven't added a target, and I just remember what we have added. We have got an improvement direction. So we can see these guys are very much obviously in common cause variation, but we can see this one's in a high special cause variation in that we've got data points outside our confidence intervals, and also we've got a run where we can see there are a bunch of stuff above the mean. So obviously something's going on in our other attendances. So I should have left this to you. So over to you. Make a faceted plot for type 1 attendances across these 3 sites. Change the point size to make it a little bit nicer. I don't like those big blobby dots, so make them a little bit smaller. Change the x-axis label to say date rather than period, and have a look at the other bits of that function and see if there's anything else you'd like to change to make it a little bit more useful. Blimey, we're at 11:30 already. Jeez. But we're all right. My goodness, what functional programming links? Okay. So what have we got? I'm not exactly. It all looks too much prettier. Let's have a look at what that looks like then. Yeah, that's prettier. Did you find any other bits? What did you do? Yeah. Again, press F1 on create, plot the dots, and see if there's any other bits we want to add in there. You might want to change the main title. And again, this is where we could, let me see. We change that to there, and we pop something in like that. And then let's do a glue because that's type attendances. Can't spell attendances or I call it sites. Oh, does it not like that? Interesting.
Oh, do you have? Oh no, sorry. I was going to say two brackets at the end, but you needed that.
Yeah. That's interesting. Oh, what have we got? Not light blue. Try. We don't do that outside. Let's do the title. Let me do it that way. Argument must be character length 1. That works. Why won't it let me pull in something else? Oh, I see. Because it's I need to flatten my sites. Ooh,
that's
so
sites, not sites. Just to say.
Oh, that is sites. Yeah, you're right. How do I stop it being a vector? I do see sites. But that's going to, yeah, all right, so that's right, but I'm gonna title. I think the problem that I had is that when I've got my sites in a vector, yeah, it's still got the same problem. And my site as a title, they're 3 separate things. They're a vector and they're each separate. What I want is a single is it flatten? Nope. How do I get that into a single? Right, I'm going to come back to that. Because what I want is a nice title that says SPC chart attendance is 4, and then list the 3 titles. Your site is a list. Yes, it is. I need to convert. No, it's not a list. It is a vector. Let's do convert vector to string. How to convert a vector into string? No. Is that it? Let's have a look at that one. To string. Let's try that then. That looks good. Title. String. Sites. Cannot find to string because it's got a capital S. Of course it has. Oh, yeah, there we go. Now, if I look at my string title, I've got that in there. And then if I run my title, I've got a new title. And then if I run it all through, oh, I want my title to be that. jobs are good, and look at that. Fantastic. Blimey, that was way too ridiculously hard for something. It should have been quite simple. And fantastic use of Google there to show you how to find stuff. So the problem I had is when I was trying to feed in my vector. So a vector, even though it's one, I created a vector up here, which is one object. It does actually contain 3 separate things. So when I tried to do my glue, it was gluing them to each of those things within my vector. So what I needed to do was to convert my vector into a single thing, which I used this lovely toString function, which then just converted it into a flat string. And then I could glue that into my title, and then I could put my title into my text here. So that then allows me then to create, potentially if I wanted to run this on different sites, I could just change it here. And what's the nice thing about doing stuff like that is I wouldn't, that would automatically dynamically update my title, and it would also dynamically update where my sites go into here. So what would be really nice is if I wanted to create something, so I'm going to do this again and again and again, and I want to create something that potentially I could just choose any 3 sites, put them into a command, and it spits out that report, spits out this text, spits out that plot, but without having to sort of change this each and every time. And maybe I've got a report where I'm doing it on a different set of 3 each time. So how do I do that so it's I'm not having to repeat the code? And the answer to that is functional programming, which is what we're going to have a go at now. So say we want to do something lots and lots of times, we could copy and paste our code, which is totally viable, but it does get really, really quite dull really, really quickly. And as I said here, I've put my sites in here and I've hard coded them, which is quite nice. If I hadn't done that, if I want to change something here, I would have had to change it elsewhere. I could have put my title in here, and I could have hard coded my RX4 or whatever it is, and have my title in that kind of format, and had to do it again and again and again. And what that means sometimes is that you're sort of changing bits of code over and over again. And if you've got the same plot done over and over and over again, and then you suddenly decide, actually I want to change the point size of it because actually 0.1's a little bit too small, maybe I want to do it point size 2, you would then have to go and change it in each iteration of your plot, or each thing that you've done, and it just gets a right pain in the neck. And it means that quite often something can slip because you're having to change it multiple times. And big fundamental bit of our coding is try to keep your code as minimal as possible, and don't repeat yourself unless you have to. Coming from me, that's a bit rich, but there you go. So so yeah, what we want to do is something where we can update something and do something to our data, and it runs that. So what we can do is set up a function to do a number of steps for us, and we can then just call on that function and it will do all those things for us. So let's start with an example. So you're going to create 3 variables called X, Y, and Z, or Z for those Americans of us, and we're going to give X a value of 5, Y is going to have a value of 10, and Z's going to have a value of 15. And what we want to do is triple or times by 3 each of our variables. So we could do X times 3, Y times 3, Z times 3, and that would be, that would be great. And we could create a new variable called X mult, which will be our X value times by 3. And if we then look at our X mult, we can see, well, we can see it over here. It's given it a value of 15. Hopefully, people can work out that 5 times 3 is 15. So that's great. So if we wanted to do that, again and again and again, we would then have to go, all right, well, I want a new thing now, and I want a y mult, and my y mult will be y times 3, and then my next one will be z, and I want to do z times 3. So each time I would do it, I would have to update on this side what I'm doing, and then change all the variables and to do all that, and that would get really, really, really tedious very, very quickly. Or not tedious, it would just get duplicated. Yes, yeah, that's the word. So let's just build a function to do that. So we start with naming what our function is going to be called, and we always want to call it something that is descriptive of what it's doing. Then we tell it what are our variables that we are going to feed into our function, and then we give it a scope around what it's going to do with our variables, and then it will have an output. This will make a lot more sense when we start building it all. Similar to our if statement, we're going to use curly brackets again, and we're going to define a scope. And as always, as it said, that scope is only, the stuff with the curly brackets is it only gets called by R is when we call that function. So it won't get run as a matter of course. It would only get run when we call that function. So curly brackets are those weird sort of things where we can, sort of segment a little bit of our code and tell R to run it under certain circumstances. Obviously, with our if statement, we told R to run it with under a conditional. In this instance, we're going to tell R to run this bit of code when we tell it to. What is really important to understand, though, and this does get a little bit messy because it works a little bit differently than how our if statement works, is our scope is self-contained, and what happens in the scope stays in the scope apart from the last thing which gets spat out from the scope. So you can put a load of stuff within our curly brackets, etc., but the only thing it will return is the last thing. If there's any Python programmers, that will make much more sense to you. And with Python, you explicitly tell your functions what to return. R, you don't have to. Again, R's a little bit more sloppy on that sense, but the last thing that you do is what it will reproduce, which will make much more sense when we do it. And I'm going to explicitly tell it to what return. So we're going to create a function which is going to be called times3. Okay. And what that function, so we're going to call a new function called times3. So a function are all those lovely words that we've been using, like select and mean and median and mutate and ggplot. All those things are functions. And now we're going to create our own, and we're going to call it times3. And we're going to say our times3 is going to be a function. And then first of all, we give it in our round brackets what are our variables that are going to go into this function. And we're going to create a dummy variable. It's just going to be called input. It could be called X. We could call it whatever we want. It's just literally a variable name. And I've just called it input here for hopefully clarity. And then we've got a curly brackets. And our curly brackets is what is going to be evaluated when we run our function. So our curly brackets, again, is our little scope around what's going to happen. And I've explicitly told it what it will return is that input number, which will just be a variable that we put in there, and it will return that variable times by 3. So if we run this, it will, down here now, show that we've created a function within our data set. Sorry, within our environment. So we now have a new function. Times3 never existed before. It wasn't a thing. But now if we start typing, and even better if you spell it rightly, if we start typing times3, look at that. We can now see that there is a new function created. And also now we can give it a number. And if I do 7 and press return or run that, we can see that it is taken that 7 as our input, and has returned 7 times 3, which is indeed 21, which is amazing. We can also feed in our variables. So we've already got a variable of x, which is 5, and we run that into there, and it will give us the 5 times the 15. Or we can put in the 7, the y, which will do that. Or like I said, we can put in our number, and that will go in there. Does that very basically make sense, sort of, around what we're doing? Any questions on that before we get going? Like I said, we are going up a level in programming type concepts, and I want to try to hold your hand. Yeah, we're happy with that. That's good, fantastic. So we're not limited to one thing in there. So we can have a multi-part function. So let's just check this now before we type it. So if I start typing x times y and run that, object x times y not found. So there's no such function called x times y. So now I'm going to do 2 different things, or it's going to take 2 things. So it is going to take x and times x and y. So I'm now going to feed in 2 things into my function, and it's going to create a new variable within the function called which is going to be the result, and that is going to be the result of x times y. It's then going to create a new variable called b and assign it the value of 150, and then it will return a text message or a message that will say the answer is, and it will print the result, and b is b, and it will print the value of b, which will be hopefully 150. So if we run that one, I've got a new function. So let's just try that with some x times y, and I don't know, 2 and 4, 2 and 5. If my maths is not failing me, I think the answer is around about 10. So if we run that one, the answer is 10 and b is 150. So that's pretty cool. Look at that. We've made a function. However, there are some weird things going on with functions, and this is where we are going to get a little bit odd. So we took in x and we took in y. We created a variable called result, and the result was our x times our y. However, if we look in our global environment, result does not exist. And if I type in result, there is no object called result, does not exist. Which is like, but it does exist because it was in the output and we did it. So this is where we are talking about our lovely curly brackets being a span and sort of existing in its own sort of, I don't know, sub-dimensional space. I don't know, pocket dimension. I don't know, I'm getting kind of weird now. That probably is going to make things even weirder. So some of my D&D roots there going. So yeah, it's kind of got within our span of our scope of our curly brackets, we've got this like sub bit of environment where we've created variables. Again, we assigned b to be 150. If we look in our variables, so we have got a b. That's because we created it earlier, but it's definitely not 150. It's something that we messed about with when I was doing stuff yesterday. So if b's not 150, and again we can feed we can do x times y. We can feed in our x and y here, so we've got 5 and 10, and we can feed those in there. So if we run just that, it will say the answer is 50 and b is 150. If I assign here, b is 200. Look at that. B is 200, and we can see that's updated here, and we now got a variable called B, and it's 200, and I run my x times y again. It's still going to say the answer is 50 and B is 150, because the B that it's talking about is the one within the scope, not the global B, and that can get a little bit messy around what it's doing. Yeah, so just kind of be aware that it will not necessarily overwrite those things, and I can show you that we can mess about with that in another way at another point. Also, we can assign our result of our function to a separate variable. So now we've got a variable here which has literally got the answer is 50 things, so we can assign a function within that. So really, really important to understand that function only will return one thing, and that's the thing that it will kind of imprint onto the global environment. So it only ever returns the latest thing. So for instance, if I removed this line or just commented it out and told it to return, oh yeah, if I just did it like that actually. So if I commented that out and then run it, so I've got a new function now, and if I run x times y 2, 2,5, where's our b? What is that going to do to our b? Is it going to change it or not change it? I don't know. Can we have hearts for change it, thumbs up for not change it? I've got hearts, got a thumbs up. Okay, thumbs up, got hearts. Okay, interesting. So let's find out. So based on the rules, it only ever returns the last thing you do, and like I said, that's what affects the global environment. So if I run this one now and we run it, it does not change B. So there we go. Yeah, it does not. Oh no, I didn't actually rerun that. It should change B. Surely it should change B. Why is that not changing B? That's very odd. Did I? Why is that not changing B? Okay. X. Yeah, running x times y is changes B within doing it. Yeah, absolutely. So I think that's the problem. It's not actually changing the global environment. So if I did B is that, then it would change it. So there we go. Yeah. So that makes a little bit more sense. So just to show that, yeah, playing with functions sometimes, if you're trying to mess with variables in that level, can get really, really confusing. Yeah, you can also use the double assignment to assign it to the global environment, which is very, very bad practice, I am told. So yeah, we could do wrong one. So we could do a double assign, which basically plops. So we've got an extra bracket there, which kind of takes it out of the scope and puts it into the global environment. So if I change that to 250 and then run that one, that will change it to 250. Generally, that is yeah, seen as bad practice, and yeah, don't do that. So yeah, forbidden knowledge, absolutely. And yes, as Claire says, that's yucky. Let's not go there. So always, but again, good to know that it's there, and if you do see it out in the wild, then you know to point and deride it. So function will only return one thing. So we've done our X. So where have we got? So only return one thing. Do not have to specify what it returns. So previously I've told it to do a return. It will just take the last line of your scope and return that. So if I do X times Y, no return, it will just print out that last line. So hopefully that makes sense. So putting that return in there is probably good practice, but very, very rarely seen in the wild. So just kind of be aware. And again, with this, you know, result, even though it's doing that X times Y, there is no actual variable called result. It does not exist. It only exists within that scope. If I wanted to, you know, you could do that and do it to the global environment, but yeah, please don't do that. Because yeah, it could get really, really messy. So going back to our curly brackets, and what happens when a function scope is not in the global environment? For instance, result has not been created, only exists within the scope. A function scope cannot affect outside the function. Yeah, so I think we've covered that lots around. We've got test here is monkey, and then if we reassign test within this and we run that, yeah, what will happen to the variable test when we run this? And I think we've sort of covered that before. Because we're only reassigning it within the scope, it doesn't change it. It's still monkey, even though it's printed out moo here. We have not assigned it within the global environment. It only exists within that scope. Maybe I've over-explained scope and made it much more complicated than it is. Let's do some examples and we should get there. So we can add multiple steps into a function, which is yeah, a bit bonkers. So we're going to create a function here, which is x times y plus 10 date, which is going to take in two features, an x and a y. We're going to multiply x and y together. We're going to calculate the day of today's month, of today's date, and then we're going to do an if-else statement to say if the day of the month is greater than 15, we're going to add 10 to the result. Otherwise, we're just going to return the result. Okay, so let's just check that you've worked out how this works. Obviously today is the 3rd of June, so this is, look at this, a dynamic question that changes every day that we run the course. What is going to happen without running the code if you put in free time, if you run that function with 3 and 10, what is going to be the answer? Pop it into the chat now. Fastest fingers Raj, but is he correct? That's the question. Oh, you got a few people more supporting you, Raj. Any more answers? 30. Well, I mean, technically yes, but also no, Thomas. Excellent. So we just run through the logic of it. Obviously, we're going to add in 3 and 10. We're going to add those. We're going to multiply together, which is 30. We're going to check the day of the month, which we're going to take the day out of the system date, which will be 3. Then we'll run this if-else statement. If the day of the month is greater than 15, we will add 10 to the result. Obviously, today's the 3rd, so we're not doing that. So the result will just be 30. And let's just chuck it in there. And indeed, it comes out with 30. Yeah, which is great. And again, Thomas, if you did actually want it to come out with the answer, literally the word 30, there is a fantastic package. I think it's called English, which converts numbers into words, which is great. So if you did literally want the word 30 in words, it's really good for that. And again, when you're doing like reporting and trying to put text into reports, actually converting sometimes your numbers into words is really, really powerful. So yeah, you're not right in this instance, but you could be if we added the English package and had a play with that. So so as you can see from that, functions can get pretty messy pretty quickly and be quite hard to read, especially if you're picking up on somebody else's function. So it's always a good practice to write a doc string within a function, so which is a sort of a way of commenting what your function does. So this is a very long, convoluted, good practice of a doc string of what this function does. So what you would do is give an overview of what your function does. So this function multiplies two numbers, x and y's, to the x and y, and adds 10 to the result if the current day of the month is greater than 15. Otherwise, it simply returns the product of x and y. It tells you what parameters you feed in. So there's two parameters, x and y, what format they're in. So it's expecting numerics in there and what they are. So it will be the first number to be multiplied and then the second number, and then the return, it will be the product of x and y with 10 added if the current day is past the 15th. And then potentially also it's going to give you some examples of what goes in there. So you know, that's really cool, and that's a really nice thing to add into your function, especially when, you know, I'm sure I've talked about future Simon. When future Simon comes back and says, oh my goodness me, what does this function do? Having it really well documented is you know, really good. I would also thoroughly recommend sort of large language models and sort of, you know, ChatGPT, Google, Gemini, Meta, or whatever. If you feed a function into it and ask, say, please write a doc string for this function, it's really good at doing those things for you. And then if obviously you read its outputs, it will very much tell you how to format your doc string, and also you just double check when you read it that it is actually doing what it's supposed to be doing. So I would thoroughly recommend adding in sort of a doc string to your functions. So we've got an over to you. So now this is an extreme example with not so lots of different things. Obviously, if we take our y times 10 plus 10 date function and we add in, instead of we add in the word monkey, and we try to multiply the word monkey times 10, it's going to throw an error. Our function's going to fall over and break. So again, when you get into more advanced, rather than your code just erroring and breaking, what you can do is do sort of checks that, you know, when somebody's inputting something, they are actually inputting a variable, and if they're not, send a warning back to say, you know, this needs to be a variable, this needs to be a numeric variable, not a character variable, or just try to do this, but if it doesn't work, rather than just crashing, print a message to say a warning that says failed, but carry on with the code. And there are sort of ways of doing that type of stuff. So definitely have not got the time to sort of go over that today, but we can do that. So over to you. Tweak the above function so that instead of times the two inputs and adds tens, it adds a number that you so yeah, so instead of timesing the two numbers, it adds tens to the result based on the day of the month that you specify. So for instance, at the moment it's hard coded that if you put in a an input, it checks against the 15th of the date. Say you want to do it so that it adds 10 based on a number that you put in. So you could put it in as a variable that it's going to add 10 to it if you have the 2nd or the 5th. So how can you convert that into a variable that goes into the function? So over to you. Just very mindful of time. Where we at? We're at 12:07. Okay, I think we're right. We're good. We're gonna get there. We're gonna get there. I think I have got the worst function for you to build in a minute yourselves, which is going to be horrible. But yeah, I think we're going to be all right for time. Oops, what's going on there? So let's just use the non-docstringed version because it's just easier to see. So like I say, at the moment, this 15 is hard coded. So yeah, how could you make that a variable as well? Do you want to stick your hand up if you're done? No, I did not use rexpgen to generate the docstring. I ChatGPT, I think, or I wrote it manually. Roxygen is also another thing for doing that. Hopefully that's a hand up to say I'm done rather than I'm stuck. So, great. Any other hands up? Raj, fantastic. Fantastic. Any more? Any more? So I want this one to be a variable. So let's just call it day. Or I don't know, where is it? It's very hard to give it a descriptive thing because it's utter nonsense, but let's just call it day Z. And then I can add in another function, another variable into my function here and then run it. So now where I've got x plus 10, so I can do free thing and I can run it on the 10th of the month and that will give me the answer of 30. But now if I run that again and I make my weird cutoff arbitrary date the 2nd, should hopefully get an answer of 40. How have I got 40? Oh yeah, sorry. It does add 10 if it's above that. Yeah, sorry. Free can't. Yeah, should get 40. Blimey, I can't count. So yeah, it's then adding that 10 because the current day is the 3rd, which is greater than 2. Does that make sense? What we can also do is add defaults into our data set as well. So if I want to have DayZ to be a default of 10, so I can run that, and if I run it without that variable in there, it will run it and assume that the default is 10. However, I can also put in my extra value now, and then when I run it, it will override that default, which is another nice quite little thing. So hopefully that vaguely makes sense, and we've come up with lots of really stupid examples of how that works. But what we can do is apply our new functions to a data frame. So let's just create some a quick data set, which is our data fun. So we're going to create our little data set of here, and what we're going to do is we've got our X and our Y in there at the moment. And what we're going to feed in there is row wise. So we're going to do a nice little row wise. And again, I've been very naughty and forgot to do my ungroup. And I'm going to do a mutate. And my mutate is going to use my new lovely, I don't know, where are we? Here. I just noticed that's wrong. That should be, that is right. Yeah, that's right. So I'm going to create a new column, which is called attend times emit maybe plus 10, because obviously depending on the date variable. And then I'm going to call my x times y plus 10 date function. And I'm going to feed into that the attendances and the admissions and the value 10 to sort of run that through. So you can see that actually once you've created a function, you can use it in your sort of dplyr stuff as you go along and create you know, your own functions that do that. So this is, like I say, this is a little bit silly, but if we run that through and we look at our data fun, we can now see we've got this, you know, we've used this function and it's taken our admissions and our attendances and times them together. And if the day of the date was above 10, it would have added 10 to it, which it hasn't done. So yeah, that's absolute bonkers way of doing things. But yeah, we can do some stupid things with that. So okay, here we go. So this is like the worst horrible test for you ever, and really, really difficult. And it does pull together a lot of the things that we've done previously. So I do apologize for this. So what we're going to do is now create our own mean function. So obviously, hopefully you know how to calculate a mean, which is add up the numbers and divide them by what you've got. So we're going to calculate the mean of 3 numbers. But we're not going to use the inbuilt mean function. We're going to do it on our fingers by code within hand. So not using the mean function, we're going to calculate a mean. Okay, so can you create a function that takes in 3 numbers and then just calculates the mean of those 3 numbers? And then, like say, if you want extra credit, can you create a function that will take any number of numbers, so it would take in 4 numbers and calculate the mean of those 4 numbers? Or if we put in 7 numbers, it would calculate the mean of the 7 numbers. So start off with the simple, calculate the mean of 3 numbers, and then if you want that extra credit and be teacher's pet, I don't know, you want to be teacher's pet, that's getting weird and creepy, Simon. If you just want to be super student, yeah, have a go at doing it so that it will calculate it across any length of numbers. And the trick is trying to work out what format of data would you want to feed into that. Yeah, how would you do that? And it's definitely stuff we've covered, but probably a lot previously than you probably would have thought. But anyway, bit of lateral thinking. So yeah, give us a hands up when you've done the first bit, and then I don't know, a big heart or something if you've managed to get the extra credit. I'll tell you what, I'll even send a prize to whoever, if anybody gets the extra credit version. I will take your address and I will send you a prize. Okay, got a hands up, fantastic. So first one, Alberto's going for the prize now. So I can't actually see your hearts at the moment, so yeah. Or just shout in the chat if you've managed to do it. Think you've done it. Fantastic, Sean. We'll let a couple of people have a go. And we want to claim second place in case Sean's got it wrong. Wrong sounds a bit strong. Incorrect. Oh, sorry. Something's... Oh, so Alberto's claiming a second prize, I think. Okay. Anybody else want to put their oar in? So Thomas as well. I don't know, that's for the first. Okay, let's have a look at some solutions then. So anybody wants to posit a solution for the sort of the first method? Don't think it's worked. Okay. So let's create a function for yeah, anybody want to post in their function for adding and dividing 3 numbers? Pop it in the chat and I can share it. There we go. Fantastic. Lean, mean, calculate. I love the very descriptive function name. That's properly brilliant. Love it. So what have we got? We've got lean, green, functioning, calculating machine, where we are taking in X, Y, and Z, or Z, as our variables. We are then adding them up together and into SUMMY. Then we are then dividing our SUMMY by 3 and then returning our result. So yeah, I mean, definitely bonus points for very, very descriptive thing. So let's see, 4, 3, 4, and 5. If my maths are serving me correctly, we should expect to see a mean of 4. Is that correct? And we run that, and indeed, look at that, we get a 4. Anybody else come up with anything wildly different, or even slicker or less code than that? I mean, you could do, yeah, look at this, slicker than that. Who was that? That was Mean Fun. I think that just sums up trying to do this exercise is mean fun. Sum of, oh, hang on. I know 1, 2, and 4. That's why, isn't it? Let's just check the easy version so that I can work it out in my head. 3, 4, and 5. It does indeed give us an answer. So, yep, happy with that in a single line. Anybody else come up with anything wildly weird? Return. Raj, you used the mean function. Raj, back of the class. The whole point was we were not using the mean function. We're designing our own mean function. Failed. Sorry. FF there. You have to start all over again and go
trying
back
to be creative.
No, wrong. Yeah, you've just used the mean function that's already there. I mean, obviously fantastic. Don't reinvent the wheel, you know, bonus points for that. But yeah, just renaming a function that already exists is probably not what we're after. So yeah. Obviously, yeah. Anybody else got anything wildly different or come up with anything there? Did everybody come up with something that at least did that? Did anybody not get that? Or anybody got one that sort of didn't work? And you know, it's good to debug things and try to work out if we can make it work for you, where you went wrong. No? Okay, so you forgot to put in the return bit. Like I said, the return isn't strictly necessary. I mean, if we look at, I can't know who was this one, Alberto's, he didn't actually do a return. I mean, you could have put that in a return there, but just the way that R works the code, it will just automatically return the last thing. So that return is superfluous as far as the code is concerned. It's just probably good practice to chuck it in there just so it looks nice, and we're very explicit about what we are returning. Okay, did anybody got the bonus points? Why do we use the row wise bit in the code? So the row wise in this bit was so if we didn't put it in, let's just have a look. I'll try to remember. I think it, why did we do row wise in that? Because I think what it would do, it would calculate it across the whole of attendances and the whole of admissions and then create it. Obviously it's failed. Why has it failed? Error else. Yeah, so the mutate, yeah, because there's more than one. Yeah, it's trying to do it across the entire columns, and it's not going to work like that. Yeah, So that's why. So what we're feeding into our if statement is 108, which is the entire data set. So what we're feeding into our function would be 108 things out all at once for X, and then 108 things for Y, and it would not like that, to especially sort of come out as a single thing. So yeah, that's why we had to row-wise it so that it did it on each row. If we want to do it as a total, we would have to go that. Anyway, I'll come back to that if we've got time, but that was the basic answer. And always a good idea to try these things out and see what happens and see where it falls over. So did anybody get to a mean function that took in any function? Look at this. Okay. Sean was city mean. Look at that. So we're looking good. So Sean here. So Sean got the bit that was the killer. Is that how do you put in a multiple number of things and then also work out how many things there are? So the answer to that is a vector. So again, so this takes in our vector of numbers, and then it takes the numbers and then divides it by the length. I think I did put a, there was a little bit of a, yeah, there we go. We did, there's a little bit of a clue in there about how do we find the number of things within the vector. So if we run this, we should get an answer of 2.5. And when we can also use city mean, and we could put in a vector of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that will also give us our correct answer, because from our vector, if we did sum of that, we will get the total. And then obviously the trickier bit is finding how many there are. But obviously there was a little bit of a clue there. So, and we run that one, and that gives us our number of things within our vector. Congratulations. So were you first, Sean? I can't remember. I think you were. You have to email me your address at the end, and I will make sure you get your prize. So what have we got here?
Mine one is incorrect. I think no, it's the same as Sean. Mine one.
So what have we got here? So somebody else has done one here. So yeah, you've done it outside of this. Where are we? Mean funds special sum of C. And then, yeah, so that's this one. That also does the job. Who was that? That's Alberto. So yeah, that definitely does the job. So you've done it without explicitly, yeah, obviously you've just got the function C, but again, realizing that you have to feed a vector into it, which was good. Where are we? James has done the same. I mean to. Yeah, fantastic. So I think the important bit of learning in there is that you can feed a vector into your functions, and you can get quite complex around what you can do with them, and then being able to do things like the length of that function allows you to do some quite funky dynamic stuff. So it's not just sort of like data functions that we can do. So a bit earlier we were messing around with the SPC stuff. So if we run all of this little code, we're going to create a plot function. So we want to create a plot for our data set. And obviously what we've done here is we've have it so that it pulls in a variable of site. We're going to filter our data down to the site, and then we're going to do all of this stuff. So now if we run this, it will create mine's all squishy and horrible. let's just run that again. So it will create a plot for this site. However, now if I want to reproduce that plot and just run it for a different site, ta-da, I can just run it for a different site. That's only come out with one plot because the other plot was faceted on type, and this one's only got type 1s, so it hasn't got any others or whatever, the others and 2s, whereas this plot has. So again, if I wanted to, you know, incorporate this within my report, and, you know, I always get really annoyed by the point size. If I want to change my point size and I want to change that to a 2, I only have to change it in one place. And then when I run my new plots now, they will come through with the new things, and I'm not having to tweak each and every plot. So once you've got your plot all nicely set up with all the colors and all your formatting how you want it, you can then call on your stuff. Call on your stuff, call on your function as you want it, and that becomes really, really good to do that. It is good practice not to call on a function, call to a function something that sits outside the function. So again, when we're talking about our scope of our function, the function scope can see what's going on in the global environment. The global environment can't see what's going on in the function. So it does work that way around. So when you've got your like little scope, it can see what's in the global environment. So you can refer to things in the global environment. However, it's good practice to make sure that your scope is its own little self-contained universe, that it sits, all the data and everything that it needs to know sits within its own little thing, so that it is nicely self-contained. So one of the main things that you would do is say that actually I want my data that I'm working on, rather than working on the data that sits within the global environment, I actually pull that into sort of my micro environment of my scope and bring that in here. So I can say for my function here, I want my site to be RF1, and I'm going to give it a default, but I'm also going to call in my data frame, which is going to be my data, and call that here. So actually, you know, I haven't got a DF, which is my data frame, doesn't exist in the global environment. I'm just going to call it in within my micro environment. It also means then if I want to apply this function, lovely function that I've made to a different data set, I don't have to then, I can just change that within the function, and it becomes, again, much more lift and shiftable in that I haven't hard coded it to certain things. And that's really, really nice to do that. And also, for instance, here we've got things like attendances. We could, it's a little bit more tricky to do it, but we could change that. So that's a variable as well, so that our plot function would take, it would, you know, plot possibly the breaches, or it might do the attendances, or it might do the admissions or whatever. And we can make that sort of dynamic as well. That's a little bit more tricky to do, but it's possible. Not going to go into that now, but yeah, we can sort of set that as a default. So we can do this. As I said, I've set the defaults here, so it's automatically working on the data. As part of my little function here, I said we've used df. As you can see, within my actual data environment, there is no actual object called df. So that df only exists within my scope within there. So okay, so we've got a nice little a facet plot for a single site, and now want to do the same plot over a number of sites, or even all of the sites. We could do is create, we could you know, call that for every single site that we've got in our data list, which is possible, but again, you know, that's duplicating what we're doing. So what would be nice is there a way we could iterate over every single site and create that little plot for every single site? and do that in the most sort of efficient, in a more efficient way. So this is where we start getting into sort of potential loops, I believe. So if we run this one, this is exactly the same function, but we've just added, again, we've just added a docstring to it. So as you can see, it's just got a bit of an example of what it does, tells you what the parameters are, what the defaults are, and also tells you of where it, you know, what features it uses. This function filters the data to the provider site. It then uses the plot the dots to calculate plot the dot values and improvement direction, assumed to be a decrease based on the code for each attendance type. Finally, it utilizes the plot the dots to create the plot the dots with specific formatting options, etc. So, you know, it's kind of in there. So that's all good. And then, yeah, creates our plot. So let's have a look at how potentially we could use that function to iterate over all of our sites and create a plot per site, that little plot per every single site, but without having to explicitly type in every single site. So start with some really simple loops. And how long have we got? We've got 25 minutes. Okay, we're going to be fine. We're going to be fine. Look, we've only got a teeny little bit here to go. We'll be fine. So let's look at simple sequence. So we can use the sequence command, which is a very, very simple bit of base R, to create a sequence of numbers between 1 and 10. And as you can see, if I do sequence 1 and 10, we can see that's created a sequence of numbers for us between 1 and 10. So what we can do is create a loop, and what we want to do is iterate through our sequence of numbers, and we want to do the same thing to our number each time. We want to do, again, we're using a little bit of a span, so we're creating a sort of a micro sort of dimension of code. Sure, that micro dimensions probably not the best way to describe. We're going to create a scope of our code, and we're going to feed a variable into that code, and we're going to run that little dimensional scope of code. Stop calling it dimensional, Simon. We're going to run a little scope of code several times, but each time we run through a loop, we're going to feed in our different variable, and our variable is going to be that sequence of numbers between 1 and 10. So the first time we run through it, that it will be 1, and then the second time we run it through it, it'll be 2, etc., etc. So we can write this for statement. So a for statement, and then we say for and I don't know why, it's just a very traditional programmy thing to do. I for iteration, I think, is probably what we start with, and we create a variable which is going to be I, and that I is going to be in the sequence between 1 and 10. So the first time we run through this, our I variable will be 1, and then it's going to loop around again, which is what the loop is, and the second time it iterates through, it will be 2, etc., etc. And what this code will do is we'll say I plus 5, we'll create a new variable called I plus 5, which will be the iteration number and plus 5, and then return a result, which will be I plus 5 equals, and then it will turn the result, and then it will print the result. My goodness me, I think I might probably need a simpler example, but we were going to run through that. So if we run through that, what it will do is spit out a bunch of results of 1 plus 5 is 6, 2 plus 5 is 7, etc. So it's gone through each of those sort of iterations and come out with a result per loop, and then when it's obviously got through all its loops, and then it's done with that. So again, with the curly brackets and scope, so a scope for a loop does have a global scope. So for instance, here we created I plus 5, and if we look here, we can indeed see that we've got an I plus 5, and it's given an answer of 15. which is basically the last iteration. So each time it's iterated, it's overwritten this I plus 5, but it's saved. The latest version will be in the global environment. So a 4 scope does impact on the global environment. So hopefully that kind of makes sense. We can mess about with the sequence. We can mess about with the sequence and come out with all sorts of number patterns if we want to. So the sequence function allows us to create a sequence of numbers that starts at 50, ends at the number of rows within our data set, and then jumps by every 500. So if we do that, we can see, if we go back to our lovely data, we've got 12,765, and then it's iterated through that, and it's created a set of numbers for us, which is really good. So that's great as a sort of a sequence and sort of creating those sequences. So for instance, but what's really nice, and this is where the magic starts, is when we feed in a vector of data. So we're going to create a vector which is Bob, Pete, and Mary. So that's our values. Which is, as we can see now, a vector of values, Bob, Pete, and Mary. And then we can iterate through our vector. So for I in vector, it's going to return a result, which is paste hello, and then I. So the first time it iterates through, it'll be Bob. Second time it iterates it through, it'll be Mary, and then, so Pete, and then Mary. So if we run that one through, we can see that it's saying, hello, Bob, hello, Pete, hello, Mary. So again, we've sort of iterated through, and we've done something within our loop. So we can see that looking at our function, but it's within a loop. So so kind of interesting. So what are we doing here? So yeah, we're just very introducing a list object. So what we want to do, going back to our original ask, is we want to iterate through our function that we've created for our charts, and we want to run it for each of the organization names. However, we need something to stick our result into. So how can we create an object which is going to be a collection of these charts? So R does have this amazing data type object, which is called a list. And lists are just beyond amazing around what they can do. So you can have we can have obviously all our data frames and whatever here, and then we could create a list of our data frames. So we could have data frames within data frames, which gets really sort of inception, mind-blowing type thing, which I'm not going to go into massive amounts of detail here. But essentially what we can do is feed all our results from our loop into a single list, and then we can call them from that list. Which is what we're going to do. So look at this, even though I wrote it back then, is a list object is a super special multi-dimensional thing. See, really descriptive, Simon. Well done, pass, Simon. But you can put a mix of variables, you can put data frames, you can put plots into a list, you can put anything you want in there, and it's quite bonkers around what you can do with lists, and you can do some really clever things well beyond the scope and scan of my brain today. But to start with, what I'm going to do is just create a little start with a list, and I'm just going to initiate a blank list. So this is a little bit different from where we've done variables and stuff. Like always as we've been going along, we've just initiated and set them as we go. In this instance, we do actually need to set a blank list in order to start with. So just going to initiate a blank list, and as you can see now, we've got a new piece of data, which is where has it gone? Plot list, a list of 0, because there's nothing in there. I'm going to create a vector of sites, which will be the 3 sites I want to run through to put my stuff into, and then I'm going to iterate over my vector. So my vector is going to run first time it runs through, it's going to be for RQM. Second time it's going to be RJ1. Third time it's going to be RDD. And then within my plot list, which is my empty list at point I, so I'm going to call it RQM for the first time and then RJ1 for the second time. I am then going to run my plot site function and pop the chart that it outputs into that list. So we can definitely go back to this and make some sense of it. So we can do that. It's going to come up with a little bit of a warning, mainly because I've got an infinite list at the moment, my uninitiated list, and R likes to know how big a list is going to be. So it's just going to tell me that it's giving me some warnings. So now what I can do is I've got this new object here, which if I see my plot list has now got 3 things in it. And now I can call those individual plots by themselves. And I can pull that one, or I can pull that one. What was really, really nice, so if we want to, we could pull all the unique data $org codes and put those into a vector. And I can't spell unique. My coding would be, oh, have I just, no, I've done it again. Right. So now I've got my unique data org codes and created a vector of all the unique values of those. So I've got all of them now, and potentially now I can feed that into my little for loop, which will take a little bit longer to chug through because loops are not necessarily the fastest. However, you've got to appreciate it is making 274 odd things, charts as we go. There we go. And now I can just pick any of these ones at random and pull them out of my plot list. Got a plot. Oh, dear grief, that's gone a bit weird. Maybe because I've got it all squishy, haven't I? There we go. And then, yeah, I can look at, I don't know, RD1. Ooh, what's that doing? Weird spacey things. But as you can see now, I've got a list which has got all 274 plots in them, and I can just call them and plop them into my report or whatever I want as soon as we got. I can see, sorry, in the chat, Dan says, I ran it. I don't know what you mean, but yeah, okay. Oh yeah, so literally, there we go. We've created a vector there. And so yeah, that's just showing you then you can create that vector. We've created that list and we've put all the charts into it and we can sort of pull those through. So actually by combining our little function and having something within a little loop, we can then create huge amounts of charts at massive scale. So if you can imagine that SPC stuff that we just did is calculating SPC plots across 3 different types across 274 organizations. So it's creating just shy of, I don't know, because not all of them have got all sites, but it's creating about 600 SPC plots all in all. And yeah, it took 30 seconds, but see how long it takes you to build one of those in the SPC Excel tool, and I guarantee it will be probably more than 30 seconds. So yeah, the fact that you can do them massively at scale and design them how you want. And again, if I decided, oh, I don't like this one, this is a bit blocky, I could then change it in my function and change the size of it and then just rerun my little loop. And then I've got 600 charts which I've changed one parameter on, and it's changed it across all of them rather than having to sort of copy it and paste my code and do bits and pieces of that. Oh my goodness me, look at that. We have reached the end. We made it. Congratulations to the 20 of you who survived to get this long. You all deserve a medal for listening to me blurble on for however long it is. Double points if you managed to do the introduction to the R the other day, and I've had like 4 half days of me blurbling away. So yeah, looking to build some further courses. really interested to get any sort of feedback on this course. I think I have had various feedbacks about, I mean, it's a lot to cover in quite a short amount of time. I appreciate that. Hopefully though, you've got that script, and you know, with all things, I mean, I do it myself, is that you start building up a code base yourself and go, oh, I've done that thing before, I can go and nick it from there. And you know, you can go, oh, I remember Simon burbling on about this, and I can go back to his code and I can nick that bit out of there. And then you start building up your sort of your code base, and then you know, when you start tackling things, it becomes much easier. There are so many further rabbit holes. I mean, if you want to go down the rabbit hole with functional programming, there's so much more stuff you can do in there. You know, I definitely would keep it simple as best you can. Just kind of understand. Yeah, I don't know. I'll probably shut up. We have got sort of 10 minutes for any sort of questions, or if there's any bits you want to go back to, or if there's any sort of any questions at all, really. Pick my ever melting brain.
Alberto's got a question in the chat if you want to handle it, Simon.
Where's that then? What am I doing wrong? Okay. Let me pop that in there. So what am I doing wrong? That's the first thing here. Oh no, I'll pop it underneath. So you created, so we've got vector here. What is vector 1 to 5?
Yeah, so basically I only took the first 5 sides.
Okay. So does that, what does that do? So that does take the first 5. But when you...
Then I run that, and then if I run plot
so that
list
one's
1, plot
so that
list
one's
2,
happy.
Yeah.
So that one's
and
fine.
Then with the second loop, I would expect to have 5 plots.
Oh, I see. Okay. So length plot list is 274. I think that's because in this horrible factory thing, this is coming through as factors, and yet it's got 274 levels.
Yeah, okay.
So I think it's doing weird, horrible metadata stuff, which is messing you up. I guess if we did as now, how did I flatten it? We did levels, didn't we? So if we did levels plot list, no, that's going to be not right. What do we want? We want as character. Does that? And then we're getting into crazy. So if I did as character plot list, just check whether that works in of itself. Let's get rid of that from bracket. So is that gonna be, oh my goodness me, what happened there?
Plot list is a list of plots, so what you're getting there is all of the data for each plot.
Oh, we are, aren't we?
Yeah. So what that second part says is for every iteration in the sequence between 1 and, well, currently now it's a very long list of characters plot list. Then what you're asking it to return is the whole list.
As character in vector 1 to 5, possibly.
So I think if you went back to your length of vector, so it's our vector 5. Right? No, that's still 274.
Yeah, I think you need to change the for iron at the top one.
Yeah.
So not the
well,
vector subset, because it's not usually the way it works with for loops, is it?
No.
You've got a J instead of an I. Is it supposed to be there?
Yeah. I think it's just calling it. So I is just good practice, is general practice, and generally what we would do if you were setting up multiple for loops, and you do you start at I, and then your next for loop would use J and then K, etc. And that's just a weird programmy thing, and people do that in Python and C++ and various other sort of programmy type languages. It's just a weird thing. So we did sequence 1 to 5. Where are we? Oh, we got an extra bracket missing, haven't we? If we do I 1 to 5, that would print them out, I guess, because that's, if I clear those. Is that printing them? No, it's not, is it? Does that print them if I do it outside? Yeah, that does. I don't know. I have to think about. I mean, I guess if you've created your stuff in a list at that point and you want to print them out, I would probably print them out as you went anyway. I think it's a bit of a an odd thing to do anyway. Is it an I instead of a J? As character vector, yeah, I think that's what I tried to do, and I don't think that's quite right. Other things you can do in loops that you can't do in map per. No, I don't think so. So map and per are alternative ways of doing loops. I think, well, I guess that what you can do is write much messier code that isn't in a function when you're doing a loop. So loops, you do not have to use functions in, as in you don't have to. I think when we were writing stuff up here on our when we built, we didn't do it. When we built our function up here, we weren't using functions, so we were doing stuff like this. So in this loop, we weren't using functions. We were just like coding as we go. If you use map and per, you have to put your stuff that you're doing into a function and then map and per it across your iterations. So the thing that loops, that for statements that per doesn't do, is allow you to write scrappier code. Whether that's a good thing or not, I don't know. And also, I think for loops, they are slower. They are much slower than map and per, but yeah, they do. They are sort of more computationally expensive, and they can take longer to run than do other. I mean, generally, if you can avoid doing it in any shape or form, don't use loops. But sometimes they can be useful. I mean, in this instance, obviously, we're creating this loop in order to plot those charts, but we've already created a function that just plots those charts as we want to call them anyway. All right, so yeah, plot list here. Plot list. Was it 1 to 5? There we go. We'll spit them all out as well. Ooh. And now we see we've got all of our plots come through. So yeah, thanks for that, Alberto. So yeah, I mean, I would definitely recommend not doing plots, because we've actually created a plot function that does exactly what we've got there. What am I doing? Plot site. Oh, whatever it is called. I can't remember what it's called. RGM QM. All right. RQ. I don't know what I've done there. I've messed something up somewhere. But yeah, we've created a function that does it, so there's not any reason really to pop it into a plot, into a loop separately. Yeah, so I would generally avoid loops if you can at all help it, but yeah, it is possible. Any other questions or queries? I guess it's more to be aware of them if you do see them again out in the world in other people's code. I mean, I very rarely, very rarely use loops myself. And there are usually ways of getting around. I mean, the way that R works with its group bys and dplyr, all of that is called vectorized as it works. So, you know, quite often if you're trying to do something, you can just do it within a group by. You wouldn't necessarily want to iterate through that sort of manually within a loop. You know, that group by pretty much is what, you know, it's kind of like essentially it is doing a loop, isn't it? It's, you know, you're telling it to do this thing, but by each group. So that in of itself, that group by function or group function is iteration. Sorry, I've suddenly got hiccups. Okay. Literally got 2 minutes left, so massive thanks for everybody. Yeah, nesting loops. So yeah, you can do that. You can do loops within loops, which again probably makes more sense within sort of mapping and pair scenarios. Definitely you can do that. Again, not necessarily recommended. So for instance, if we had a plot feature here that instead of created faceted plots, it created the plot and then we fed in which type it was. You could do a mini loop that you could do an outer loop that iterated through the organization codes, and then a mini loop with inside that which then iterated through the types and sort of spat those out. So you can do loops within loops, but anything where you start doing that kind of nested stuff can get quite nonsensical quite quickly. So yeah, I guess closing statements. Thank you also very much for making it. That was really, really helpful. Sean, you need to send me an address so I can send you your mega prize for winning. Raj, I guess you sort of semi-redeemed yourself, so I'll let you off. And yeah, thank you all so much for coming.